Ladies and gentlemen, welcome and good morning. We are now at the beginning of the starting of the fourth Waseda Brussels office conference, which will be about new technologies and regulation. I am sure we will have a bunch of very interesting presentations today, and so we'll start immediately. We are a little bit late, and maybe I can give the floor to Professor Gemma, Vice President from Waseda University.
Good morning, ladies and gentlemen, and welcome to the Waseda Brussels conference. I'm Masahiko Gemma, Vice President for International Affairs at Waseda University. It is my pleasure to be able to welcome so many of you to today's conference. To begin, on behalf of Waseda University, I'd like to extend my sincere gratitude to our co-hosts at the Free University of Brussels for their tireless efforts to organize this event, as well as the continued support for the Waseda Brussels office. Especially, I'd like to mention about the great contribution by Vice Rector Anne Weyembergh and Dr. Frederick Poliat for their continued support for our activities here in Europe. And then also I'd like to just mention about the great contribution of the organizers for today's three sessions. Professor Julien Cabay and Professor Tatsuhiro Ueno for the panel discussion one, and then Professor Chiloe Biele, I'm sorry, I cannot really pronounce too well, and Professor Hitoshi Mitomo, Hitoshi Mitomo, and for the great second session organization. And then for the third panel, Professor Joe Barton and then Professor Paul Bacon. These two organizers have been very instrumental for organizing the excellent panel. So we look forward to their active discussions. And then, last but not least, I'd like to welcome everyone and then appreciate, thank you very much for your participation. And then we look forward to your contribution through the active participation and discussions. It has been over 6 years since Waseda University first opened the Waseda Brussels office on the ULB campus in April 2016. Waseda has been engaged in concluding partnership agreements with European universities since the 1960s. And our researchers have continued to actively pursue exchange in a variety of academic fields into the present. As the process of globalization and the movement towards borderlessness have continued to advance in Europe, academic exchange today has likewise diversified and then expanded beyond simple bilateral partnership frameworks between two countries or between two universities or two institutions into trilateral cooperation frameworks and international joint research consortia. In light of this, Waseda University has been seeking to establish networks across Europe with the Waseda Brussels office acting as a hub. In addition, by having access to various projects implemented by the EU and related organizations, Waseda can engage on ongoing high-level joint research with its programs in the region. The first Waseda Brussels office conference was held in 2016. The second one was in 2018, and then third one in December 2019. So it's almost 3 years ago, with this year becoming the fourth one. We are happy that we can hold a face-to-face conference despite of the continued challenges by the prolonged pandemic. The goal of this conference is to disseminate academic and research findings from our countries, and in turn to contribute to society by making meaningful use of these findings. This time, we are focusing on the theme of new technologies and regulation in Japan and Europe, which examine that these three critical challenges regarding the EU-Japan science and technology relations. We'll discuss first interplay between artificial intelligence and intellectual property. And then we'll discuss as a second topic the role of transparency and legal safeguards in ensuring the trust in governmental data collection practices. And then third panel will discuss the cybersecurity implications of emerging technologies. Every topic is important. We are happy that we'll be able to intensively go through these critical issues within one day today. In closing, I hope everyone here today finds discussions insightful and that conference serves to further develop the close relationship between the European Union and Japan. Thank you very much again, and enjoy your conference. Thank you.
Thank you, Professor Gemma, for your very kind introduction to our conference. And now I would like to introduce Professor Anne Weyembergh, who is Vice Rector for International Relations at ULB. Please.
Thank you, Jean-Louis. Dear colleagues, ladies and gentlemen, it is a great pleasure and an honor to open this fourth Waseda Brussels conference together with Vice President Gemma. On behalf of the ULB, I would like to underline how delighted we are with this event, which is a great realization of the Waseda Brussels office, as well as a concretization of the long-standing collaboration between Waseda University and ULB. And I would like to highlight 5 characteristic elements of this conference. First, continuity in spite of COVID. As Professor Gemma already mentioned, this is our 4th Waseda Brussels conference. The first one took place in 2016, second one in 2018, third one in 2019, and this year, 2022. Second element, consistency, and especially consistency in the topics covered. The first conference aimed at launching a new research and cooperation platform between Japan and the European Union, with a focus on inclusion and intersectoriality. The second focused on the future of robotics and artificial intelligence in the super-aging era. The third one was entitled Democracy at the Crossroad, Populism and its Consequences on Political Trust. Well, this year, it concerns a key component of the partnership linking the EU and Japan, namely, as you know, the regulatory dialogue surrounding technological innovation. So today, we will come back to artificial intelligence, but this time to study its interplay with intellectual property. We will, in a way, come back to democracy and trust, but this time focusing on the role of transparency and legal safeguards in ensuring the trust in governmental data collection practices. And finally, we will examine, as you know, the cybersecurity implications of emerging technologies. A third characteristic element of this conference is, of course, its interregional perspective, or its Japanese-European-wide perspective. Each of the 3 sessions has been coordinated by a Japanese-European duo. On the Japanese side, Waseda is of course very well represented, and on the European side, we will listen to scholars of various universities, such as Geneva, such as Strasbourg, Nottingham, Aalto University, Université Catholique de Louvain, Maastricht, Leiden University, etc. The fourth element I want to highlight is the deep, if I may say so, interdisciplinarity of all panels. Lawyers, political scientists, engineers, economists will present their view and dialogue with each other. And of course, such interdisciplinary dialogue is absolutely essential to analyze in depth the opportunities which the emerging technologies constitute, but also to study the new challenges and the new threats they pose, and to unpack the societal implications. Finally, the fifth and last element, which is key as well, is the intersectoriality of this event. As you will have seen in the program, we will of course listen to scholars who will expose their views, but practitioners as well will intervene, including of course EU civil servants and officials from the European Commission. And we will of course also have the pleasure to listen to His Excellence Ambassador Masaki Yasushi later in the afternoon. These 5 characteristics of this conference are also more generally very representative of our Waseda ULB collaboration, which is of great value to us at ULB. So in the name of our rector, Professor Anne Schaus, I would like to thank you, Vice President Gemma, and with you, of course, the whole Waseda University for this long-standing, very rich and fruitful collaboration. I would like also to express my most sincere thanks to the Waseda Brussels office, and of course to Jean-Louis Moortgaat and Clara Olive as well, to Frédéric Pugnard from the Institute for European Studies, and to all academic duo who coordinated this panel. So Professors Cabay, Professors Bueno for panel 1, Chloé Brière and Professor Mitomo, Professor Burton and Paul Bacon. My great thanks also, our great thanks also, of course, to all chairs and speakers of today, and of course also to the Japanese mission to the EU, and in particular to Ambassador Masaki Yasushi. I wish you an excellent conference and an excellent day. Thank you so much.
Thank you so much, Professor Weyembergh, for this very enlightening introduction to our conference. And now I leave the floor to Professor de Werra to start the panel 1.
Good morning, everyone. It's a great pleasure and a great honor for me to be chairing this first session of our conference today, and I would like to start by thanking the organizers for bringing us together, as mentioned a few minutes ago. It's great to be back in person-to-person meetings, because this is really the way how, at least I think, we can somehow cross-fertilize and hopefully leads to interesting discussions. As just mentioned by Director Weyembergh, I think the first panel, as well as the rest of the events, are anchored in key principles, 2 of which are, I think, very relevant today with respect to the topic of the first session, which is this international approach, so bringing together perspectives from various angles and regional traditions between Japan, of course, and Europe, and also this interdisciplinarity, which is key and which is, as we will see, reflected in this first panel. And I think also, to add to that, and perhaps Professor Weyembergh was too modest to mention this, but given that I'm not based here in Brussels, I think it's obviously great to hold this type of event here in Brussels, knowing that the EU, as far as I can perceive, is really developing a very strong policy in terms of trying to manage the many challenges of the digital environment. So I think it's extremely timely and relevant and important to have this type of meetings here in Brussels. And that's reflected also on the program, given that we have people, of course, from the EU institutions joining us today. And I would also like to mention that for us, and for me personally, it's a privilege to be here because this is somehow aligned with what we think is an important bridge to be reinforced between Brussels and Geneva and the international organizations based in Geneva, which are also quite active in digital policy making on various facets, including, and that's the topic of the first panel, with respect to IP, with the World IP Organization, which hosts regular events on AI challenges. So I think it's also important to try to see how we can connect the dots, so to say, and reinforce the bridge which already exists, including thanks to Julien, Cabay, and also André Petermans, who is here with us this morning to see what we can do in order to try to reinforce this kind of European perspective in the digital policy sphere, of course, with other colleagues from other regions, including today Japan. So this being said, so the first panel this morning is about cross-fertilization of AI, artificial intelligence, and IP. As you will have seen in the program, we have a stellar list of speakers and very limited time, as you will have seen. So I have invited the speakers to try to keep the time limit, and I must say I feel quite comfortable with that mission to be the official timekeeper and perhaps the only Swiss representative on the panel. So just an additional warning that I'll be strict, but hopefully still polite in order to keep time under control. This is, of course, a very important and interesting panel, not only because it brings inter-regional perspectives from Japan and also Europe and various angles, but also brings people with various background and expertise, and that's exactly also that essence of interdisciplinarity, which is key in order to try and cope with some of the challenges that are raised by artificial intelligence from an IP perspective. So we will cover, and I will be introducing each of the panelists in the order in which they appear on the program, one after the other when they get to speak. But we will be covering various facets of IP, from copyright to trademark, which is sometimes neglected for erroneous reason, and we'll hear more about this in a few minutes, but also, of course, patent law and other perspectives. So we'll have a very rich and stimulating panel discussion, hopefully sometime also for Q&A and interactions after the presentation. So in terms of housekeeping, so each of the panelists will have 15 minutes for their presentation, max, and then we'll have also some time for interaction. So without further ado, I'll start and give the floor to our first speaker, coming from a hosting institution from Waseda University, Professor Tatsuhiro Ueno, who is professor of IP law at Waseda University, who is truly a leading expert, not only in Japanese copyright law, but also in comparative copyright law, also because he has spent some time and still just spent some time in Europe at the Max Planck Institute in Munich, where we met last time. And he's also deputy director of the Research Center for the Legal System of IP at Waseda University. You have the floor, and you'll be talking about copyright issues arising with AI on the specific topic of text and data mining in copyright law.
Normally it should work. Naturally.
I'm sorry, the computer is still working. Okay. Thank you indeed, Jacques, for kind introduction. It's a great pleasure to be here and to be able to talk to you. My name is Tatsuhiro Ueno. I'm law professor of intellectual property and especially copyright law. So my topic is text and data mining. So to tell the conclusion first, Japan is very much advantageous for text and data mining due to the copyright exception, the very broad copyright exception. So beforehand, I'd like to talk about what text and data mining is. So text and data mining is often defined as the process of deriving new knowledge from text and data. And as you know, the CDSM directive, the directive on copyright and the related right in the digital single market, has a definition of text and data mining. So let me take some examples. So if you analyze a massive amount of the medical articles, you might be able to investigate the underlying causes of health issue, and you might be able to investigate new method of medical treatment. And analyzing a massive amount of recent books or large number of tweets in the Twitter might make it possible to know the future trend or the people's interests, which would be very much valuable for business marketing. So another example is artificial intelligence. If you train an AI through machine learning using a large number of images or texts, you can improve AI systems such as machine image recognition AI or machine translation AI. Furthermore, AI can create works. If an AI has learned all of Rembrandt's pictures or all of the Beatles' album, the AI can generate a new artwork or new musical work in the style of Rembrandt or the Beatles. So therefore, TDM can foster the development of new products and new services. However, if you conduct TDM using a large number of contents, such as images available on the internet, you will copy the data containing copyrighted works or subject matters. Hence, TDM activities might constitute copyright infringement. So basically, you have to obtain a license from right holders to conduct TDM activities. However, in case of TDM using a large number of contents such as images available on the internet, it's highly likely that there are too many unknown copyright holders. Obviously, it's quite hard or almost impossible to obtain authorization from all of right holders. That's why a specific provision, specific copyright exception for text and data mining plays an important role in this regard. In fact, TDM exception is one of the major topics of heated discussion in the field of copyright law. As you can see, there are many articles on TDM exception in the field of copyright law. So let me introduce some examples. So the UK introduced the provision for text and data analysis in 2014. But this provision, as you can see, only applies to the analysis for the sole purpose of research for a non-commercial purpose. So actually, according to the UK IPO, the outcome can be used for commercial purpose, but the original purpose of carrying out the TDM must be solely non-commercial. So actually, UK government currently intends to extend the copyright exception, but still now it's only applies to non-commercial purpose. So next, the CDSM directive has the TDM exception, has a mandatory copyright exception. Article 3 allows reproductions and extractions made by research organizations and cultural heritage institutions in order to carry out for the purpose of scientific research, text and data mining of works to which they have lawful access. Additionally, under Article 4, even if you conduct TDM for commercial purpose, you are allowed on condition that the use of works has not been expressly reserved by their right holders in an appropriate manner. So that means right holders can opt out. So I have to skip about the contractual or technological override, but implementation deadline was June 7th last year. So, and some member states, including Germany, have already implemented the directive, while the others haven't yet. So next, Swiss Copyright Act was amended in 2019 to introduce a kind of TDM exception. This exception applies to not only non-commercial scientific research, but also commercial TDM activities. But a computer program is excluded from this exception, and there seems to be no lawful access requirement. So now, let me introduce the Japanese TDM exception. The Japanese TDM exception was first introduced in 2009, which was extended in 2018. Let me point out some features first. Purpose. The Japanese TDM exception is applicable to not only non-commercial purpose and non-commercial scientific research, but also commercial TDM activities, and the right holders cannot opt out. Second, in terms of allowed acts, under the CDSM directive, reproductions are allowed. On the other hand, under the Japanese law, it is permissible to exploit a work in any way and to extent considered necessary. That means an exploitation other than reproduction, for instance, the distribution or a communication to the public of a training data set containing copyrighted works can be permitted under the Japanese law, insofar as it is conducted for another person's TDM activities and to the extent considered necessary. Third, no lawful access requirement. Under the CDSM directive, it is allowed to use lawfully accessible works. On the other hand, the Japanese TDM exception has no such requirement. Therefore, even if you download a number of movies from an obviously illegal website, you are still allowed to copy them for the text and data mining. So, however, the Japanese TDM exception has the proviso. The Japanese TDM exception is applicable unless it would unreasonably prejudice the interests of the copyright owner. For instance, the Japanese TDM exception is not applicable to a data set prepared for the use of text and data mining. So if we look at this slide, you can find the differences between jurisdictions. But I would say the Japanese TDM exception is much broader than the DSM directive in other countries. As far as I know, no other jurisdiction has such broad explicit provision on copyright exception for text and data mining in the world. Recently, Singapore introduced a broad TDM exception in last year, which can be applied to even commercial TDM activities. But the TDM exception in Singapore only applies to the lawfully accessible works and not only computational data analysis. That's why the TDM exception is not broader than the Japanese one. As a result, you are totally allowed in Japan to copy a number of publications such as books and newspapers or a large number of tweets in Twitter in order to predict the future trend for commercial purpose. Also, you are allowed to copy all of the Star Wars movies, all of the Beatles albums, or all of the Japanese manga or animation without any authorization of copyright holders if you conduct it in Japan for machine learning to create an AI which can generate a new artwork in the style of the Beatles or the Star Wars. So recently, various AI art image generators from text such as Midjourney and Stable Diffusion. As you can see, I tried to input the text, a man studying copyright law at university, so it was generated by such AI system. If you create such AI art generator, you have to train an AI through machine learning using a massive number of images. Under the Japanese law, you were totally allowed to copy the images available on the internet for the purpose of machine learning, even for commercial purpose, even if the images would be unlawfully posted in the internet, and even if the right holder would opt out. So on the other hand, under the CDSM directive, if the right holders opt out, expressly made reservation by embedding the data, the TDM copyright exception doesn't apply to commercial TDM activities in EU. That's why I always say that Japan is a paradise for machine learning. I often say to AI developers, if you like to conduct machine learning, you should come to Japan. So I can recommend you introduce broader copyright exception for TDM also in the EU. But my concern is about the latitude or leeway of EU member states to implement the CDSM directive. I'm wondering if member states may not provide for a broader provision for TDM broader than the DSM directive. However, if I understand correctly, not a few European scholars criticize the TDM exception in the DSM directive, and they are in favor of a broader copyright exception. And in particular, one European scholar says that the debate on the scope of the text and data mining exception in the directive should be urgently reopened in the very near future in the EU. In fact, the UK intends to extend the existing copyright exception for TDM, thanks to the Brexit, maybe. So last week I gave a talk in University of Bournemouth, so we discussed about this topic. But my concern is the leeway or latitude of the member states of the EU. So there might be a great objection against it, but I can recommend it. So to conclude, let me just briefly summarize my talk. Text and data mining is quite useful and to foster the new services or new products. However, TDM using data containing copyrighted works might constitute copyright infringement So relevant copyright exception for TDM plays a significant role. The Japanese TDM exception is much broader than the CDSM directive in the EU. It is quite helpful for machine learning. So I can call Japan as paradise for machine learning. So I can recommend you introduce broader copyright exception for TDM also in the EU. Thank you very much for your attention.
Thanks very much, Professor Ueno, for your very convincing presentation that Japan is a paradise for machine learning. It's actually not only for machine learning a paradise, but there are many reasons why Japan is of course, a paradise. I would suggest, unless there is an urgent question, that in the interest of time, we shall directly turn to our next speaker. I don't see any, or there's perhaps one question from the floor. I guess there must be, you should use a mic. I don't know if there is anyone. There's one. Sorry. Perhaps you could briefly introduce yourself, if you don't.
Oh, no, maybe. My name is Toshiyasu Ichioka from Riken Europe office. Thank you for the presentation. And just quickly, if you could comment on the legal frameworks in the US, China, just for comparison, that would be great.
Okay. US doesn't have no explicit provision for text and data mining. Instead, the US has a general provision for so-called fair use, so which can apply to TDM activities, but not explicit provision. So I think the explicit provision would be better than, especially for Japanese companies. So, and China has one general saving clause in the end of copyright exception. So currently China has no such explicit provision for text and data mining. But 2 weeks ago we had China Waseda conference before coming into here, and the Chinese scholars explained the current debate whether to introduce explicit provision as an administrative regulation, not law, but administrative regulation for text and data mining. So that means the topic is also under discussion, also in China. So thank you very much.
Thank you very much. So we can now come back to Europe and turn from law to technology with our next speaker, who is Lonneke van der Plas. So welcome to you, Lonneke. So Lonneke is a computer machine learning expert, head of the Computation, Cognition, and Language Group at IDIAP, which is a leading research institute based in Switzerland, not very far from Lake Geneva. And she's also associate professor in language technology with an affiliation with the University of Malta. And Lonneke will speak about computational creativity. Lonneke, you have the floor.
Okay, yeah, very happy to be here. Indeed, my background is in AI, and I've had the pleasure since maybe about more than a year ago when Professor Werra visited our institute, and I started thinking about the implications of my work in a law context. And I think this is a really interesting thing. And so we've started collaborations now. I'm very happy to be able to talk to an audience of people in law. So yes, so we're in Switzerland, but after listening to Professor Ueno, I think we should open something in Japan, right? It's a paradise for us. Well, I'll think about it. So I'm going to talk to you about computational creativity today. So first, a little bit of an introduction. What is computational creativity? So it's a very interdisciplinary field. It's based mostly in AI, but it has a lot of overlaps with, for example, arts, as you can imagine, since it's creativity, but also cognitive science, because how are people creative? How can we study the processes of creative thought? and also philosophy. It's been a field that's around for quite some time already, but it started really as a niche in AI. There were very few people working on it. But recently, as you were saying also, you've shown in the previous talk, we saw also how images are created, for example. There's text that's being created. So it's a very booming topic at the moment. So there is an Association for Computational Creativity. You can look it up. They have an annual conference as well where there are many papers. But actually, papers are really spread over different AI conferences. You find elements of creativity in all of these. Well, one thing I think that is missing is law, because there's actually a big role also for law when we talk about computational creativity, when we think about copyright, the data that we're using. All these questions are actually very important for us to study. So a bit more about computational creativity. So it's a very diverse area because there are people studying several aspects of creativity. So on the one hand, there are people focusing mostly on creative processes. How do we get to a creative artifact? So for example, how do we model creative thinking? How can we model that computationally? And also creativity more as a social process. Maybe we should model it as multiple agents working together, coming to something creative, just like you would do in a brainstorming session with colleagues. And then there are people that are not so much focusing on the processes, but more on the outputs of these systems. And then we have different types of outputs. People sometimes create outputs on the textual level. For example, there's poetry, there's stories that are generated, concepts, movie scripts, even puns, there's humor generation as well. And on the other hand, visual. Images, designs, video games, and the last thing, musical composition. So there's a varied types of artifacts, all being very creative, and people are working on those. So the other thing which is an interesting perspective to take on computational creativity is how autonomous these machines are. And you can look at that from the user's perspective, or you can look at that from the developer's perspective. So I've started with the user's perspective. So you have certain systems where I would say it's more like human-aided, computer-aided human creativity. So they're just tools that help you be more creative. And on the other end of the scale, we see machine creativity. And this is where there's actually, maybe you could say, almost no human involved anymore. So it's really on that end of the scale where the machine is creative in its own right. And that's something maybe that, when I say that, you might think, is that really possible? Can machines really be creative? Well, that's a thing that I think, should also discuss. And in the middle, there is the human-aided machine creativity. So where the human is still in the loop, does certain things, makes certain decisions, but the machine is more involved than if we go completely to the left. From the developer's perspective, and that's where I'm working, we have seen a difference in the types of models that we create. So whereas when computational creativity started, computational creativity was more about a developer coming up with some models and also with some rules that they would write down in code. So there was a lot of influence from the developer behind the code, let's say. And nowadays, with the advent of neural networks, maybe you've heard about neural networks, so these are new methods that we're currently using that are highly, highly data-driven. So you just feed them a lot of data, then you have some standard methods often, and you can create really great outputs with them. They perform really well, but the developer is a bit less involved and has a bit less control over these models. They're also often therefore called black box models. So yes, we've seen this shift from going more to the machine being in charge here, also from the developer's perspective. So just an example, I saw this recently, so I translated it automatically from a Dutch source, from the NRC. So there are artists, for example, here this is a theater show that is done in collaboration with AI. So you see all the types that I've just discussed, like so there are some where the machine creates completely by itself. For example, the music I think here was created by the machine, but then other things are also in collaboration with the artist, and it's on several modalities. So there's text, there's video. So this is something that's actually happening now. And the funny thing that you see there is that they were asking the artificially intelligent protagonist, should we create a theater show using AI? And they said, I would really advise you not to do so because it would be the end of humanity and all of that. So it was really funny that it was going against itself. So this can happen. So if we look at computational creativity, I think it's something that's booming. I think we will see more and more of this, so it's very important that you people start thinking about what laws we need for that, because if you look at what they are thinking, it's going to grow like 24.3%, so we'll see more and more of that. So a little bit about my group. So I'm looking at the boundaries of current AI systems, and I'm focusing on language. So I'm doing AI, but basically on textual data. I like to look at different languages. I do cross-lingual transfer, and what I'm also interested in is human cognitive abilities, and this is what right now I'm focusing on. For example, creativity. It's one of the human capabilities, I think, which is very important. It's how we survive through all those changes in the world around us by adapting and being creative, finding solutions. And somehow, currently, these aspects of creativity are really underexposed in AI. So these are a couple of topics that I've worked on: multilingual news aggregation, content creation, question answering, and text mining. So about IDIAP, maybe you haven't heard of it. So we're a research institute in Martigny, in the middle of the mountains in Switzerland. And we are an AI institute that has been around for 30 years. So we've been studying AI even before it was very a hot topic, right? When everybody thought we were crazy doing that. And we have expertise in many different fields of AI. So if you look at that, we have computer vision, people looking more at images, others robotics, machine learning, and we can handle lots of data types: text, speech, audio, images. Then we have several application domains: health and life sciences, very important also in relation to law, security, media and entertainment. And as you see, we have 14 research groups, all focusing on different aspects of AI, and mine is there, the computation, cognition, and language group. So why did I decide to study computational creativity? So I think that currently the machine learning systems, the recent trend that we see in my field is we just give these machines more and more and more data. And this has led to really impressive results in some of the tasks. But there's also a lot of limitations in these systems that you might not see when there's a nice demo by Google. You look at that, you're like, whoa, okay, that's really great. But we know that there are some limitations. For example, they are very brittle. So if there's some change in the distribution, or you go to a different domain, all of a sudden these models don't work very well anymore. So they're very narrow and trained for a specific task. Also, they cannot explain often why they made a certain decision. So what do we do with a system that just tells us, I think it's this, but then you ask why, and they can't explain. Imagine in a health context, that's not very helpful, right? Also for law, I think we really need to be able to explain. So all in all, if you look at these systems, they might do a task very well, and people might be impressed by that, but they're not learning. They're not learning like we humans do in this flexible way where you learn from one task to the other. So they lack many aspects of human intelligence, and one of those, I think, is creativity. So if you look at the threats of current AI systems, like the brittleness, data hungriness, they need a lot of data, they're very bad for the environment therefore as well, there's biases as well, because they just take in the data without thinking and just reflect anything that's in the data. They're not explaining very well. But then the last one, the narrowness, is not really focused on by many people. So the other are actually quite much discussed, but narrowness, somehow people forget about it. And I think that the narrowness is actually very much of a threat, because I've done some work while I was in Switzerland, in Zurich, with a philosopher, and we said, I was working on computational creativity, he was working on ethics, and we started discussing, and I was saying to him, I think there's a big problem with the way AI is used nowadays and how we use it for decision making. So if you think of normal society without AI, there's a lot of processes that allow for diversity. There are people making decisions. Some people make a decision which was just a gut feeling, yeah? So you don't always go for the optimal solution. You just think, well, in this case, I think I make an exception, I do this. So there's quite some diversity going on. But if you think of intelligent systems, they are trained with very narrow objective functions. They don't want to make mistakes. That's how we actually construct them. But what happens because of that is that there will be more and more of the same decisions made, the same data will be generated that way, and they will be training over and over again on these narrow kind of search spaces. So I think that the world could become a very boring place and a very non-diverse place. So I think that therefore we need to make sure that creativity is added, because If you look at filter bubbles and echo chambers where people arrive in, it's also all related to this. The systems are just being trained in a very narrow fashion. And also biases, for example, in candidate selection. If you have a job open and you're using these tools, you can imagine they would go for the safest solution all the time. So what did we decide to do? We thought, well, the first thing we want to look at is concept creation. It's a creative task. People come up with new terms all the time. Let's try and see if we can make a machine learning method that does that. So if you look at how humans came up with safety glass, they started with the ancient Egyptians doing laminated wood. Then probably somebody thought, wood, that's similar to glass. Actually, it's also a material. It could also be made a little bit more strong. So why not do something like putting layers of glass on top of each other? And this is how, at some point, safety glass was invented, and it was patented in 1909. Now, can't we do such a thing also by using a machine, we thought. And the nice thing is there's all these data around with time-stamped data. So you can see that, for example, laminated wood was there earlier, and then there was laminated glass. You can see the mobile phone also becoming very much used at a certain point, whereas the mobile radio was there earlier, but then wasn't such a success. So all of this data we can use. So what did we do? Just to put it in a nutshell, not to be too technical here, we took this timestamp data and we said we're going to train a system, we're going to let our system see everything up until 2009. We're going to create embeddings for that, and these are like semantic, trying to get at the semantics of words. So for example, tea and coffee are similar and water is, but something like a chair is very different. It will learn that automatically. And we take the trends, like what are words that are gaining popularity. Then we have the development set, which we tell what are good combinations. So we say coffee machine is a good combination, we've seen that. But a coffee mouse, I will just do random permutations, that's a bad example. So that the machine can see, good example, bad example, good example, bad example, until he figures out what the pattern is. And then it can predict new ideas. Now what comes out of that? Well, here are some examples. So if you look at the red part is the predicted by the system, and on the blue side you see what is found in the evaluation set. And you see that some things are in the middle, so it's both in the evaluation set and predicted by the system, so that these are very good examples. But the ones that are predicted by the systems and not found in the evaluation set are also not all that bad, right? Maybe there is a menopause anxiety, I can imagine that. Special food for boys, who knows, maybe there's a market for that. There's some weird ones like brain tingle and a knee-length glove. I find that also a very intriguing thing that the system came up with. But the light-emitting lamp, I first had to laugh about it, but then somebody told me, yes, but there are also lamps that are not light-emitting. So it seems that it had a point there. So if we looked also at, for example, the brain sculpting, I could find some pictures on that and even some business model here. There were people also inspired by the term of melting cloud, it seemed. So yes, so we used this technology in our innovator, which was a prototype that we worked on for a hackathon, and then we won this hackathon, so that was very interesting. We had some beverage and food company involved, and they were thinking, maybe we can use that to come up with our next products, because we need to be creative. And I have a recent project that's been funded by the Swiss National Science Foundation, where 2 PhD students will be working on the topic of computational creativity. So, to conclude, I had some points for discussion, which for me are interesting as a developer. So, if we look at data, so the current AI systems are mostly data-driven, but what types of data can we use and how? And luckily, this has actually already been discussed by the first talk, and I think that is very nice to see that in different countries there's different regulations, so that's very interesting to know. But for me, that's always a problem. When I start building a system, I'm like, and now what data can I use? So it was very nice when we had somebody visiting us to help us with that from the Digital Law Center. The other thing is, when you look at a system, there's generally sometimes a feeling of wow when you see what they create. But they're based on neural networks, and a lot of what they create is actually quite predictable by nature. This is how these systems are made. They're made to mimic us. So does originality play a role when we think about what these systems create? And the last thing, that's this this about the autonomy. Can we call creative systems creative in their own right? It's true that we now have machine learning methods that use a lot of data. There's not much emphasis on the developer, but still we carefully choose those algorithms, we choose which data we put in, so we still have, the developer has a role to play there. So how much can we say that this machine is creative in its own right? So these were my discussion points, and thank you very much for your attention.
Thank you very much for your excellent presentation, for your introduction to this complex area with still interesting terminology, including cheeseburger spread, and also your important mission, which is basically to avoid that the world gets a boring place. So this is what we should all aim at. Are there questions, urgent questions for Lonneke, for Plas? If not, I suggest to keep on hold, including what you put on your last slide in terms of data systems and what may come out of that, and turn now to a legal topic, and more specifically a patent law topic, which is AI-generated inventions and patent law. That will be presented by Jean-Marc Deltorn, who is Associate Professor at the International Center for the Study of Intellectual Property at the University of Strasbourg, who has co-founded and now manages CEPI, which is the Center in Strasbourg AI and IP diploma, and who has a very long experience in IP and specifically patent matter, particularly because he has spent more than 15 years at the European Patent Office. So we're very pleased to welcome you, and I give you the floor.
Thank you, Professor. Thanks to all the organizers. I mean, everybody organized the conference. It's a pleasure to be in Brussels today, and I would like really to thank all the Clara and you, Mr. Moortgaat, for the organization. Also, Waseda University, ULB2, and Julien in particular, for the invitation. I'm very happy to talk about a topic probably not so exciting for many of you. Patent law can be very terse, but I think there's a lot of creativity, technical creativity happening in the midst of this patent system. And the previous talk has actually used, I guess, patent as a metric for creativity in technical terms. I'm working actually on those topics with INRIA, so as a computer scientist. That's one side of my work. But I'm not going to talk about this creativity development, but rather the patentability of AI. And 15 minutes is very short. I'll be a bit fast, I guess. I may skip a few slides if you don't mind. I don't need to introduce any more AI. A few years back, we had to go through the motions of explaining what we meant by machine learning. Now, most of you know about it. We know it's something that can be applied pretty much everywhere. So from image processing to speech to natural language processing, as we've seen just before, to creativity, creating new artifacts, art, music, graphical pieces, also text, and applied to controlling machines like a vehicle, for example, a car. Some of these applications can be patented indeed, and we've seen in the last 10 years or about a huge surge in this number of patent applications. That's the number. Those are the numbers at the European Patent Office. They're pretty much the same, not in scale, but actually in the shape of this curve everywhere in the world. So what happened around 2012, some of you know, it's the advent, or actually the resurgence of deep learning. It's a technology that was there before, and as you can see the numbers, AI, this curve shows the number of filings per year in the core classes related to artificial intelligence at the EPO, and you see there was AI before the 2010s, but something happened around 2010s, essentially the conjunction of lots of data available, lots of cheap computational power, and a few tricks, I would say also algorithmic tricks that enable to train bigger models capable of answering to more complex questions, practical questions for the industry, and that led essentially to that AI, I would say, hype. There's a bit of hype also, but a reality in terms of industrial application as well. We see that in Europe, we see the same trend with a variation in the 90s, where there was a bump already in Japan. essentially due to a funding of the 5th generation computer project that injected a lot of money into expert system, more symbolic side of AI. Today we focus more on machine learning, where machine learn the rules essentially based on example, not necessarily based on the rules elicited by human beings. So patents on AI are there, at least at the filing stage. What do we do with them? That's the big question, and there's a bit of a challenge there. And the pickle is that essentially an AI object, AI first is a very ill-defined word. It's an umbrella term that covers many, many different concepts, some philosophical, some very practical, but as a technical object, it's essentially a multifaceted hybrid object. It's a bit of a chimeric object. You find data inside, mathematics, algorithms, essentially code, software, but also practical applications and parameters, data structures. All those things make it a bit more complicated than traditional technical application, traditional technical objects to patent. Why? Because, for example, data can relate to collection, pre-processing, labeling. When we talk about supervised learning, we need to label the data to tell if there is a cat in the image or a pedestrian in front of the car, and that is done by human beings. That's really part of the value of the pipeline, it's the quality of this annotation. The learning process is essentially driven by code and algorithm. The architectures of this model is very important, and that leads to a model, a trained model, which is essentially a parametric set together with a particular architecture that needs also lots of works in terms of validation, sometimes updates, sometimes retraining or transferring to other modality from text to images, for example, and also work in terms of access through application programming interfaces before it's been deployed in the world through application. Some are technical, some are non-technical. And all those issues, in a sense, this sort of progression in the pipeline of the AI system and its deployment raise issue in terms of training data, algorithm code, data structure, and application. And the question that we would like to ask ourselves is whether some at least of those segments can be patented, protected by patents or not. Of course, some can be protected by other means. You know, we see copyright resonating with software, for example, and we'll see there are also other means of protecting maybe computer-implemented invention with patents. That's an interface we'll talk about in a moment. I'm going to focus today on the intersection, or in a sense, the comparison between the Japan and European perspectives. And that's essentially the core, the gist of the topic, and highlighting the fact that there are similarities at a certain level, but also disjunction and dissimilarities at a different level. So I would like basically to emphasize in the rest of the talk all those aspects, focusing first on the overall, so taking really a step back and looking at the broad picture of patentability. I mentioned those hurdles, where in fact in Japan and pretty much everywhere in the world, you can decompose the patentability process into two big chunks, two big blocks, two hurdles. One has to do with the eligibility of the subject matter. There should be something patentable in the first place. How we define it, we'll see it in a second, may be different from Europe and to Japan, but essentially as a concept, that's one of the first essential building blocks of the patentability construct. That's the first hurdle. The second hurdle, once you've passed it, and only if you pass it, you go to the second one, and the second one is a conglomerate of different conditions. Novelty, a patent has to be novel to be granted, but it also has to meet a sort of condition of inventive step, which is a rather subjective. We try to objectify it to make it a bit more processual and clear and transparent, and we have different recipes across the world in order to solve this issue. Not always super easy, but we try. And that's going to be the focus also of that second part of the talk on that second hurdle. I won't talk much about novelty and industrial applicability. Honestly, there's not much issue there, but there can be problem related to inventive step. I've just listed for reference the law related to those notions in the EPC and the Japanese Patent Act. But it's just for reference, for the definition, the EPC and the Japanese Patent Act for inventive step is pretty much identical. You've got references to a legal fiction, a person having ordinary skill in the art. That's going to be the sort of the metric to measure that inventive contribution. So we create that personal, that fictive entity, and we're going to try and see whether, with respect to that person, the invention, the claimed invention, is indeed meeting the criterion of inventive step. So the first thing, and going back to the first hurdle, is whether or not there is indeed an invention in the first place. Well, the EPC, and it's often the case in law, shoots on the side. I don't know exactly the term in English, but we don't answer directly the question. There is no definition in the EPC, the European Patent Convention, as to what an invention means. We just have a list of non-exhaustive lists, actually, of non-inventions. I'll come to that in a second. And that's a big difference with the Japanese Patent Act, where indeed there is a definition, a positive definition of an invention as a highly advanced creation, so the creativity part is already there, of technical ideas utilizing the laws of nature. It's a very broad construction, of course, but it's a positive definition. In Europe, we didn't dare. We didn't want to be sort of caught in that sort of crystallized definition, and you can find that in the origin of the text of the EPC, people refusing to actually even mention the definition, the positive definition. What we did in both cases, actually, is mentioning a list of non-inventions. So we defined it by excluding, by paving a perimeter in the negative. Of course, it's not complete, because there's plenty of holes in that sort of Swiss cheese there, but actually we have an idea, we get a sort of an emergent idea of what a non-invention is. Mathematical methods, very important for AI, are not inventions, and they should be free roaming. Scientists amongst you should be able to use discoveries, mathematical formula at will, without them being monopolized by a particular proprietary model, patent, for example. The same is for computer programs, actually, as such. And I come back to that notion of as such, because those objects, mathematical methods, methods for performing mental acts, are excluded from patentability only if and only if they are claimed as such. So only very, very narrowly, in a way. The Japanese Patent Act has a positive definition, has also a list almost identical, I would say, to the exception of the programs for computers that are treated separately, and we'll come to that also in a second. So how do we pass this first hurdle in Europe and in Japan? Well, there's a bit of a difference, and I'll show you the difference here. At the EPO, we consider, as I mentioned before, that, for example, a neural network is a mathematical construction, is actually just mathematics, an algorithm. So a method for training a neural network would be actually non-eligible for patentability. That's excluded from patentability. But a series of decisions, in particular this one, Hitoshi, highlighted the fact that the presence of any technical means associated with that algorithmic object makes it patentable, makes it actually pass that first hurdle of eligibility. So it means that if you create an object, for example, an object called a computer-implemented method for training a neural network, you see there's no much difference with the previous mention, that would be considered eligible. So you see that first hurdle at the EPO, at the European level, is very, very low. It's very easy to circumvent when it's a method, all right? The Japanese Patent Act actually says a slightly different story. Actually, it tells a story where indeed the fact of associating a technical entity, for example, a computer, to another non-technical object, for example, a neural network, may not be sufficient. And in fact, at the Japanese level, it depends on the context of the law. It depends on the application of that particular association between the computer, if you will, and the neural network to a particular subject matter. So it's very much on a case-by-case basis that this eligibility hurdle will be met at the EPO, whereas actually in Europe it will be more straightforward and more easily predictable in a sense. So that's actually a first difference. And when we come to computer programs, actually they can be patented if they meet a certain standard as well. They're not exactly seen as computer program as such, but they can be associated with other entities, other technical entities, and if so, if they meet certain conditions where the computer program goes beyond, the use of the computer program goes beyond the normal physical interaction with the electrons, if you will, in the computer. For example, it controls a machine or it interacts with another entity external to the computer, then in that case it creates a further technical effect and it's deemed eligible at the EPO, and it's pretty much the same, not worded exactly in the same way, but the spirit actually is the same at the Japanese level, where indeed when information is processed by a software, and if it's concretely realized by using hardware resources, be for example it by controlling an apparatus or by modeling an object or using information concretely defined in the object, physical attributes of the object, and the use of this neural network would be deemed eligible as well. So you see that for at least for the part of the computer program, there are slight similarities. So when you've passed that first hurdle, and you can do it both at the JPO and EPO under slightly different conditions, you've got to go to the second bigger hurdle and try to see whether your invention is actually meeting the standard of inventive step. And here, actually, it's slightly more complicated. First, talking about the EPO, I mentioned this mixed type invention that associate algorithm, for example, and hardware, a computer. And the second hurdle of inventive step actually try to answer how to treat those mixed type invention, those AI invention, follows a methodology established in the case law. So actually, after sort of trying to understand how to approach these objects, we identified a particular type of recipe now sort of set in stone in that particular decision called COMVIC, that tells us in a way that we have to look at those invention in context. We can't just like cut in slices the algorithmic part and the non-algorithmic part. We have to take a step back, take a bird's eye view of the invention and see all those pieces together. It's essentially the gist of that decision. So all the features that contribute to the technical character of the invention must be taken into account to evaluate the inventive contribution. That's a very important decision that has been also validated recently by an enlarged Board of Appeal decision a couple of years back. So now actually we see it as a reference, and the way we depict it in a way is that by looking at the closest prior art, so that's the red part, the invention will be the sort of somewhere defined by that dark ellipse there on the left. And we would separate the non-technical component, the one that don't contribute to the technical character of the invention. Those one cannot be the locus of an invention, and focus essentially on the top part, the one that are essentially contributing to the technical character. I'm not defining yet what that means, but essentially that will be there that an invention can happen, only there. That's the only place where the invention can happen. And only those features can contribute to the assessment of inventive step. The issue, of course, is that the case law needs to define what we mean by technical character. So in Europe, again, how do we answer that question? How does an AI can contribute to the technical character? We sieving through the decision of the case law of the Boards of Appeal. There are only two axes. The first one, if the AI is applied to a specific hardware, essentially, that's the idea, so specific technical implementation, and that's okay. In that case, if the AI is specifically adapted to a specific computer, it meets that standard of contributing to the technical character of the invention. And the other side, if it sort of meets or focuses on serves a technical purpose. Technical purpose is very, very, very broad, actually. So we don't have, again, a proper positive definition. We need to look at examples. Just an example could be if a specific neural network is helping your car to brake better and save lives. In that case, you would not like to discard that particular application, that conjunction. It's a bit like a yin and yang component. You've got the algorithm that serves a specific purpose. And the use of the algorithm is actually only meaningful in conjunction with the application. So, but the the sort of the grouping of those two notions together serves an industrial purpose, and for that reason could justify a patent. You wouldn't like to discard the second, the bottom part of the slide here, the neural network, improving the efficiency of an ABS or a pacemaker or medical application and so forth, just for the simple fact that there is indeed some neural network lying around in the patent. There are many at the EPO, many technical applications, though, that are not deemed technical. And that's also a big component. I'm listing some of them, and one is natural language processing, so I'm sorry for IDIAP. But there are many issues, and Lonneke, where actually classifying text or basically annotating text data would be considered as essentially semantics. Not Chomsky exactly, but close to. And for that reason, we consider it not patentable. They would be disregarded. Going a bit fast for the AI patentability condition in Japan, showing you that it's different there, because in that case, we don't make that separation between technical and non-technical features. All the features, technical or not, will be taken into account and can be the locus of an invention. And you see that's a major difference between Japan and Europe. Here in that case, the contribution at the inventive step can come about from many different sides, including non-technical ones. So we don't proceed exactly the same way, and that's making a very interesting, actually, difference. I'm not going to go through all the text here, but just giving you an example. For example, you have here an application where you have a data set, training data, where questions have been labeled. A question, for example, about the weather would be labeled about a topic corresponding to that question. And the idea is to detect dementia. You see, if you're a patient suffering of dementia, you may answer a particular question off topic. I'm asking you about the weather, you're answering about your, what you ate at lunch. And that's maybe a trigger to identify signs of dementia. So you could build your data set and annotate the data painstakingly, it's very long, and build a model that can able to identify signs of dementia. You can build a model that includes speech recognition, that translates speech into text, and so forth. And the novel part, if you imagine that the novel part of that application lies in the annotation of the data set, for the Japanese system would be sufficient to grant, in a sense, a patent and to make that system inventive. So that would be okay in Japan, because even though that system, that part is actually semantics, if you will, human annotated data set, that's okay in Japan. That's not okay at the EPO, not at all. That would be completely refused by the EPO. So you see that's a major application. I will finish, if I have a second, 1 minute only, I'm not sure about the time, but I'll let Jacques.
You're running behind.
I'm running just behind, so I'll finish on that.
I'm generous.
All right, that's cool. I'm just 1 minute behind. And the issue is about reproducibility and enablement. It's a very important one, essentially in light of AI, because AI makes many things, and you're never always sure it's working. As it's been said before, we have all those fantastic statements about the efficiency of AI, but they're very brittle. They're creating a manifold, they're interpolating between existing data. Are they good enough? Well, it depends on the quality of the validation. And sometimes we don't know exactly how good they are. So that also poses issues when you want to validate that enablement and reproduce the invention. You claim you have an invention, is it really working? And here the EPO and the Japanese work really hand in hand. Really, we have the same approach. We see AI, in a sense, and patent as an issue in relation to enablement, the capacity to reproduce the invention effectively, and we're making sure that indeed we're very, very cautious to exclude only speculative patents. So I'll jump over the next slides, just examples about that particular aspect to conclude, telling you that AI can be patented both in Europe and Japan. There's slightly variation. The ratio between the first hurdle of eligibility and the second hurdle of inventive step are not exactly at the same level. Overall, there's a lot of commonalities, but there's also an essentially renewed focus on that notion of reproducibility that's related to what we call the patent bargain. We give a monopoly to inventors in exchange of disclosing the invention properly, and I have to do it at a level so that other people can reproduce the invention. If they don't do that, they don't meet that particular bargain. last word to conclude. I've been lucky enough to participate in many, many discussions when I was at the EPO with my colleagues in Japan. I'm actually going to Japan in 2 weeks' time also for different purpose, actually related to IP. And I've seen actually something very interesting happening at a level where you don't see it before. I mean, you don't see it usually. It's something a bit that's still in the backdrop, actually. It's the construction of those soft laws, those guidelines, those directives, that at the end of the day, in a sense, give flesh on the positive law, on the regulation that sometimes are a bit elliptic. And that has been done, in particular, using AI as a stepping stone, as a catalyst to rekindle some of the relationship between those offices. And I think what has happened in the past years was very exemplary in that respect, so that we could work together to, in a sense, build a new law, or actually interpretation of the law of AI, and that's still an ongoing process on different topics related to emerging technologies. So the idea is, in any case, to incentivize innovation. That's the purpose of patents, and we do it through those meetings by improving the legal certainty associated with the AI application. So thank you very much, and sorry for being too long.
Thanks. Thank you very much for leading us through this very interesting, though complex, issues of patent law, which are sometimes overshadowed by the issue of AI ownership of patents. And now we are leaving aside patent law and moving back to copyright law with our next speaker, who is Alina Trapovin, who will make a presentation on the topic of AI-generated works and copyright law. So Alina Trapovin is assistant professor in law on autonomous system at the School of Law of the University of Nottingham. She has written her PhD thesis that she obtained at Bocconi University in Italy on that very topic. Before joining academia, she has had a very diverse and outstanding experiences in various fields, including at the EUPO as well as in private practice. So it's great to have you with us this morning, and without further ado, I'll give you the floor.
Thank you. I know we're a bit short on time, so I'm going to skip through some of the things that I thought were a little bit obvious to all of us. But now that we're talking again about AI and copyright, I want to raise the question again of why are we still talking about AI-generated output? So I started my PhD in 2016, 17, I think, and then everyone was talking about it. There was a big boom among legal scholars, among IP scholars, and then, as you can imagine, for a PhD student, this was a nightmare, because everything that one wanted to say on the topic was already said. So we are in 2022, there's been a pandemic, and we still talk about this. And we still talk about this because there has been some very interesting reports actually coming from an institutional perspective on the topic. And the debate is not closed. Some laws have been reformed, some other proposals have been put forward, and academia is still quite active on it. Now, I want to take a specific angle on this topic. And I have two sides of this research, and I would leave the normative one for later for coffee and discussions and maybe over the reception. But the substantive question of my work looks at the output issues only. So we heard earlier about the TDM issues. This is completely not the focus of these next 10, 15 minutes. And related rights, sui generis rights in copyright law are also outside of the scope of my work. What I focus entirely on is European copyright law or copyright law claims on the output of all of these complicated computational creativity processes in the field of art. The conclusions that I make are mainly for the field of art, but they can actually be exported a little bit more to other creative industries. What I have done and what I'd like to show you a little bit is this dissecting exercise of the machine learning process in the context of computational creativity or generative art. There's an important disclaimer to be made in advance that, as we all are very much aware, none of these, there's no one-size-fits-all model here. The machine learning model, if we want to be a little bit more precise, and generative adversarial networks and whatever we want to call it, is not a monolith. It changes all the time. But nonetheless, I have managed to identify some features of this master algorithm that keep reappearing and that can have certain very important implications for copyright law. So the main question is, who is actually the author of those creative, beautiful outputs that we get at the end of these processes? This matters because the person who is the author commercializes these things, they sell for a very high price, markets move, there may be a market failure, so laws may need to be adapted. I don't want to say have to be adapted, because you'll see that my conclusion is actually completely the opposite. Okay, what I have done on the basis of this dissecting exercise is to map the authorship claims in the process, mapping the copyright authorship claims. So starting with the law here, I'm not going to dig too much into this in the interest of time, but there are, broadly speaking, from a European Union perspective, there are 3 protectability criteria that we should always look for in order to give a valid copyright claim at the end of a work. First of all, we need a human author. So this is the designation. We cannot give copyright to an animal, to a machine. We need human in flesh. The second one is that goes under the second and the third benchmarks go under the bigger basket of subsistence. So we only give copyright law to a work that reflects this human author's own intellectual creation. And we need to look for these creative and free choices that human author actually imprinted into the work. And the final requirement, the final benchmark, is that of objectivity. So whatever kind of work we have at the end, it has to be objective, it has to be clear, it cannot be constantly changing, because we need a certain degree of certainty for creators, for artists, for the market, for everyone to know what is actually protected with copyright law. It's bad enough that copyright is an unregistered right, so at the end of it, at least we need some sort of objectivity. So, what have I done? So from the beginning of my work, I have been basing my research on a study carried out at the Harvard Law School's legal clinic at the Berkman Klein Center, where they have identified very helpfully 3 main pillars in this computational generative art process. The input pillar, the learning algorithm pillar, the trained algorithm, and then the output. What is interesting compared to the systems that we had before, and here I'm very happy to be corrected as I'm not coming from a technical perspective, but what I find interesting and different is that previously we would assume that whatever kind of computational creativity we had contained one algorithm in the middle, one software, one technical piece. And then, there is the user in the beginning, there's the coder at one point, and we have an output. What's interesting to see here is that we actually have 2 algorithms in the middle. They often get conflated. Sometimes they're called differently, but there are 2 stages. Now, to walk you very quickly through these different stages so that I can come to the mapping exercise, the input is easy. The input is all the existing artwork that we want a system to learn from. We feed that into a system. This is the very first stage, where you have a team of people collecting the work, curating it, cleaning it up a little bit, deciding exactly what goes into the system. The second stage is this so-called learning algorithm. And this algorithm is actually the one that runs through all the inputs and identifies their relevant characteristics. Now, this can be an off-the-shelf algorithm, this can be something proprietary, it can be open source, there are things that are currently freely shared around. The third stage is actually the most important and difficult and novel one to approach from the machine learning perspective. This is the trained algorithm. The trained algorithm practically is the information that the learning algorithm has extracted after having operated on the inputs. So it is a very, and I see people nodding, so I see that I'm not saying something completely wrong here. This stage is unique to every single process. So in the sense that if you run the same learning algorithm on different types of input, you get a different trained algorithm, and the other way around. And importantly, it is this trained algorithm that generates the output. And the output are these new computational creativity works for which we wonder who is the author. Without spending too much time here, because this has already been mentioned before, this is the most important and novel, but I wouldn't want to say in a patent sense, novel stage. But this is what we want to dissect a little bit more. At the stage of the trained algorithm, we have an architecture, and usually when we talk about neural networks that are these methods that generate usually these kinds of works, we are concerned with neurons and weights. So without going too much into this, this is a very different thing to what we had before with traditional programming. The architecture is something that is developed prior to the entire training process. So it's fixed, you may be able to identify a developer, you have a human author there, so copyright may not be that difficult here. What becomes particularly tricky is the analysis of the copyright authorship when it comes to the neurons and the weights. These things are automatically optimized, so in the process, there is no human that runs through these every single second. At the same time, these are mathematical functions. We have just heard this from the previous presentation. So the copyright lawyer's bells should already be ringing, and copyright does not subsist when we have functions and mathematical calculations. Now, this is what I have done on the basis of these two benchmarks. So to explain a little bit the colors, before we actually get a valid copyright claim, at every single stage, the process has to be white, basically. Wherever we have yellow, we have a yellow light where the copyright claim potentially fails. So starting from the input, how am I doing on time, by the way?
You have 10.
Okay, so I can slow down a little bit.
You have 5 minutes.
So starting from the input stage, this is, as I said, the moment where a machine learning team sits down, collects all the works, maybe they curate it, maybe they clean it up a little bit and organize them in a way that they want the process to work. Do we have a human here? Maybe this is done by a team of human machine learning programmers. It may actually, however, be done automatically. If this is done automatically, the copyright claim at this stage immediately fails, because as I mentioned earlier, copyright subsists only when we have a human author. But let's say that this is done by a wonderful team of machine learning experts, the human stage is passed. Whatever kind of selection and curation this team does has to, however, be a creative selection, has to employ certain free and creative choices. It cannot be, okay, let's have all the pictures of dogs that are there on the internet. There has to be some thought. But so possibly there might be a copyright claim at this stage, but that claim is only limited to that specific stage, to the collection and the organization. The learning algorithm is the next moment of our exercise. Here, as I said, this might be a proprietary software. If it is a proprietary software, copyright claims subsist in it, so we don't have too many issues here. I'd like to spend the last few words on the trained algorithm. Now, the trained algorithm is composed typically of an architecture which is predetermined by a human developer in advance, so we tick the human box. But we also need to understand whether in designing this architecture, the human developer actually employed their own creativity. So in a copyright word, have they employed free and creative choices? It may be the case that they have employed free and creative choices in setting up this architecture, but one needs to be very careful as to the technical constraints that they had whenever they were setting up the architecture. Because functionality and copyright law is a very tricky aspect, and we have some judgments from the Court of Justice saying that when you have technical constraints, the room for creativity may not be that wide. There's an argument, there's an interesting discussion to be had here. Turning to the weights, so the weights, remember those connect the neurons, so the neural networking processes, these are actually set up automatically. So we don't have a human, we probably don't have free and creative choices, so there's no author, so there's no author's own intellectual creation, and these weights, this numerical value changes constantly. So actually, here even the objectivity benchmark is not met. And in fact, this is the stage that produces the final output. So my claim here is that whenever we have that kind of processes, we have to be very, very careful when we say that these things are protected with copyright law, because there might be a stage where the originality idea, the originality claim is so far stretched that copyright does not subsist. Finally, in the output, if you have the machine learning team actually curating a little bit this works and preparing it for commercialization, that's where they may be able to stamp their authorship. This was the substantive part of the analysis. Normative question, I'm not even going to touch it, but I'm just going to mention it. If we say that on the basis of this analysis, copyright does not subsist in generative art, coming from these processes, should we actually open up our copyright systems for this? And in the European Union, my answer is no. I have a draft paper currently under review to explain to you why the internal market is not the best competence that we should use here, but this is a talk for another time, and with that, I thank you.
Thanks very much, and I think you're raising a very important issue, which is to make sure that we lawyers discuss and are reacting and trying to conceive legal approaches on the right facts. So make sure, and perhaps that's going to be a topic for discussion later on, and you perfectly addressed that. Now we're turning to the final topic of this morning's panel, which is trademark law. And we are starting this topic from a legal perspective, thanks to Professor Anke Moerland, who is a professor of IP law, associate professor of IP law at Maastricht University, where she has also submitted her PhD thesis, and based on her academic activities, one could see and also admire the breadth of her interests, ranging from copyright to patent, also to geographic indication, and she will speak this morning and share with us her thoughts on AR and consumer experience in trademark law. You have the floor.
Thank you very much for this very kind introduction. I would like to really thank the organizers for having me on this excellent panel. I have enjoyed every single presentation this morning so far, and I hope I will not disappoint you with the next excursion into a different field of IP law, which is indeed trademark law. And it is very nice that I'm able to speak here, because it often is one of the areas that is a little bit neglected in the light of artificial intelligence, but I hope me and Julien and Tom can actually convince you otherwise. So the topic I've chosen is also a paper I've recently written, and it's going to be published very soon, is about the question in how far does actually AI-assisted shopping behavior by consumers still can let trademarks fulfill a function on the market, because actually trademarks are there to fulfill a specific function. I will tell you about this. And once we've tackled that question, the second question is, we also have a certain conceptualization of the consumer who operates on the market in law, particularly trademark law. And the question now is, with the new AI tools that are at hand, does this legal concept still fulfill the purpose that we actually have when we are looking at what we want to achieve with trademark law? So it's a bit more abstract, a bit more legal, so I hope you bear with me, but I'm happy to go with you first through the technologies that we have looked at for online shopping that are currently being used. And then second, I want to look at the functions that trademarks so far have fulfilled, why we protect them, because IP rights generally are monopolistic rights and we need a good justification to have them. And if we agree there is still a role for trademarks, then we need to think possibly about the concept that the consumer now in an AI-assisted shopping commercial behavior displays. So when I look at these technologies, and I'm so happy we've had the previous presentation as well, there are many forms of AI. And obviously the most advanced form is arguably machine learning. But nevertheless, when we are looking at some of these tools, we need to consider there's different technological advancement in there. So the one AI tool does not do what the other AI tool does. And also human bias is one of the things that is still a matter. I will come back to that at the very end of the presentation, that actually for consumers is very important to know and to consider that what comes out may actually be different from what his or her own preferences really are, because someone has programmed the AI, someone has fed it with training data, we've heard this before, and so there can be still some human bias as well. The other criteria that we have used to actually categorize some of these technologies are the different stages of involvement in the purchasing process. And here we follow Michael Gull and Niva Elkin-Koren, who have defined 4 stages, the first 4 in their algorithmic consumer. So the first stage is to determine what are the consumer's preferences. Second is to go on the market and look at the options that are out there. Third is to actually combine the two and then propose the best fit. And the fourth is to complete a purchasing transaction. We have added a 5th stage, namely that where the consumer actually consumes the product and provides feedback for the next purchase that then will take place afterwards. So let's have a look at the first, which are product recommendations. We all know them, and you now also see some of my preference of buying kids' books and yoga equipment. When we are going to retail websites like Amazon or Zalando, you will see recommendation based on your previous order or complete the look. And these are, of course, based on either what the same consumer, has previously purchased or put into your shopping basket, or where your mouse hovers over for a rather longer time. This data is collected, and then next time around you will be presented with such options. Or of consumers with a similar profile, and where consumer ratings are basically similar in that regard. In the end, I suggest that these types of technologies are pretty much involved at stage 1 and 2, so they determine your preferences and they compare what is out of the in the market and provide you with some options, and you still make a decision. Second, virtual assistants. You also may know Google Assistant, Pepper the Robot, or Alexa, who actually are able through text or voice interface to reply to actually any kind of question that the consumer has throughout this purchasing process. At any time, they can identify options, they can tell you the delivery possibilities, the payment, and so forth. So here, already a stronger involvement is visible, where also the actual best choice type of idea. This is the type of product you should buy, seeing your preferences and the options, is a bit further, stronger involvement. So nevertheless, the consumer still makes the final purchasing decision. And then you have automated ordering. That is the most advanced form that is so far available only for a couple of products. So typically this would be printers, this would be dishwashers, or other devices in your household that have a particular feature that you can activate, and then certain brands that are connected to that service will be ordered when the ink runs low, for example, or you have otherwise defined on how to do that. Here there is a full involvement. So even when the purchase has to take place, it's not the human consumer who does this, but actually the device that you activated to do so. Now, that was my introduction, and now I want to look with you at the trademark functions in the market. So typically, trademarks fulfill a shorthand indicator function. We see a brand on the market, we are either familiar with it because we have already bought the product, or we have seen a commercial, or your friends that you very much like purchased the same product. In any case, it tells you in a very simple and effective way what this product is. This was useful because it allowed for speedy and effective purchasing, reducing transaction costs. Do we still need this when you have Alexa telling you what the best choice is and actually, going in the market with much quicker information gathering and analytics? Maybe not. So maybe for that purpose, trademarks are actually not anymore needed. However, there is an element where the trademark still contacts the consumer, even with the automated ordering, and that is at the very final stage, that of consuming and actually experiencing the product, where we see, feel, and maybe eat the product, and then we have experiences about this product that will feed back in our next purchasing process. And that's useful, because again, then our preferences are better defined. That's effective. So for that last stage, it does make sense. In addition, trademarks are about having a fair competition on the market. We don't think it's fair that someone just communicates to your consumers using your brand, your trademark, while it's not the right owner. So we still see that there is value in correct and not confusing information on the market, even though AI may at one point be so sophisticated to identify counterfeit goods very well. We'll hear in the next presentation that still image recognition may not yet serve fully that purpose, but we may get there, that actually we can. But that doesn't mean we should allow it in the very first place just because there are AI tools on the market that can identify counterfeit products. Last, the other function that I want to talk about is those types of brands that you purchase not only because the product is very good, but because, for example, Apple has a certain design that appeals to you because it is a way of living. It's defining a certain type of status, and you just enjoy buying these types of products because they give you more than just a good product. And these positive values and feelings, we also protect these. We see a role for those types of communication, and that's why trademarks could still do that, because we believe that the AI cannot translate that type of feelings to the consumer. And the more we are invested in that product, again, your preferences will be fed back into the next purchasing process, making that again effective. That's very short about the functions. I want to dedicate the last 2 minutes to the idea of how do we see the consumer at this point. And I think here I heard also before, cognitive science, cognitive psychology is the type of discipline that actually has something to say about how consumers behave on the market. So I guess people generally agree there are at least two ways, but it's a spectrum, of course, but the outer edges are an unconscious rapid decision making for things that are common to you, that are more background information, you just on autopilot do things, or things that are new, that are unexpected. There, you need to think about it, it's a bit slower, and you're actually going to weigh what is in front of you to make your decision. So, in fact, the legal concept that we are using in trademark law of a well-informed, observant, circumspect internet user for internet purchases is not always the right thing, what we know from the science. But that was also not the purpose of that legal concept. That's for a different discussion. Nevertheless, when we look at the case law of the Court of Justice, we do see a very differentiated approach. The court does distinguish consumers depending on the type of goods they are buying. It's a different thing if you're buying detergent for your dishwasher or an expensive car. Second, it depends what type of public. Are you a general average consumer who buys sneakers? Everybody would do that. Or are you a professional who has really understanding of the type of product that you are buying? The degree of attentiveness will differ. So that is something the court is quite aware of. So how do I think this will play out? Only hypotheses at this point. We still need to go further in this. But we believe, because product recommendations offer a choice, the way we are seeing the consumer at this point, being offered informed choices means that the consumer is able to process and actually in a deliberative manner make up their mind about what to buy. Courts already have looked at this from a keyword advertising perspective. If you know, Google suggests certain things to you, and there the court felt, fair competition, it should be possible that you make up your mind being presented with different options. So that's quite likely to be the case here as well. For virtual assistants and automatic ordering, we are not so sure. Here, the consumer is only involved in the last stage, and I actually thought it would be more likely to see the AI as a professional giving you some guidance. If you trust that suggestions that you are being made and that actually the purchase is taking place is taking your preferences into account and that the bias is rather low, so that you do not have to display a high level of attentiveness, but you actually trust the best choice that is given to you, because it is likely to do a better job than maybe you do on the market. So it will very much depend on that trust and that experience by the consumer, whether it's a successful way of purchasing, I guess, most likely staple products rather than any type of expensive car. Final slide. I wish that we, not only we, in the end, it's also obviously the judges that will have to make that more clear, that we need a better understanding of the particular AI mechanism at issue, which is a difficult matter. As we have heard, it's not always possible to disclose it to the extent to know what is exactly happening. We need behavioral data on how consumers are acting with these AI tools in online purchasing for different types of goods. But I believe that at least so far, the concept that we have been using in trademark law of the consumer allows us to make a differentiated approach. Thank you very much for your attention.
Thank you very much for this fascinating presentation. When you refer to AI-assisted consumer, to what extent we're very far from augmented humans to some extent to see, and perhaps also the tricky distinction that we may have to make between AI-rich and AI-poor, those who can afford and can benefit from AI and those who cannot, what impact it may have on trademark law. I suggest also, because we are supposed and we're supposed to be in the coffee break in 1 minute from now, I will give more minutes to the last presenters for the duo, who will continue on the same track of trademark law, but move to a more technical presentation, which will be made jointly by Julien Cabay and Thomas Vandamme, both at ULB. So Julien is a professor at ULB, among many other activities, where he chairs the Integration and Innovation Law division. He has different affiliations, one of which is, of course, key from my perspective, which is with our very own Digital Law Center, and we're very pleased about that as a research affiliate.
He has been working along with Thomas Vandamme for some time, and we had the chance also to host a presentation with the two of them, and Thomas Vandamme is a PhD student at ULB in engineering and working in the LISA laboratory, which is a laboratory of image synthesis and analysis, and who is working for his PhD on deep learning methods for identifying similarity between objects from an IP perspective. So they are really the experts to talk about that topic of deep learning for the purpose of trademark similarities assessments, and I give them the floor. Thank you.
Thank you very much, Jacques. I want to thank you all for being there. Thanks to the organizers, with special thanks to Jean-Louis, who has been working a lot on this. Thanks to the speakers who actually accepted this invitation, and I owe you all an apology. It's the 15 minutes constraint for speaking about this complicated topic. But you see, and that's even worse for me, because people who knows me, they know that I'm used to speak a lot. This constraint applies to me too. So with no further ado, I'll introduce you what we've been doing so far in that particular field of AI and trademark. And I'll follow this outline, starting with the introduction of the context in which we've been speaking, we are speaking today. So I received funding from the ULB for running this project, which is called IPSAM. It goes for Intellectual Property Similarities Assessment Model. So basically, this is a research project which we're running in an interdisciplinary manner with my research center, which is the Juris Lab, so we are lawyers, and the LISA, which is a laboratory of image synthesis and analysis where Thomas is working as an engineer. So we are working together in order to study actually the technologies which are existing nowadays and that are used to assess similarities between objects, similarities that are relevant to us, obviously similarities in the field of intellectual property. So it's complicated to study those things, so we need to narrow down the aim of and the ambition of this project. So what we want to do is to focus on 2D images. Why? Because it is something that would be common to all IP rights. You can have 2D images and protected somehow through IP. We focus on the intellectual property office's tools. Why? Because they're publicly available, so we do have access there too. And we focus on trademark. The reason why we focus on trademark, I'm a copyright lawyer, but we have a lot of data. We had a lot of data, and these data are actually somehow formatted in a consistent way so we can use them, process them to a large extent. And we got the chance to attract the Benelux office support for these research projects, so they help us in some manner. So basically, I have limited time to show you, so I don't present video of these tools functioning, but you have tools that are developed nowadays by intellectual property offices and also private companies that help you finding out whether there are pre-existing trademarks that are similar to yours. So we have these different tools at in the different offices. Some have been created by the offices themselves, so they developed in-house solutions. Others actually partnered with private companies who developed their solutions. All these tools are powered by artificial intelligence, deep learning being the main technology used. And basically, it's always the same idea. There have image search function, so you can just upload the image of your trademark, and the tool will provide you with a list of, according to the algorithms, similar trademarks that are already in the register. So it's quite easy and convenient to use this tool with the purpose of finding out whether you are likely to be actually not necessarily infringing, but maybe in the field of something that has been already registered in the past. So it's really great for prior art and trademark clearance. So the state of the art, as I mentioned, it's been mentioned also by Jean-Marc, is deep learning actually. This is main technology that's used for these type of tools. And if we look at the literature, what we can see is that basically they moved from training these algorithm with that type of function from natural images to trademark and logos datasets. So it's, they reached an improvement thanks to this. And what we do see the most is that according to the literature, they try to enhance the performances of these computer vision systems through removing the text, because they're seeing that actually the text is giving too much information and that it lowers down the results and the efficiency of their techniques. So we have different papers that I just mentioned here. The other thing we do see in the state of the art, and that's quite new, we saw that in some papers from Trapi, is that they are starting actually using legally relevant information in order to evaluate the performances of these tools. So, for example, Trapi has been using US infringement case law for the purpose of evaluating their system. So, basically, regarding the performance, they claim, all the providers of the solution or researchers in the field, that they are being more efficient than the previous systems, or that they are going beyond the state of the art. But the problem is that we don't know what is efficient according to this, and we don't even know how good is the state of the art. So our claim is that if we want to address the performances of these type of tools, what we need to do is to study those tools in the light of their capacity in identifying similar trademarks, the one that are likely to raise likelihood of confusion concerns, which is basically infringement of trademarks. So that's what we've been trying to do, relying on the relevant case law. According to our project, and since we're in the EU, we're relying on EU case law, generally speaking. So what we've been doing so far is an exploratory research. I'll say a few words on this. What we're doing now is trying to systematize the analysis that, of these tools in order to have actually the possibility to benchmark these different tools, and with the aim of, in the future, making our own tool and check whether it gets better or not than what exists already on the market. So we've been doing this exploratory research. I had the great chance to not go to Geneva. Pandemic is the main reason, you can assume, but to give this webinar with Thomas during the AITPT talks in November, and where we explained what we were doing. So we tested some tools, but this was really an exploratory research, so we used like 15 cases in order to test this. So the basic test is the one you're seeing here. Actually, we upload a trademark that has been giving rise to a likelihood of confusion discussion before the EU IPO division opposition. Okay, so each time you see the number of the opposition, and the trademark on the right is the one that has been discussed as giving rise potentially to a likelihood of confusion, and the one on the left is the one that was the basis for this opposition. So the basic test, we did all the time upload the one on the right, and we were looking where, if any, would appear the one on the left in the results. So we were looking for a match, actually. So we've been doing this with a few cases, and you're seeing just some example here, but I invite you to just watch the video of the talk we gave if you want to have more detail on this. But the general assessment was that we don't understand what's going on, because we had really different outcomes. We had a lot of noise, which means we had a lot of false positives popping up in the results, and we had a lot of false negatives, which means many signs that are absolutely not likely to give rise to the likelihood of confusion issue according to trademark law. And we also had really surprising results that we could not understand. So the best example is with this Apple case, where actually, so we uploaded the contested sign, which is this small weird apple tomato-ish, and we were looking for the well-known Apple sign. And actually, for example, in the WIPO tool, we had this old Macintosh sign popping up first. We only had the real, actual Apple sign popping up on the 472nd position, but it was not even the one you would assume, like the one being registered in the US or in the EU. It was registered in North Macedonia. So it was really weird to us, and we could not understand. We do not have access to the technology and what's going on inside. So we decided to try to make systematic and automated analysis, because we've been running these tests with 15 decisions, so we needed more in order to have some kind of view on what's going on. So the methodology, and I'll give the floor to Thomas in a second, just to tell you, we decided to take all the decisions from the opposition divisions that gave rise to likelihood of confusion since 2016. It's basically the entry into force of the last regulation in the field of trademark. We took all the decisions regarding likelihood of confusion as to figurative EU trademark, and we started an automated data mining process. So I leave the floor to Thomas, who will explain what we did exactly.
Thank you very much. So we first started doing exactly what you said we did as an example, and we automated it. We did both the BOEP and the EU IPO search, and we queried with high-resolution images. There are various errors, of course, but since we are still left with more than 6,000 decisions. So these are the results. No, this is the first question. So the main problem is, how do you evaluate that a trademark is the trademark that you are looking for? And we had two main options. The first one is by assessing that it's exactly the same trademark ID, so exactly the same trademark. There are some problems with it because trademarks can change orders, or by order, because some trademarks look alike. So there is no reason that we take one where the other was look alike, like in the Apple example. We tested both, and they yielded results with clearly negligible differences. So the rest of the analysis is based on the order match. These are the results. So these are histograms. Basically, on the x-axis, you have the rank. The rank is the position at which the trademark appears. And on the left, on the y-axis, you have the number of occurrences. So first of all, there is very little matches for the BOEP, less than 8%, and the majority of matches for the EU IPO, which is very strange. Also, we see that the histograms are way more spread out for the BOEP than for the EU IPO, and we were expecting more of the BOEP histograms. As a matter of fact, about 3/4 of the matches made made for the Europe is at the second rank. So the query trademark ends up at the first position, and the one we were looking for is at the second. I'll speak more about that later. So this is very strange, and we were trying to see, can we find in all of the data some correlations to find why this is so. So we tried to look and discriminate for the likelihood of confusion of the case. So we were expecting, for example, that if there had been a likelihood of confusion assessed, we were expecting the results to be better, like the similar trademarks should be higher up than the ones that are not. And we proved that this is not true, at least for the EU IPO. For the BOEP, this is just not conclusive because there are too few examples. Then we tried to see for the cases where we had two trademarks and the matches, well, we could match both in both methods. This way we are comparing things that are comparable. As you can see here, of course we are very limited because the BOEP has very little matches, and we found out that this is very similar to what I just showed you on the overall data set. So as a conclusion for this very specific finding, the EU IPO seems to be way better both in match rate and ranking for the task, but it does seem too good to be true. So we tried different solutions that I don't have time to show you, but we tried to assess the metadata use of the methods, and it didn't yield any difference. We tried to see if in the time there was a difference, because we think that somehow the EU IPO might have trained on these samples. So this is, of course, not a problem in and of itself, but if we assess the performance of the system with something that has been trained on it, we can be sure that there will be an unfair comparison. So the future research will be about trying to assess these performances, at least for the EU IPO, on national case law that hopefully they haven't seen. And also, there might be some other hidden correlation or feature that we will try to see, and this is, of course, further work, both in statistical and legal. And now, just a quick word about, so we tried to see where the BOIP was doing better than the Europe search engine. So there are only 13 cases, which is very little, and they have all one feature in common, and this is the text. So this goes back to the state of the art that Julien explained, which is that most academic literature remove the text from the trademark to assess the similarity, which is, of course, kind of problematic. So this is something that we will have to test more in depth, but as a preliminary finding, I think this is very interesting. I leave the conclusion to you.
I conclude in a minute. So we've been very fast on this, but you see with these numbers that we showed you that these technologies that are supposed to be efficient or useful show a very poor result, 8% of the matches. And we know that the signs we're looking for are in the register, so we checked that. So we know that they are there. So 8% for the BOIP and 60%-ish for the EU IPO, with this claim that we're making that probably it's because we had the bad methodology, we actually look for their training sets. So obviously they had good results. So what is important, and I got 3 takeaways that make sense and for all of us, and that may, let's say, conclude what we've been all discussing today, actually. First, if we want to discuss and to assess the use of these technology and therefore regulate them, so I'm addressing myself to the policymakers as well, we need actually to make these big data analytics, because without this, you don't understand exactly what's going on. Even with these type of data, you don't understand exactly what's going on, but you get a better idea of the efficiency that is sometimes proposed as a feature of these technologies by the providers. So big data analytics is absolutely indispensable for the regulation of big data. Second, there are many limitations. So it is not easy to run these type of studies because we have troubles getting access to the data we need. It is time consuming a lot. And we are tied, for example, to the user interfaces. We had here the idea of testing publicly available tools, which is much better than secret tools where we do not have access to nothing. But even with this, it's quite complicated because we know that we wish to look for something, but that is complicated to get access there too because of the structure of the interface and so on. So it's extremely difficult. So these limitations gives, let's say, researchers a lot of troubles in actually performing this type of big data analytics. And the last thing I wanted to say is that we have been working together all the time. So if you want to do these type of research, which are, once again, from my perspective, absolutely necessary for regulating the new technologies, you have to have the lawyers and the engineers, and obviously even more disciplines than this, working together. Because every time we have some kind of weird thing, we get questions as to the methodology and so on, we have to discuss together in order to make sense of this and to find the correct approach. Thomas can't do it alone as an engineer. I can't do it alone as a lawyer. So we have been working together all the time, and this would be my recommendation to all of you if you want to perform this. Find an engineer. Thank you.
Thank you. To be continued indeed as reflected on the screen. Many thanks to our last panelists for this session of this morning. And I think this is also a perfect conclusion to the panel discussion, also highlighting the importance of evidence-based policy making and I think data-based policy making, which is why data analytics can play such a significant role in many areas of the law and policy, and specifically with IP, and more particularly with respect to registered IP rights, where you have a goldmine of data, which really calls for closer attention. So many thanks to our last speakers. I know we're running late, and I apologize for that, but I still wanted to open the floor if there are any comments or questions, knowing, of course, that the discussion can continue during the coffee break and assume the coffee break will still take place in spite of we are being a bit late. Are there any questions? So please, perhaps we can give you the mic, and if you could briefly introduce yourself, that'd be perfect.
Thank you very much. My name is Julien. I work as a legal and policy executive at ICMP, the global voice of music publishing. My question is to Professor Ueno on the text and data mining exception in Japan. And the question is, you have explained how this exception is construed particularly broadly in Japan, even dispensing with the need for lawful access. And my question is, could you speak to the safeguards that exist in Japan for the right holders that are available to them to protect their, as you say, legitimate interests? And if you could contrast that with any safeguards that you see being included in the new UK proposal that you've referred to. Thank you very much. So, for instance, you mentioned that right holders in Japan are able to affirm or make an argument that a use is particularly prejudicial to their legitimate interests, so that an application of the TDM exception would unreasonably prejudice their interests in accordance with the three-step test of the Berne Convention. My question is, can you speak to the efficiency of these safeguards in Japan, and as to whether you see any such safeguards included in the new UK proposal that would allow you to conclude that there are, let's say, appropriate safeguards in that proposal as well, or not?
So I'm not sure I could understand correctly, but it is true that, for example, in the lawmaking process in the EU directive, there was a great an objection against the introduction of such kind of the TDM exception by copyright holders, including publishers. So then, and in Japan, when the copyright exception was introduced first in 2009, there was no, almost no objection against the introduction, because copyright holders didn't recognize the value of the big data. But now, sometimes the broad copyright exception is criticized by the copyright holders, including, especially in the other countries. So, and the point is the compatibility with the copyright treaty, including and the Berne Convention, especially the three-step test. So, and sometimes the Japanese copyright exception is argued because it's whether it is compatible with the three-step test, and especially it would unreasonably prejudice the interests of copyright interests. But the Japanese copyright exception for TDM has the proviso, so it is applicable to activities unless it would unreasonably prejudice the interests of Copyright Act. So the meaning of the proviso is still unclear, but it would be the safeguard for the copyright owners. So I hope that would answer your question. Thank you very much for your question. Yeah.
Just very quickly, since the UK IPO consultation closed in January and the results were published in June, there's still no text about how the provision is going to look like. It's going to be, though, for all purposes, so commercial purpose including, and there's going to be no possibility to contract out of it. So these are the only two things we know about it, and everyone is waiting for a text because that's going to be probably the only good thing that came out of Brexit somewhere else. So let's see what they go.
Thank you very much. I think there was another question here, right? The mic is here. Perhaps you can also.
Do you hear me? Yes. I'm Jean-Ferdinand Purémont. I'm working together with Julien at the Juris Lab and with André Putemans. I had two questions, in fact. The first one was for Mrs. van der Plas. It's more of a general and perhaps philosophical questions. We have all heard a lot about the Turing test, about AI. And would it be possible to apply a sort of test like that for creativity in order not to be able to ascertain if it's coming from a human or from a non-human? And that was one question. And the second question was for Julien and Thomas. It's more about perspective, because the research is in fact also could also be of a lot of interest for litigation, as it could be also applied to the problems of discovery of evidence. In order in copyright, in the era of Google, and I know we spoke already a lot about this, but the problem is that there is a possibility of an enormous number of on prior art, prior works, and so this sort of research is also very important for this field of legal research. Thank you.
Thank you very much. Lonneke, would you like to?
Yeah, thank you very much for this question. I think it's a very interesting proposal. I hadn't thought of it. I was thinking of, with my project, to come up with a lot of benchmarks. But indeed, one way to do this is indeed to see whether an outside human would be able to see the difference between something created by a human or by a machine. I think that is a very interesting proposal. One thing that I think we need to also be careful with is that what we do currently with benchmarking in the field of AI is that we also watching very carefully, we're using experts to create benchmarks, because if we just let lay people come up with benchmarks, they don't know what the vulnerabilities are of the systems. And the current systems are very good at mimicking us, so this is why a general public would be very much impressed, but we know where the weaknesses are. So I think that if we do such a Turing test, we should also make sure that the person that is actually doing the test is somebody who knows what the weak points are of machines. But I think it's a very interesting idea. Thank you.
If I can just point.
Yeah.
It's already been done, actually. It's called the Lovelace test. Ada Lovelace is actually a famous person in the field of AI. It's a person who sort of coded for the first time, in a way, implemented an algorithm together with John Babbage. So there's a test called Lovelace test. You can find it on Wikipedia. That does exactly that.
And turning to the question of litigation to our last speakers.
Extremely short. First, regarding the impact on the law of evidence, this will be huge, because actually these technologies can help you find out prior art. Therefore, each time novelty is an impact on the assessment of whether or not you got an IP right, it will change the probabilities and the possibilities to find out these prior art. So basically it will have an impact on everything in the field of IP, because novelty plays a role somehow in every field. And the second thing, which is extremely important, is the numbers that we are showing are actually here pretty low. So you won't use it as an evidence probably for saying, okay, this is similar, but you could use it the other way around as a defendant for saying it's not similar. So probably the problem you will have is that these numbers says very little, but they will create this idea in the mind of the judge, for example, that it means something. And the problem with automation biases, which is well known in the field, is that we need to teach and to educate actually the users of these numbers in order to avoid drawing false assumptions from these numbers, and in particular if the assumption is to decide these numbers as being an evidence of something being here, infringement, similarity or something. So it's going to be very important to be to have education about this anyway, because these technologies are here to stay, so we can't avoid that.
Thank you very much. Any last reaction, comments? So perhaps just one final question to you, if I may, and take the privilege of chairing the session about trademark law. I think the panel somehow highlighted potential areas in which we may need to amend or update the law in a way or another. I was curious to hear you on the need to amend trademark law on the basis of what you describe in AI-powered, so to say, consumer. Do you think this is something that would be needed, or can this be somehow managed by kind of case law approach without having to revise some more fundamental aspects of trademark law, which is perhaps basically something which may apply to all areas of IP that we discuss, and perhaps even beyond IP, but as to trademark law?
That's why we focused indeed on this concept of the consumer, which we thought would be the most prevalent to think about, because it is indeed a different game when you have all these tools available. There we did find that the scope is big enough to currently fit the technologies that we see, and then how they help the consumer into the possible ways of assessing it. And the consumer, depending on how we assess the consumer, we have lots of consequences, whether we think trademarks are distinctive, so whether they can be protected in the first place, whether they have a reputation for the consumer. The consumer comes back obviously in the likelihood of confusion question, which is indeed another concept I would now dedicate more attention to, because that is indeed the question, as I also said, maybe we don't need it for this origin function, which is to find exactly the information. Is this the product from company A? The confusion may be lesser, and then the standard would also be lowered. So this is exactly the next steps that we are trying to understand better, and also develop guidelines, because the cases aren't there yet. So case law is not really in that field yet, so we are still waiting, but we can draw some parallels. But it's definitely a very important question. And if I may abuse the fact that you asked me a question to add to what Julien just said, I think also the comment made by Lonneke earlier, the narrow scope of these AIs is something that we highlighted in a paper, that actually people will very easily be misled by these numbers. And it's very difficult because under law, luckily, likelihood of confusion is not only based on similarity of images, but the private tools that are currently around are very much based only on high similarity, suggesting there is a risk of confusion. But actually in the law test, and I'm happy that then lawyers still will fulfill a certain purpose, there are other criteria and factors like similarity of goods and services, and then you still need to show that the consumer actually is really confused or likely to be confused. So I also want to make that pledge that the AI tools currently we see really are there for only a very niche type of purpose. And that's what we really, this message should be spread, because it will help us to regulate it also in our society, and not to run risks of making decisions based on wrong assumptions. Thank you.
Thank you very much. So I will not attempt to make a summary of the very rich and stimulating discussion. Everyone is, I guess, hungry and wishing for coffee, which is quite understandable. I just wanted to say that we've been talking about artificial intelligence, but I think we've seen really very brightly a lot of human intelligence, thanks to our panelists, and that was really a wonderful demonstration of the various facets of the issue. So let me finally just invite you to join me in thanking them and in congratulating them for the excellent presentation. And as reflected on the screen, this is certainly a discussion that shall continue. Many thanks and congratulations.
Let's start with a presentation of the three speakers. We have changed a little bit the order compared to the program. This is Waseda University event largely, and ULB as well. So I think it's good to start with our Japanese invité, and we'll start with a presentation of Mr. Shikato, who works for the Trade Ministry, JETRO, in Düsseldorf, in the IP department, and he represents as well the Japan Patent Office, where he worked for more than 20 years, basically, in different functions, and he was involved with awareness campaign as well on IP. So you have the floor with a first presentation, and then we will move to the EU view on some of those issues, and we'll have some comments at the end by Tom de Koster.
Yes, okay. Please. Yes. I'd like to thank you for the opportunity to give a presentation at this excellent conference. I'm Shunsuke Shikato from JETRO Düsseldorf, and I'm also a representative of the Japan Patent Office in Europe. So, actually, this style of the presentation, when I was in the JPO, I was in the PR office. I was the director of the PR office. At that time, I made this style of presentation. So, this time, it is very happy for me to use this presentation. And there are so many topics in IP and AI, but the JPO focuses on improving predictability for patent applicants and the quality of patent examination relating to AI-related technologies, where applications are expected to increase in this field. Today, I will introduce the JPO's efforts focusing on these perspectives. Yes, I will explain them in order as shown here. And first, I will explain about the application trend of AI-related inventions. Yes, in many cases, big data collected through IoT-related technologies and that are analyzed and learned through AI-based machine learning. In this example, AI will determine a kind of animal in response to an image input. The generated trained model is used as software or application in a universal computer or terminal. And this slide shows a number of applications for AI-related applications. Actually, Professor Deltorn has already used this slide or data in this previous session, but top line refers to the number of patent applications to Japan, which has been gradually decreasing in recent years. In contrast, the bar chart at the bottom shows AI-related inventions and AI core inventions that have been classified as AI-related inventions. They are all on the increase. And I think it is very small, so I'm sorry, but this slide shows AI-related applications broken down by technical field. The technology fields with particularly high numbers of patent applications are image processing, business, information retrieval, and recommendation and medical diagnosis. And this slide shows a number of AI-related applications in the IP5 offices. The data was obtained from WIPO. As can be seen from the chart, there has been a marked increase in the number of applications in China and United States. The number of applications is also growing in other countries. From next slide, I will introduce the JPO's initiatives for AI-related patent applications. AI-related technologies are applied in various other technological fields. It is therefore essential to accurately ascertain the level of AI-related technology and the state of application of AI. It is also necessary to improve predictability for applicants and the quality of examination by eliminating variations in examination by examiners unfamiliar with AI-related technologies. And to this end, the JPO has set up an AI examination support team consisting of directors of patent examination divisions and AI examination experts responsible for improving the examination environment for AI-related inventions. This will ensure that each examiner can consult with AI examination experts And the AI examination experts can share information on AI-related applications in each technology field. And this slide shows our cases examples on AI IoT-related technologies. The JPO has also published the world's first patent examination case examples on AI and IoT-related inventions. Yes, I will use this case. The case study is presented in this slide. This is a patent application in which, as training data, the face image of the person who grew the vegetables and the sugar content data are machine learned. When a face image of a particular farmer is input, and the sugar content of the vegetables is output. As you may know, there is no relationship between farmers' image data and the sugar content of the crops they grow. Besides, the relationship between the farmer's facial image data and the sugar content of the crops is not supported by this patent application. So it is, and it is not common. This is a common technical knowledge. So this application should be rejected because of a violation of the enablement requirement. This slide shows this one uses a training model that machine learns that driver's image to decide whether or not to switch from automatic to manual driving. For example, if the driver were eating or drinking something, the invention would not switch from automatic to manual. But if the driver had a firm grip on the steering wheel, it could switch from automatic to manual. In this case, unlike the previous one, the causal relationship is clear and the decision is consequently not rejected. By the way, this is very simple. To simplify the explanation, I have prepared these simple examples, but not all samples are that simple. And the JPO has always pursued the creation of something that is easy for everyone to understand. The JPO has now published a comic version of its examination guidelines in AI and IoT fields. What is easy for everyone to understand is also easy for experts. And the usual examination guidelines are only in text and therefore sometimes difficult to understand even for experts. As I am not an examiner in this field, so I didn't feel that I understood these examination guidelines very well. Still, after reading the comic version, I finally understood. This episode explains the efficiency about this manga examination guideline. However, I would like today's participants not to say to the JPO colleagues about this fact. And yes, this slide is about differences, the patentability of the United States and the EPO and Japan. But Professor Deltorn explained a lot about patentability. So I will not explain this slide in detail, but we believe that the Japanese examination guidelines for computer software-related inventions are predictable for the users. And from this slide, I will explain about the AI utilization to improve quality and efficiency. As the JPO patent examiners studied AI themselves and created systems for patent classification, pre-search, concept search, and examination management, and advanced search by themselves. So the JPO got the patent for the first time from the JPO by this patent classification technology that patent examiners had developed themselves. And this slide shows the advanced search system. This system is critical for examiners who were newly assigned to new technology. The search queries of experienced examiners are stored in the suggestion system, which suggests frequently used classifications and synonyms. I have also used this system to eliminate omissions in the search, as all synonyms are covered. While many examiners continue to examine one technical field for a long time, but sometimes they need to move to other technical fields due to the technology trend. In such cases, it is beneficial for examiners assigned to the other technical fields to have the knowledge of experienced examiners transferred to them through this system, which improves or maintains the examination quality. And finally, I will explain briefly about the AI competition in Trademark. The JPO conducted its first machine learning competition. A competition was held to implement the best model into the JPO system. This event attracted a great amount of interest with 637 participants and approximately 1,500 submissions. Yes, it was particularly noteworthy that approximately 20% of the participants were university students. And accuracy is approximately 70% for tasks. Improvement is expected to twice the accuracy of the current JPO's tool. And the competition also made the development of support tool more effective and reduced the development period. Reasons for improvement accuracy include the ingenuity on the part of the competition participants, such as the use of latest open source software to create models, was also a reason for improved accuracy. On the session one, Mr. Cabay and Mr. Vandamme tried to use the system EUIPO and BIOP, but it is not published right now. But if you can use this system in the future, please use this system. Thank you very much.
Thank you very much for first respecting the time limit, which has been reduced. I suppose you have understood that Mr. Shikato was patent examiner because he could present the issues quite clearly. And it's interesting to see that the GDPO released a manga about patent examination. As you might know, Belgium is a country for comics well known, so maybe you should, I'm suggesting, set up a research group on the manga Belgian comics application in the IP field. It might be interesting. But you were focusing on the enablement requirement, which is, I think, quite interesting, because beyond the technical aspects, that is a topic of patent law which is directly linked to a policy objective, which is the spread of knowledge. And there is a requirement because you need to share the knowledge embedded in the patent, so it's important to respect it. And it's more complicated with generative technologies. Okay, let's move to the second speaker. You speak either from your seat or if you want to stand, Virginie, as you want. I present you. You are policy and legal officers at DG GROW, one of the Commission's DG. Working in the unit for IP and the fight against counterfeiting. You worked before for other units, the copyright unit at DG Connect, and before that you had a life as an IP lawyer and as well a research at the ULB. So you have the floor to present the policy aspects from the EU point of view.
Thank you. I hope you can hear me. Yeah. Okay, very good. So maybe you should. Right. So thank you. Yes, I will focus my intervention not so much on AI, but more on the data aspect, because for the development of AI, what you need is also more access and more sharing of data. And also because it offers, I think, a good concrete policy example that we have and that we are currently living also at the Commission. And so that's why I would like to discuss the interaction between data access, data sharing, and trade secrets. And for that, I will first explain a bit the context of the discussions, and then start with the concrete example of the discussions on the Data Act, and then what we are looking at for possible solution to solve this issue between trade secrets and protection and data access and data sharing. So when the discussion started on the data economy, so I'm talking about like 3 or 4 years ago, where we really started discussing the Data Act and the Data Governance Act at the Commission, the first IP reflex, if I may say so, was trade secret. It was not so much about the copyright. We had already the text and data mining exception in place. So we were thinking about, okay, but what do we do? Because we have one aspect is a conflicting interest between providing access to data and allowing more data sharing, and on the other hand, how do you protect trade secrets? We wanted to provide protection to EU companies and to make sure that data sharing, data access obligation will not lead to the disclosure of trade secrets. So that was one aspect of the reflection. The second aspect, it's a bit less obvious, but we were thinking, but maybe trade secret is something that can be used to foster data access and data sharing because it provides a safe environment. So the idea was this is not an IP right as such. There is no ownership, so we don't want any ownership on data. But there is this defensive framework that exists in the Trade Secret Directive, saying that, if there is a data breach, a trade secret breach, then you can start procedures to prevent that, to stop further disclosure. So we were also thinking, maybe we can draw some inspiration from the Trade Secret Directive to create this environment where a company is not willing to share data with its competitor, but maybe is willing to share data with other companies, and so how we can create this safe environment. And here we were already looking at Japan, that has a law on data, kind of a limited right on data that would allow sharing with some safeguards surrounding the sharing. So that was a bit how we were considering the issue of trade secret versus data access and sharing. And then came the Data Act and the discussions of the Data Act. So I don't know how much you are familiar with the Data Act. I will very quickly explain. My unit is not competent for the Data Act, but in short, the objective of this text is really to provide further access and further sharing of data, and especially data that is generated by the user. So you will have the possibility for the user to get data it has generated. So the data holder will give the data to the user, and then the user can ask the data holder to give access to a third party to its data, the data that it has generated via a device or else. So we had these two interactions. And so when we started discussing with our colleague from DG Connect, we were like, the first easy solution would say, oh, you do not touch the trade secret, carve out, and end of the discussion. But of course, it was not something that could be done, because if you decide that the Data Act does not apply to trade secret, and that you cannot disclose a trade secret in the context of the Data Act, you create a loophole, saying that tomorrow many companies, to avoid their obligation under the Data Act, will say, yeah, but I cannot provide you, I don't want to disclose this data because it's a trade secret. And the trade secret is not registered, so it's very easy to claim protection. So it was not a viable solution because it would go against the objective of the Data Act. And also, when you take the IP perspective, you can think that it could dilute also to some extent trade secret protection, because suddenly you will have all types of data that suddenly can become a trade secret. Again, we cannot assess the risk because it was difficult to assess something that is not existing yet, but we can understand this loophole. So what we decided in the end was to allow the disclosure of data, but with some guarantees, some confidentiality requirements. So we decided, okay, between the user and the data holder, you disclose the trade secret, if there are some, and if you decide to disclose, you have to take some confidentiality measures. So that was the first guarantee. In the relationship between the data holder and the third party, we said same guarantees, disclosure, confidentiality measures, but on top of that, the data that has to be disclosed should only be disclosed if it is necessary to achieve the purpose, because the user will ask the data holder to release, to disclose its data to a third party for a specific purpose. Let's think of repairing the fridge, something like that. In that case, you can only provide the data that are necessary to achieve the purpose. So here we can see some also influence from the data protection regulation. So that's, in the end, the compromise that we reached in the proposal that was published. And you could see that the negotiations are still ongoing, and we can see that some stakeholders, companies typically, are still very worried about that, saying, but at the end of the day, what we would like to have is a right to decline access, decline sharing. So it keeps coming up. But here you have two solutions. Either you grant this right, but then you have the carve-out solution that we had excluded in the first place. Or you decide, okay, there is this possibility. But then you run the risk to create another category of trade secret, which we want to avoid. Saying like, I'm okay to disclose this trade secret, but this super trade secret I don't want to disclose. And that we want to avoid because there is only one definition of a trade secret and you cannot have like super trade secret on top of trade secrets. So again, we want to avoid this dilution of trade secret protection. So that was a bit where we stand at the moment. And the other way, the other solution would be to work on the definition of a data. And here it's quite difficult to try to really tailor the text to decide what type, to kind of exclude the data that could be trade secrets from the scope of the directive or the regulation. But here it is very difficult because we conducted a study to assess also how trade secret protection was applied in the context of the data economy. And in the context of this study, there were like, I think, 50 interviews, 70 persons asked by survey. And the big conclusion from this study is that companies do not know. Companies do not know what data is a trade secret. They are still adjusting to the trade secret directive. I mean, this is a very young directive from 2016. The implementation has just been finalized in all the member states. So it would be very difficult for us to provide a definition of a data that would exclude trade secrets. I mean, the discussions are not mature enough. So we are left with that at the moment, and we have some options. And typically, the study has provided us some pistes. The first one is to change the trade secret directive. But that is not happening. Like I say, it's a very young directive. We still need the case law to develop. We still need to see what works and what does not work. The other one is just to do nothing, wait and see. This can be a solution because we let the court decide and how to interpret the trade secret directive and the international implementation of it. But it can be long, and it can also lead to some diverging views from member states. So that's also something where we need to be a bit careful. The third option that was proposed by the study is to provide some guidance, because at the end of the day, the big conclusion was that there is a lot of legal uncertainty on what constitutes a trade secret in the context of the data economy, but also on the safeguards that are to be applied to preserve the confidentiality. And this will be a key point when the Data Act will be in place, because in the end, the safeguards, that's this safeguard that we have included in the Data Act. So we can think about that. This is, again, not what we are proposing now. We are still assessing the situation. And then another option would be awareness raising. And that was a very important point, but not only for the data economy. And here we are already doing something. We are developing a toolkit for companies, especially SMEs, to see how they can use trade secret protection, and also in the context of the data economy. This is especially important now, you know, that the EU companies are subject to a lot of IP theft at the moment, so we are very careful about that, and we are working and building some more awareness. I think that the manga was an excellent idea, and maybe we will steal the idea to do Tintin et les secrets d'affaires, something like that. We can think about that, but that's something that we are, at least that's the only thing that I can announce at the moment, but we are further reflecting about possible guidance, maybe for the next mandate. And now the last point, maybe the Japanese example, because I explained that there was this Japanese law. We were super interested in this initiative. I mean, there was a very good presentation done at WIPO by the Japanese representation on this new law based on unfair competition, providing some protection to data, but a defensive framework to allow this safe environment to develop. And so that's why we asked the study team to have a look at that and to assess the situation. So here, the conclusions were that it was very context specific to Japan, and that it couldn't be, I mean, it couldn't be transposed in the EU now. The directive is still very young, like I said, so we are, again, trying to see how it evolves. I think it was also the conclusions of the study was maybe a hidden way to say, like, let's see whether it works in Japan, and then after that, we can maybe decide if we want to implement that in the EU. So for the moment, what we propose is still checking, again, for each legislation that will provide some access and data access rights and sharing rights for data. We will still continue this assessment on the case-by-case basis, and always not preventing the disclosure, but to make sure that the disclosure does not erase trade secret protection. Thank you.
Thank you very much, Virginie. I think concerning the awareness campaign, you can continue with Mr. Shikato, because he was involved in the production of video as well, Show Iyo Ken. So he is an expert on not only mangas, but as well videos for awareness campaign in the IP field. So I think you raised a very interesting topic. It's really a policy topic. It's about how to control data and how to facilitate the dissemination of data. That's basically the balance that is at the core of intellectual property, at the core as well of data protection law and many other laws. We have a complete shift of perspective in Europe. I think for many years the Commission was focused on probably increasing the protection, more IP control, with a lot of directives. But recently, with the Data Act you mentioned, as well with the Data Governance Act, but that's only for platforms, with the Digital Market Act and other pieces, obviously the objective is now more data sharing. But of course, you have to respect the acquis and the rights, including trade secrets. I just made a check because I learned data checks are important. There are 17 occurrences of trade secret in the text of the Data Act, which means it plays some role in the balance that you have to find. So very interesting. I think we might have a discussion on that afterwards. But I give the floor to Tom de Koster now, who is an attorney at the Linklaters Brussels IP practice. He has an extensive experience in contentious and as well transactional matters in different sectors, including tech, consumer, and healthcare space. I think that's for the presentation. So please share your views, standing or sitting. You have the choice.
Thank you so much, Professor Strowel. I would like to point out, in fact, a couple of points, mainly relating in the patent and the copyright sphere as an IP lawyer, and also picking up on a few points which have just been discussed. I think the first point I wanted to mention is actually based on what Mr. Shikato explained. So we have all seen that the Japanese patent office already appears to be at the forefront of AI developments, which is a good thing to see. And I believe that actually all patent offices will need to, implement AI in their prior art search tool, etc. Because basically the private companies, the companies are all starting to do that today. So there are let's say, very specialized applications on the market, getting available, startups developing that, and companies are starting to use that, in fact. So as a consequence of that, compared to the past, there will be a much more thorough prior art searches. So that's one point which sort of is important to note, because let's say the novelty requirements will become more let's say a higher threshold than it was before. And similarly Similarly, actually the inventive step requirement may also follow because basically a person skilled in the art will now also use AI applications or have that at at his or her disposal if this person makes an investment, which may make, of course, more inventions in the future obvious because you have like access to this, to a lot more than you would be able to analyze before. And that, therefore, for this reason, I think at some point the EPO examination guidelines may need to be updated for such persons skilled in the art to take that into account. Another point on patent rights is that in some cases, they may not be available or the best tool to protect AI-assisted inventions. And I wanted to pick in a bit on what Virginie said, because I do think indeed that trade secrets will play also a big role. And why do I think that? For like a couple of reasons. I think the first one to mention, and I'm just for clarification talking about AI-assisted inventions here, not so much about AI-generated inventions, because that's more for a far future. So I don't think that's already possible to date. But the first point is that AI may in some cases not contribute to the technical character of an invention. And so therefore, as you know, so the technical character of an invention at the EPO is one of the key considerations to assess whether AI can be patented or not. Same for that the inventive step may not always be based on technical features only. So I can give a very practical example, in fact. So for instance, imagine a mere classification of text documents based on their textual contents. That is not considered to have a technical contribution. So that's just like that's totally lacking. So you would really need to resort to like trade secrets there and fall back on that. A second point why patent rights may not always be helpful is, and that has also been mentioned before, also actually by Professor Strowel based on the presentation of Mr. Shikato. So basically the sufficient disclosure requirement, which was also called an enablement. So the problem is with AI systems, in fact, that you have to, be able to sort of disclose everything. And you have the input layer that's very clear. The output layer is also very clear, but in between, in many AI applications, you have hidden layers, which I call sort of a black box. And the problem is you can't really sort of disclose that, but there are of course ways around it. So what they do, for instance, is provide information with respect to underlying algorithms, training models, training data, weighting of certain data, system architecture and so on, but some of this information may be proprietary, so you don't want to always disclose that, because then you are giving that out of hands, and it will be then publicly available in the patent register for everyone to consult. So in a study, in a report to the European Commission, a deposit system was also suggested, like already exists for biological materials, so that could be a possible route, but it's not really clear whether this would be really like the way to go. Yes, and then jumping on because I want to be a bit fast, so there are also the third point being in fact that, so there may also be other reasons why patent protection may not be ideal in every circumstances, for instance, because some companies in practice may consider it too expensive or time consuming, etc. So confidential information, trade secrets are often considered as a good alternative. And to keep such confidential information and trade secrets confidential, you have to of course invest a bit. You have to make sure that they are protected by all legal, technical, and organizational means. They should also, of course, as a starting point, not be reverse engineerable, because otherwise your trade secret protection may fall. But there, it's good to note that the black box may help you, because so that's a good point. So which favorizes again trade secrets. Jumping to copyright here, Professor Strowel participated to an extensive study on copyright and AI, which was commissioned by the DG Connect. And that study looked at possible policy initiatives on the use of copyright-protected contents as inputs on the one hand, and on the other hand, the possible copyright protection of the output of the AI system. And there are a couple of points that were to be noted. Just in the interest of time, I will not just tell you everything which I have noted down. But on the input side, I think one point to note is that in line with the Pelham and the CV Online case law of the CJEU, there may be also a need to sort of clarify, because this case law is already doing that a bit, that reproduction should be in an AI context, but I mean the cases are not really purely in an AI context, but it's just like saying like basically a reproduction, if you have to take into account basically that sometimes there may not be reproduction. In fact, when the work is not recognizable, you have to be a bit pragmatic about it. That's basically what the cases are saying. So for instance, if it doesn't undermine the adequate remuneration of like an author or performer, then basically there is no reproduction. So it's good to see that in those cases I take a bit of like a more theological approach to reproduction right, for instance. Saying, and based on which you can basically derive, and that's the point I was getting to, sorry, that took me a bit longer, but that's basically technical copies, for instance, made during the process of feeding an AI tool, that may not be considered to be a reproduction, which would then infringe copyright, because basically it's just like, yeah, it's not, as long as it's not recognizable in the output of the AI system, and as long as it doesn't, you know, like sort of like undermine the compensation, the remuneration principle, so meaning that the initial author still gets like its royalties, his royalties, etc., based on other work that he is exploiting, based on the same work that he is exploiting in another way, then basically there is no issue. Then the second point, and I will not talk about the moral rights here, but I will just maybe mention that in terms of the input as well of an AI system, that it is a bit unfortunate, I think, that the copyright DSM directive provides for an opt-out possibility for text and data mining other than in the framework of scientific research. Because if we look at the UK and the US, then basically we see that we are a bit, I must say, using a different approach here. And for that reason, I think the recommendation in the report is indeed like a very important one, that we should welcome uniform guidance in the EU on how this opt-out should be exercised. Then I will jump to the output side in the interest of time. So basically, AI-generated outputs, talking about copyrights here, will only be protected if there are sufficient human creative choices. And that are then also expressed, of course, in this final AI-assisted outputs. For instance, one concrete example to make this a bit concrete is like the Next Rembrandt project. There I think this was the case because basically a group of art historians, and you may have heard about that, and researchers and so on, and data scientists, because they have a core role to play in the future and already nowadays, they spent 18 months teaching a machine to think and act and paint like a Rembrandt, which sort of like in the input sort of, and in the output they made a selection. So they made a lot of creative choices, like, okay, oh no, this is not good, we have to sort of like clean up the data, do some data crunching in between. Then so that's there we can really say that there was that there were creative choices being made by this group of researchers and data scientists and so on. So I think if we look at that, there is, and I talked to Virginie about that before the presentation, but I think like if we look at that, basically that's sufficient. There is maybe no reason that this should change. So there should, I think if there are no creative choices being made, should there be a copyright? Probably not. Should we think in the future maybe about different rights? The study showed, in fact, which Strowel made, that there may not be a need for that. Then I will also jump to another point here, and I will skip the others. But if the works are automatically generated by an AI application, and if there is no sufficient creative input of a human, one may of course look at the different related rights, such as, for instance, the phonogram and film producer rights, and database rights, for instance, and press publisher rights. So that's a good point to note. I will now jump maybe to my conclusion, and that's maybe turning to my own practice, in fact, what we do on a daily basis and where we advise clients. I think it's from a practical point of view, if you look at an AI tool, it's always good like to map it, of course, first that. You have the inputs, you have the tool itself, you have the outputs, and you have to determine like which intellectual property rights could arise for each element. And you have many of them, because I only talked about copyrights, patent rights, and I also touched briefly on related rights. But it's very important to really assess every element and every possible rights. And then to figure out, to talk with basically your client and ask like, okay, who will now own the intellectual property rights to sort of reflect the commercial aims of a transaction. And then you have to put in place appropriate documentation to do that. So make sure that you have, for instance, assignment agreements, licensing agreements to sort of reflect that. And what I noticed a lot when working or when advising on AI is that often, and I can give maybe, but I don't think there's time left for that, but I can give a concrete example of that as well. Also, I don't think that in many cases, it's sort of like for the client often, I would say it's colloquially a bummer, because they say like, oh, we thought we would have intellectual property rights on this, but if you analyze it, often it turns out that there are not so many intellectual property rights on each of the elements. But then it's important to know, because there is no immediate need, I think, policy-wise, to then sort of change the framework. But you can also, of course, rely in some cases on unfair competition law, on trade secret protection, and I try to stress that, trade secret protection, and also try to fall back on contractual mechanisms. And two clauses we use very often is one, a confidentiality clause, and that's one thing, so you can sort of require the other party to keep certain materials confidential or to only use them for a specific purpose. And another clause we use very often, but that's always in collaboration with our competition colleagues, that's an exclusivity provision. So for instance, to provide data on an exclusive basis, or to deal with each other on an exclusive basis, or not to deal with competitors, but again, subject to an assessment together with our antitrust and competition colleagues. So I think in practice there are also ways to work around, let's say, the work with the current framework, and given, for instance, that we are not yet at the stage of AI-generated inventions, I don't think that there is policy-wise an immediate need for big reform, let's say big reform, because there are some small points which may need to adapt it. Thank you very much.
Thank you, Tom. Thank you for all two speakers, because you respected the new timeline and you accepted to reduce your presentation as we were late. I think you raised an interesting issue again, which might serve as a link with the final presentation, the keynote. And by the way, I already invite Lisa Dippendale to join us here, so that for the interest of time, we can immediately continue. I don't know whether you want to sit or to stand. Thank you. So you were referring to description issues in patent law. I think that refers as well to an important ethical issues when we are discussing AI. Of course, it's a transparency issue, which is one of the principles for ethics of AI, and you might say a few words on that, so there might be a link there. So to present you, Dr. Lisa Dippendale is Policy Officer at the Ethics and Research Integrity Sector of the European Commission. You have been focusing on bioethics and ethics of new technologies for quite some time, and before that you were working as a postdoc at Ghent University, still focusing on ethical issues in relation to technology. So you have the floor. As you know, it's a little bit shortened, but I got a special authorization to go beyond one. I don't tell you for how many minutes, but you can go a little bit beyond.
Thank you very much for this introduction, and also thank you to the organizers for inviting me. To be honest, I feel a bit like the odd one out in this conference today, but it's been very interesting and I feel very privileged to be included here among so many esteemed speakers. I've been asked to talk a bit about ethics of artificial intelligence, and then more specifically the challenges this raises for the research community. And of course, I approach this a bit from the perspective of ethics review, of course, which is what I work on in a professional capacity, but I will also try to reflect a bit more broadly on the challenges ahead for us. One other short notification, as a bioethicist by training, I very much focus on health research. This is also the area I have the most expertise in, so that is also the context I will be referring to the most, but I hope it also contains some insights for other areas of research. I will try to go quickly. So as you all know, artificial intelligence in many applications and tools raises a lot of ethical concerns, from biases, discrimination, to potential to misuse vulnerabilities in human decision-making, harms related to privacy, to autonomy, but also misuse in the context of misinformation, criminal activities. So there has been in the last years a wide area, very wide and well-documented literature of all the things that can go wrong when we develop or use AI tools. In addition to that, there is also, of course, the continuing concerns that AI-based systems, once they are deployed in the real world, are very unpredictable, also due to their opaqueness, of course, and are often lacking behind in their performance. In some circles, they even talk about a real reproducibility crisis when it comes to artificial intelligence. Now, these problems that have been identified have, of course, resulted in a very rapidly developing scholarly discipline, AI ethics. And in addition to that, various actors and stakeholders have been very actively engaged the last years in developing guidelines, codes, principles that describe the ethical problems and ethical concerns that AI tools and applications may raise, and also what ethical AI applications are supposed to look like. Some examples you see on the slides are, of course, from industry. There was the EU high-level expert group that developed guidelines on trustworthy AI, but also several other international organizations have developed interesting guidelines. For example, the G20 human-centered AI principles were adopted under the presidency of the Japan of the G20 already some time ago. And this continues to develop, and now also professional organizations and especially standard-setting bodies have increased their efforts in developing various tools and guidelines to address AI ethics in a variety of sectors and applications. So if we look at this a bit from a distance, from a broader view, we see actually on a global scale a kind of convergence around a set of principles. Transparency is always considered to be very important, justice and fairness in different formulations, also non-maleficence and sometimes in addition beneficence, responsibility and accountability, privacy and autonomy, and maybe I should add here the EU high-level group also adds human oversight as a very important additional principle here. But of course, this approach has also not been free of its criticisms. Ethics is a very nice term, and it's very hard to argue against ethics. That's one of the perks of my job and the sector I work for. But there's also been very harsh criticisms, sometimes even right criticism, that ethics is used as a way of ethics washing, very problematic developments in the fields of AI, that ethics is used as just a kind of shopping exercise, picking the principles you like, and also that it is used as a tool for lobbying, particularly against more stringent regulations, of course, of AI-based tools and applications. And also very funny, if you follow the literature, what you see is that in the more technical literature, you see that data scientists, computer scientists criticize the lack of technical knowledge on the part of policymakers and ethicists like myself, and vice versa. Ethicists and policymakers very often mark that data scientists lack ethical knowledge and insight to go and implement these principles in a responsible way. In addition to that, what is also very often mentioned in the literature is that AI ethics principles sound very nice, but it's just way too vague, and this also reflects in the interpretations in practice. If you look at these principles, they sound very nice, but if you have to apply them, they often conflict, and it's often not clear at all what they mean. So the convergence on the one side, on the principles, which is, I think, admirable and good, and also the result of many international dialogues and negotiations, like on UNESCO level, which is very good, but we also see substantive divergence on ideas on how these principles have to be interpreted, on what issues, in which domains of AI applications, for which kind of tools, and of course, by who they should be implemented and how. So already in 2019, Luciano Floridi, which is one of the very prominent AI ethicists in Europe, also former member of the EU high-level expert group on AI, noted that it is very urgent and very necessary that the debate involves not necessarily on what we want to do, but how we want to do it, and to make sure that ethical principles and values can be applied and implemented in a responsible way. At the same time, more recently, a kind of review of medical and clinical AI research still came to the unfortunate conclusion that in many cases, high-level principles are translated by developers as they see fit. Now, of course, you can already see why this is a bit of a problem, but why this is a problem becomes even more clear if we look, of course, at the broader policy framework. The European Commission has formulated a really ambitious agenda when it comes to artificial intelligence. In particular, the term trustworthy AI has been coined already by the high-level expert group when they released their guidelines, and trustworthy AI is AI that is ethical, complies with ethical principle, is legal, complies with legal principles and regulations, and is also robust from a technical perspective. So the aim is to develop AI and develop European approach to AI that is grounded in values and fundamental rights, protects human dignity and privacy, and is in a way a force for good in society. Now, of course, this emerges in various types of actions, and the proposal for an Artificial Intelligence Act released last year, of course, was one of the most important outcomes of that strategy. Now, this entire story, of course, raises a lot of questions also for the research community, universities, research institutions of various kinds. And these questions are, of course, how can these ethical values, principles, and requirements be embedded in research and development processes, and how can also during the research and development processes, how can fundamental rights and ethical principles be safeguarded during this research? Now, I think these questions are very relevant for various types of research. There is a lot of research that uses existing AI-based tools to then go and apply to new research questions. For example, protein modeling and predictions based on for drug development is a very good example, but also the merging of data sets to find new insights and correlations, but also other areas of research that are either more fundamental or more into the area of more into the direction of developing more applied tools, see challenges here. Now, one way of approaching this, of course, is the term that they coin ethics by design. If you Google that, you will also see too many hits. So it's a very popular concept, and this is the idea, and I think this is also the reason the research community has an important responsibility here, is that from the research and development phases onwards, it's very important to go for the inclusion of ethical values, principles, and requirements into the research and development processes. The big benefit of that, of course, being is that you can reduce research waste, you can reduce research outcomes that in the end do not appear to be useful and worth the risks that have been taken to develop them. So it's also important to reduce the need for external and ex post corrections to mechanisms and systems developed. Now, this is one way of approaching the challenges for research. This is also a way that the Commission also is in favor of. If you read the work programs for Horizon Europe, specifically for industry and digital, you will see that ethics by design and the inclusion of ethics is very often mentioned as requirements in calls for proposals. But it's also an approach that has some limitations because it's to some extent voluntary. It does not qualify as an independent ethics review, and this is something, for example, industry partners have often been criticized for. They also have their ethics boards, but they're not independent, and therefore it's not seen as the only approach. And one of the problems we also see is that there is not yet really an established culture of collaboration. This still requires lots of investments and efforts to set this up. Another way to approach this and to ensure that research into AI-based tools and using AI-based tools is properly reviewed and has proper oversight is to rely on the traditional ethical review of research. So this is a bit of a schematic overview of the traditional model, which emerged after the Second World War and also in response to, of course, various human rights violations within research during the Second World War, but also, unfortunately, later as well. And traditionally, ethics review as a key oversight mechanism of research is focused on the research participant. I write here human or otherwise, because for animal research this is also very important, and has the aim to really look at what happens during the research project and what are the rights and interests that have to be protected there, what are the safeguards that needs to be in place, also, for example, to address other environmental safety concerns like lab safety. To a limited extent, ethics review, also traditional ethics review, also takes into account the direct outcomes and effects of research. Misuse of results coming from research, this can be very prominent, for example, if researchers go and study migration flows, for example, or criminal activities. The development of dual-use technologies is also an aspect of that, and especially in the biomedical sphere, fundamental ethical dilemmas like human enhancement and genetic modification. Now, if we look at AI research and development, I've tried to make a bit of an overview here of what characteristic phases are. What we see is that the model of AI research and development does not really fit with the traditional ethics review model. The entire part on the slide, which in blue, the model development, model validation and testing, non-interventional silent observation of performance, so without the real world being aware of it, just comparing it. This is an entire part of research which happens highly virtually, without any direct real world impacts. Only when AI-based tools and applications are then tested in an interventional setting where they are really used in a real-world setting and can have consequences on living human beings and the world beyond, then it would fall under the scope of traditional ethics review. So this is indeed one of the problems, that there is no traditional research participant, so to say, when we talk about AI research and development. This is, of course, partly enabled by the digitalization we see of so many aspects of society. There are huge amounts of data available on all areas of human activities, whereas a couple of decades ago, all this data would need to be assembled for a specific research project, resulting in people having to volunteer to participate in research. This is no longer the case. The consequence of that is that for much AI research and development, there is absolutely no legal obligation to go for ethics review. Very often, this is limited to research when participants are involved and personal data are really collected or used. In many countries, it's a very diverse legal framework. Also within the EU, it's limited to health-related research, the legal obligations, although many professional codes and guidelines and institutions also require ethics review for non-health related research. And then the focus of this ethics research is very much on privacy, data protection within the research. A very unfortunate consequence of that is that many tools, AI tools, for example, in the clinical context, do not even come within a remit of an ethical evaluation until already significant parts of the development have finished. This is also, I think, quite problematic in light of the fact that it's not because research does not involve a concrete physical intervention in the physical world involving flesh and blood people that there are no risks involved in research. In literature, it has been very often noted that the risks, non-interventional risks, in particular related to privacy, have been dramatically underestimated, in particular by research participants and by people agreeing to have their data, their personal data, sometimes also sensitive data or special categories of data like health data being used for research. And in addition to that, and this is also something that has also been described in the literature also by Luciano Floridi, is that there is also a very underestimation of the group level harms that can arise out of the use of high amounts of data even when they are anonymized. This is, I think, a very good example. This was a study that managed to predict medical conditions from social media posts. And in another study, this possibility was presented to a group of people who had consented to have their data used for research purposes. The moment people consent to have their personal data used for research purposes, even if they have some idea of the area of research in which it should be used, if they are confronted with possibilities like that, they generally react with some reluctance because they didn't expect this kind of possibility. So also here, artificial intelligence and the use of those tools within research changes the landscape a bit. Another reason why I think that ethics review and AI research will even become more important is because, as I already mentioned, there are significant concerns about the fact that many algorithms and AI-based tools do not seem to work in reality as good as they were apparently working when they were tested and validated initially. This I find a particularly funny example that I found about AI tools to catch COVID, that apparently one of the tools picked up on the font that hospital used in the labels of scans. So the font used by the hospital hospitals became predictors of COVID risks. So this means, and I think this is a huge challenge for the research community, that what research might need to move forward, and AI-based tools might need to move forward, is more research with AI-based tools that involve real-world testing and real-world validation to indeed make sure that AI tools bring the benefits that they promise to bring. Because if we on the one side ask people to give up a level of autonomy, to give up a level of privacy, to give their data in return for a benefit, if we have no robust evidence that there is indeed going to be a benefit, this is kind of problematic. So in a way, I think we need more AI research that leaves the computer labs but goes into the real world. And in that perspective, I think the adoption of the AI Act, if it will be adopted, remains to be seen, might also be a trigger to see more of that type of research. And yeah, that I already mentioned, the problem of research waste. So if you don't have tools that deliver on the promises that they initially made, you distort this risk-benefit balances, but what you also risk doing is then making your end users in the medical context, that would be patients, into your research participants, but then they are unwitting guinea pigs, so as they call them. I'll try to speed up a bit. I'm almost to the end. There's also, for ethics review committees, if they want to contribute to all the challenges raised before, also have to confront with the fact that it's very difficult to predict impacts in advance because of what they call the hypothesis, free research, but also just the difficulty of predicting long-term impacts at the moment of conception. The traditional model of ethics review is, of course, an ex-ante model. You get ethics approval before you start your research, and even in some countries there are explicit limitations on taking long-range effects into account in ethics research. So this begs the question, can the model be stretched? Can the model be reformed in order to play really a significant role in helping researchers, the research community, to bring ethically and socially valuable research and contribute to the development of trustworthy AI? I think to do that, a couple of things would need to happen. And the first important one is developing concrete criteria for evaluation. We already have the high-level principles on which I think there is a significant consensus. What is needed, and I think is much more needed than is available now, are really tools and processes to interpret it and evaluate these high-level principles before and during research. One of my colleagues even said that what we actually need is, in addition to technology readiness levels, we need ethics readiness levels, where we can really go and see what exactly is needed at what phase. Of course, there are already some things that have been developed, so I'm not saying that there is nothing out there. There are human rights impact assessment tools, there are algorithmic auditing tools, there's the assessment list, the ALTAI. So there are already things out there. But still, what is also, I think, still a bit missing is also tools that take into account the context specificness. For example, if you use facial recognition in a medical context, it's I think, very different than when you use facial recognition tools in a context of law enforcement. So also, values and principles translate very differently depending on what sectors and what kind of applications you are looking at. And I think this is also very important to support the researchers, because if researchers don't know what to expect and don't know what to expect from ethics review, then this is not really something that supports research, rather on the contrary. Another challenge that we have is the developing of expertise. Ethics committees generally have a good mixture of legal and medical expertise, but have very limited familiarity with, for example, computer sciences, data sciences, engineering, so they have a general lack of capacity. So I think it's very important that the research community as a whole invests in educating and training ethicists, lawyers, anthropologists, psychologists, but also data scientists, engineers, and works on tools to help all these groups to work together. One of the suggestions that have been made is that there should really be specialized ethics committees for AI. I leave it in the middle whether this is a good idea or not, but it could maybe be worth considering. Also, the processes have to be adapted, the processes of research oversight. The question is what types of research should go to an ethics review? Should we stick to the very limited legal obligations for ethics review when you really do interventions on human beings? But at the same time, I will not say that we should review all AI research because we don't want overextensions either. A very important problem, I think also, now that we see more industry, private collaborations and spin-off when it comes to AI research and development of tools, is whether we need to prepare academic ethics committees to also accept ethics review requests from industry. This happens and is quite well established in the medical fields. Pharmaceutical companies often get ethics approval for their clinical trials from university hospital ethics approvals. Maybe this should be extended in another way. And also, how do we adapt the process to the fact that an ex ante prior review is the traditional model now, but maybe not very well adapted. In addition to that, also the traditional principles should need to be updated in light of what I said before. So in conclusion, what I want to say, I think ethics review and ethics review as a principal research oversight mechanism can really make a very valuable contribution to identify and tackle risks very early with new and emerging technologies like artificial intelligence, but it also has to be emphasized that it cannot replace, of course, the need for legislation and other tools once tools move closer to the market. And what I think is also very important if we think about how to reform and rethink research oversight in light of the impacts of AI, that we work towards a model that does not just add a layer of red tape for researchers, but that researchers really see ethics review or ethics evaluation as something that helps them with their project, that is really adopts an enabling approach and that helps building the culture of research ethics that we need to deliver on the goals regarding trustworthy AI. So this is an agenda for research, defining benchmarks to integrate ethical values and principles in research, how they have to be interpreted, developing of best practices and tools and sharing those, and also to the extent possible, if you are in your universities or institutions involved in ethics review and the organization of research management, encourage ethics committees to accept AI research for review, but at the same time invest in education training for ethics committee members as well as for researchers. And also for this audience today, I want to particularly highlight the importance of international collaboration, also when it comes to ethics and AI, because a lot of the research that happens is in international collaborations, and if we work with different AI frameworks that are not compatible and are not not well understood by the partners involved, this also is a loss of efficiency and hampers research. These are some relevant initiatives, and this is about the importance of ethics and integrity and also global dialogues on international research cooperation. But I won't bother you with that and ask if you have any questions for me. Thank you very much for your attention.
Thank you very much, Lisa, and sorry, but we cannot offer you 45 minutes as in the program.
I try to squeeze it as much as possible.
But thank you for squeezing your presentation. Just a final comment, because I think we have to go to lunch. As lawyers, and I think there are quite a lot of lawyers in the room, we should be modest. Law is probably not enough and not satisfactory in regulating AI, but it's very important to have the AI Act, for instance. Ethics raise as well a lot of problems that you flagged, and that is very interesting. I think we have to take those issues even in a broader account. I was struck when I read the AI principles, the ethic principles for AI of the Chinese Academy of Science. Mm-hmm. I mean, they look perfect. They are exactly the same as ours here, and as big companies have adopted before, public authorities. But at the end, I mean, it's about how they are implemented, and there is a need to take into account a much broader context, taking into account institutions, even maybe a political context. So it's complex, but ethics is definitely important, I think, for the research in AI, for the developer, for the engineers. They should stick with it, and the law is not enough. Okay, that's more than enough. Thank you very much, and sorry we could not offer the audience to, I think, discuss, unless you offer me that as organizer, but otherwise I have to close the morning session, I think. One question, okay.
You can also approach me during the lunch.
Indeed,
if you have
the speakers
questions.
Remain, so please.
I'll be sticking
one
around.
Question. So. There is one.
A question to Virginie Foussoul. Do you think you have time to wait as a commission for jurisprudence in the field of trade secrets? And do you think we will have jurisprudence in this field? Because it's very simple. The litigations will, for most of them, remain secret. Otherwise, the secrets are away. So, don't you think that there will be a huge difference? What about the importance of the jurisprudence of the Court of Justice? We know that the Court of Justice was very active in the field of IP. I saw the word activism this morning on the screen in relation with the attitude of the Court of Justice. But if there is no question, the Court of Justice will remain silent.
No, that's a very good point. I mean, that was one of the options, but like I say, I think it can be long and it can not be the right solution because, I mean, there is, of course, the Court of Justice, but before a case reaches the Court of Justice, it takes years. So we will have national courts and national case law that can be diverging. So that's not a perfect solution. But that's why we keep in mind the guidance idea. But here we have just finished a study and we can see that, and we really try, I mean, the contractor really tried. It was very hard to get information because you rightly said it, it's a trade secret. So it's a very difficult topic to get information on because people will not share their trade secrets, obviously. And so that's why it's very complicated. And that's why we try also to take some inspiration from other areas of law. I mentioned data protection, and I've just seen that in one of the texts also circulated by the Council in the context of the negotiations, we are talking about confidential measures and talking about organizational and technical measures, and we try, to see how we can better define that. But at the end of the day, first we need to publish this text on the Data Act, see how it is implemented, and then we can act quickly. Guidance can go quickly. Legislation takes some time, and now on top of that, with the, for this cycle it will be impossible. First, we don't want to reopen the Trade Secret Directive, and for this cycle it is too late. So it would be for the next cycle. But again, I don't think this is a flexible solution and something that will, meet the expectation. But guidance is still a possibility. But we don't have the data at the moment. We don't have the information and the evidence. So just like on AI, where it was decided not to act and not to solve a problem that does not exist, because you can do more harm than good. Then we need to wait. But then, if there is a need, we'll remain open to act. Yes, that's for sure.
Thank you very much. I think I got an authorization for only one question. So for the other questions, please ask them to the speakers. They are still in the room. Thank you very much for your participation in the conference.
So people will come one by one, I suppose. So I propose to restart our conference. And now to go for the panel 2. Please, Professor Bacon, the floor is yours.
Okay.
Thank you.
Thank you very much, Jean-Louis. I think people are still wandering in, but it's time to make a start. So welcome to the first of the 2 afternoon sessions, which is titled Trust in Government versus Utilization of Privacy Data. So I think you have everybody's biographies in your conference materials, so we don't need to take too much time with that. My name is Paul Bacon. I'm a professor at Waseda University. So as I say, we won't stand on ceremony. We'll get straight into the presentations. So each of the presenters will have 15 minutes. I will sort of give people a polite warning at around the 13-minute mark, something like that. But let's see if we can contain the presentations within something like 1 hour's worth of time. Okay, so I think that's that. So without further ado, let me pass over to our first speaker, Mitomo Hitoshi Sensei of Waseda University. So the floor is yours.
Okay, thank you very much, Professor Bacon, for a very kind introduction. Good afternoon, everyone. I'm very happy to be here. Last time I was here was 3 years ago. At that time, I just joined a ceremony to sign a double degree program between UCLouvain and Waseda University Graduate School of Asia Pacific Studies. At that time, I was the dean of the graduate school. And that was December 2019. And after that, we have had corona epidemic. So my topic today is it's related to coronavirus infection. So please allow me to start with a question. You must be a bit sleepy after the good lunch. So please allow me to ask a question. So my topic today is on COVID-19 tracking and tracing applications. Probably many of you have installed that. So how many of you are using that in your country? Okay, thank you. How many of you have uninstalled that? Okay, you must be conscious about security infringement. And how many of you haven't installed it yet? Oh, there's many. Okay, so thank you very much. In many countries, they have developed and introduced their own contact tracking and tracing applications. In Japan, it is called COCOA, but it is called a contact confirming application, not tracking and tracing applications. In Belgium, in Coronalat, yeah, it's okay, correct, okay. And in Finland, Coronavirukku, okay. And surprisingly, they have a common feature. I will tell you later. And when we use this kind of applications, what do we expect? Probably you want to get exact information about the close contact with a positive person. So you want to know when, where, or with whom you had a close contact. But however, you can get is much limited information. In Japan's case, we can get the information just you had contact, close contact, but within 24 hours or something interval. So, and we cannot guess, we cannot estimate who it was and when it was. And COVID-19 tracking and tracing application is a typical government-provided or public applications. In the private sector, IT giants such as GAFA have established their power already based on the data collected from users and also from other data sources. They make the most of the data collected. But what about public sector? In a sense, public sectors have lagged behind the private sectors. But for the provision of service more efficiently, the utilization of data should be inevitable. And the COVID-19 tracking tracing applications are a typical case. And it is quite urgent because the pandemic suddenly started in the beginning of 2020, and actually it started in the end of 2019. But each country developed their own applications. And as a result, the applications were adopted in many countries just to monitor and prevent the spread of infection. So my presentation today is to show the consequence of privacy protection in the public sector and the necessity of trust. And I'd like to utilize the case of Japan, and that is Japan's COVID-19 contact confirming application as an example. So we have a lot of expectations on these kind of applications. But in many countries, utilization hasn't been advanced yet. And just the answer to my question, many of them, and of course in the 3 applications in Japan, Belgium, and Finland, they use Google, Apple API. API is an application programming interface that is used for the communication between smartphones. But on the other hand, there are countries which could successfully control the infection especially in the early stages of infection expansion. For example, China. Now China is still in confusion, and South Korea, Taiwan, Vietnam, and so on and so forth. And most of them use their own self-developed applications, and in many cases, they make the most of personal data collected. And Google and Apple jointly developed API. And they say it doesn't collect any personal information, and thus it is quite privacy conscious. And surprisingly, the API is provided for free. And consequently, the 39 countries had adopted as of February 25, 2021, according to one news source. However, no evidence is found that the countries adopting the API show high performance in controlling the infection. See, on the right-hand side of the slide, it's a bit detailed, but I highlighted in red Belgium, Finland, and Japan These are not ranking, just in alphabetical order. I have listed 39 countries which are adopting Google Apple API, but their performance in controlling the infection is just average. I say there are in total more than 100 countries using those kind of applications and not using applications. So within 100 countries, the average ranking of the countries using this application is just 48.9. So it's almost the middle. It's average. So there is no difference between those using this application and those not using these applications. And the Cocoa, it's a Japanese application, and the government developed based on Google and Apple API. And it was released on June 19, 2020, and registration of positive started on July 16, 2020. And at the time, Prime Minister Abe, who was unfortunately assassinated a month ago, he urged people, he encouraged us to install this application, saying that if 60% of total population coverage can be achieved, then the application should be very effective to control the infection. However, in reality, the total number of downloads, as of September 2021, it is just reached 19.4%. And 1 year later, even after pandemic of Omicron, and it reached 31.8% in the end of August 2022. And in addition, not only downloading, for this kind of application to be effective, people who got infected should register positive in the application. But as of the end of September 2021, only 2.8% of the total positives registered as positive. Only 2.8%. If you have 100 fish, then if you put the fishing net in the pond, and within the net, only 2 or 3 fish. Others are swimming outside of the net. So you could know how it is ineffective. And even now, the figure has increased a bit, but still less than 20%. And when we adopt or we purchase something, for example, when we start using Apple Watch, for example, we would like to know how others are thinking, or how their evaluations are. Then some sort of synergetic effect would work. I mean, if applications are adopted and it has good reputation, then you must be positive to install that. So as a part of my analysis, my background is economics, not law. So as a part of my research is just examining the existence of synergetic effects, and that is called network effects, and among people, especially in downloading and also positive registration. But as a result of a dynamic time series regression analysis, we couldn't find any synergetic effects in the number of downloads. But we could find some sort of effect in the registration of positive. But it's very limited. So why? the application has been so ineffective. And the government emphasized that COCOA gave the utmost consideration to privacy. It doesn't collect any information, personal data, and use of the application is voluntary, and registration of being positive is not mandatory. As a result, people cannot receive the information that they want. So from economics point of view, it could bring very low perceived benefit. And if so, then what should be the next? Maybe people are skeptical about government-made applications, and they have some concerns about privacy infringement, and also they are afraid of digital surveillance. Then remaining measures will be, one way is to rely on the government enforcement. That means the government enforces people to install that. Or more indirect way is to create the trust in the government. So in Japan, it is not allowed. It is not allowed to rely on the government enforcement. So the only way is to establish the trust. So why trust is important? It's because it can work as a driver to generate some sort of synergetic effect. So far, we have fallen in a negative spiral just on the right-hand side. People cannot feel any they can get insufficient contact information, and that result in low perceived benefit, and that is also result in less incentives to other users to download. But it would be a consequence of the lack of trust. So if the trust is established, then we can expect to change to positive synergetic effects, like on the left-hand side. So what about the trust in the government? This is data from OECD 2021. Finland has high trust. The Finland government high trust among people, their nations. And Japan is just in the middle. And Belgium is almost the last part. This is not what I said. This is the data from OECD. And Finland is a country of high trust. And we have the presentation from a professor from Finland. So in Finland, as my impression that personal information is shared and utilized by the public sector. One typical case is just shown in the picture. So it is called National Jealous Day. And on the day, personal tax data of all citizens are disclosed. That means everyone knows everyone's income and taxation level. And that is why it is called National Jealous Day, because they can know who are rich. And maybe as a result of high trust in the government, and then it could result in high adoption rate of coronavirus. Okay, I will skip this. This is not very important. So instead of concluding remarks, I would like to raise another question. So the corona applications are mostly government-made. But if the private sector, for example, Apple or Google, had developed and released app, what would happen? So one typical case is the success of health code in China. You may think China is a centralized, the government enforcement country. But in the case of health code, that is a tracking and tracing application in China, it was developed by Tencent and installed in WeChat. It's a SNS. Most people use that. And what government did was the government provided a nationwide platform to share the data. And I think Google and Apple, they know if they develop the application, then they can get many data. But this API is provided without collecting information. So I would think they know the limitation of application without collecting personal information. So this could be another reason why the API was offered for free. So I'm sorry, and I haven't reached any conclusion. I just want to share my understanding so far. Okay, thank you very much.
Thank you very much. We can move straight away to our next API. So the floor is yours. Thank you.
Okay, yeah, very good. Works. Okay, thank you for some nice words, Professor Mitomo, concerning Finland. You know, this level of trust, some people, especially lawyers, say that level of trust, high level of trust is the same as high level of stupidity. So I hope it doesn't hold in the case of Finland. I will talk about open data and privacy and introduce some other things on the way. And first general things and then comments based on a specific project called Luxturin 5G, which is a smart city project. Let's go on. Yeah, starting with level of trust. Yeah, democracy and totalitarianism. We are paying a high cost of earlier trust in Finland. We have 1,000 kilometers shared border with Russia, and we had some trust, but lost it, and this means that lots of business contracts with Russia have disappeared because of lack of trust in various ways. And also, as we all know, the cost of energy because of this loss of trust is also high. But then looking at internally in the country, so it seems that there is some similarity between Japan and Finland because the number of lawyers is relatively low compared to number of engineers in these countries, in both countries. So I would be not so pessimistic about the level of trust in Japan. And this is apology to lawyers, so nothing against lawyers, but just as an observation. It's a measure of trust, the number of lawyers. Okay. Yeah, this is a model about data, evolution of data sharing. And it's a nice, I don't have time to go through all of this. It's a nice kind of onion model which shows how the world is changing gradually. So it's expanding from the core, from open data towards the other layers. But it's important to notice that the role of open data is extremely tiny. It's really marginal. So this picture gives maybe a different impression, but that's not true. So open data is very small. So the world is full of data, but almost nothing is open. And So actually the current information systems, the lifetime of information systems is very long, and the current information systems are mostly designed for information hiding. And technically that will continue for a long time, and also most of the business contracts and security concerns take care that this is happening slowly. It doesn't mean that we should lose hope on open data, but I just want to kind of check the reality here. Data ownership. In our projects, we collaborate actively with lawyers, and even if I have engineering background, I have faced many situations, and with the legal terms, and this has been a big trouble in our project and piloting, especially with smart city. That even lawyers. Among lawyers, it's difficult to define what actually, as we heard, data ownership is not possible. So what it is it actually? And I have learned that this data sovereignty, it's a fashionable term, but doesn't help much because it seems to be also quite unclear in many ways. So what can we exactly agree? So the simple question when engineers are designing a pilot system and trying to do new things. So a simple question, what are we allowed to do and what we are not allowed to do? It's puzzling all the time. Okay. One important thing that we learned actually is because the big bottleneck has been the business contracts between parties. Even in our research project, we have had more than 20 companies which collaborate for the smart city, which have different equipment and services, software and data sets. And it's been difficult to figure out what kind of business contracts are needed between companies to enable and trigger the data sharing activities. And some partners, I was not personally involved directly in this, but this kind of rule book or handbook, very concrete handbook was built. So if you're interested, you can find it. You can find it at this address here, and this is one thing that this kind of bottleneck. So it seems to help a little bit to improve data sharing, but there are of course technical issues, technical bottlenecks, and there is a big challenge also in understanding the value of data. So companies have difficulty to understand that what is the price tag for my data set if I open it up and give it to others, and what can I lose? So what are the pros and cons? So which is kind of business assessment, and that is very difficult. So that's one bottleneck as well. Then regarding open data in Finland, the Finnish government has been very active in pushing. The ministries have helped here and we have this, you can see the address there, www.avoindata.fi. So you can find there also in English language the information about different data sets, and you can see some statistics here. So there are examples, and there is experience about open data in different sectors, and this, together with the rule book that I referred to, and with the guidance on how to use these interfaces, that's pretty good basis, and this gives an idea on how these different open data sets are and the service interfaces that they provide, how they are divided among different categories, and I will be talking a little bit more about this Luxturin 5G, which is a smart city type of thing belonging to this category. There is also an interesting activities in the health sector with open data, and this Kanta.fi, it's for all citizens, kind of a joint database which stores all your medical health data and all your prescriptions, and so it works with pharmacies, so no paper needed, and you just go from doctor to pharmacy and pick up drugs and all the laboratory results and whatever. So it has been expanding pretty rapidly, and there are also Of course, the privacy is a big issue, so it's currently very well managed, taking care of privacy. But it also provides interfaces to anonymized data sets, so for researchers, for instance. So there is quite some amounts of money that has come to Finland, and also researchers, for instance, from the US, where it's much more difficult to get access to this type of data. So as it was mentioned earlier, related to some other types of data. So Finland maybe is a paradise related to health data, getting access to national health data. But I will not be talking more about that, so I will focus on this Luxturim and the smart city. Smart city, using that as a case. And sorry about this is a very busy slide here. I'm not going through it. This is just the connectivity platform side from our studies, and this is the actual data platform for cities, and this is a structural analysis that we have made, and here you can see the international cloud provider value network configuration and some parameters for that. And so this is essentially the Google type of players. So Google actually has very good resources on the type of data which help. If you think about street level services here in Brussels, for instance, so you probably want to use Google Maps to navigate, and you want to use Google to find the store that you want to buy something in, and to find restaurants. So actually the international giants, they have got a very strong grip on cities, and this is a big question for city management and also national management to figure out that how can we sell our cities to international giants, or should we be more egoistic or nationally aware of how to organize this. And this right-hand side, neutral data operator-driven value network configuration, this is a solution where the city is controlling, opening up their information systems that are currently mostly in silos and data sets, and how to get value out of all of that data on the city level. And these are kind of, our project has focused on this neutral host model, this city-centric model, of course. Then we of course have the, yeah, please. Value network configuration, or it's actually, it combines the technical architecture plus the value network interactions, kind of transposing them on top of each other. But you can think about it. There's lots of detail here, but it's like value networks. So it's a question of strategic game with value networks about who controls what and who takes which business role and so on. Pardon? Mobile network operators. Mobile network operators, so they are also in the game, and they would also be willing to take this role. So they could help the cities, but they could also like take over, and the cities would be in smaller role. But then it would be more national anyway. Even if cities would not be driving it, then at least national. Okay, but yeah, this just shows how the different businesses, different data sets and services on top of the platform would form, and there's been lots of discussion about killer applications or the important driving services that would kind of kick off this type of new services. And maybe just kind of clarify the background a little bit. So this project that Nokia has been driving it's very big, and the main idea has been to install smart poles, smart light poles in the city. So we have a couple of pilots where there are lots of smart street light poles where there are all kinds of sensors, including drone landing stations and charging electric vehicles and bikes and cameras and air quality monitoring and all. So it's kind of poles which do everything more or less, and the challenge has been to figure out how this can be happening. I was mentioning that in referring to totalitarian countries. So there, the ownership is not the problem. So this is either city or more likely a national government-driven initiative, and it is far ahead of Western countries in many ways because there are no legal problems and privacy issues there. So as we all know, but technically also that has allowed kind of a leading-edge situation for totalitarian countries, technically, but also process-wise, knowing about how all of this merge of data is organized and so on. So there's lots of things to think about in democratic countries here. But okay, I mentioned this killer application. The first one is easy. So actually the current mobile services and the evolution path, that should also happen on these smart poles and on street level. So that's obvious. But then thinking about the next possible killer application, I don't go into any details. This was the Helsinki city center analysis, kind of time series analysis, quantitative analysis. It quite clearly shows, including a sensitivity analysis, that the video traffic will be the big capacity issue and expanding heavily. So it's kind of a possible second answer to this killer application, different use cases of video, but it is actually also the most sensitive to regulation. So the regulator and lawmakers can make or take this opportunity, really. So it's very sensitive to everything that we have discussed today. Then there is about pilot use cases. This shows, okay, very good. I'm finalizing. Yeah, this is the different kinds of use cases and services that we have been experimenting in the pilot, and more or less the observation is that the kind of third answer to killer application is this safety on street level. People are ready to pay and appreciate. Consumers seem to appreciate safety quite a lot, and also politicians, they have to. It's easy to politicians to promote safety. So the situational awareness using digital twin technologies and so on. So it is related to several of these use cases, and that seems to be one of the driving things as well. Then, kind of summarizing, we actually had to postpone 6 months for several of these services because of GDPR. It looked very bad initially, but then all these different companies and their lawyers, business lawyers, and then the research side lawyers were able to figure out how to change processes. Also, the ministry was involved as a partner in this project, so they were positive, and these problems were solved. So the conclusion is that it's not blocking. GDPR is not blocking this. Yes?
Quick question. I'm just wondering whether any of the projects that you mentioned have ever been stress tested with what adversaries could be doing if they got access to the data or to the infrastructure itself.
That has been discussed, of course, but this is a pilot project, and in that sense, the experiences are limited. But of course, the question of it's part of the GDPR also to increase the probability that incidents are not happening. Good question. Okay, but so law is slowing down, but GDPR is also enabling this type of pilots, so no big complaints regarding that. Okay, thank you.
So thank you very much, Professor Hämäinen. So next up, Vincent Mabillard. So Vincent, the floor is yours.
Okay, thank you very much, and thank you for having me today. So I'll try to keep my presentation very short so that, Chloe, you still have some time to present your paper. And I will start with a very short message. A key message is that it's very difficult, actually, to understand and to conceptualize what trust is and what transparency is. And depending on how you define and how you address these terms, you can come to very different results and very different interpretations of the relationship between trust and transparency. And that's what I'm going to present and then give you a very concrete example. So transparency can be addressed in very different ways. It has been generally defined in the public management literature as the availability of information that actors can have about other actors or other organizations, and this will enable them to actually monitor the performance or what the organization is doing. But apart from this question of availability, you have other authors that have said that other key elements, components are very important to define what transparency is. And here you have the fact that the information must be usable, it must be accessible, and it also must be inferable in terms that, in the sense that people must be able to understand, process the information, and understand it to use it then. Otherwise, it's not really, really transparent if it's just available but impossible to understand the information and to use it. And although transparency has raised much interest in the last few years, especially due to the passage or the adoption of access to information laws, it has been praised for a long time, several centuries here in Europe, starting with Jeremy Bentham in the 16th century, talking about the importance of being more transparent to avoid corruption and to improve the quality of government. And it has been actually also praised by the Council of Europe and the 10 principles of good governance, so we've shifted from government to governance. And here transparency is a very strong idea with two different, let's say, approaches. One is more related to the intrinsic value of transparency, so we should be transparent for the sake of being transparent. And the other approach is more related to the instrumental value of transparency. So the instrumental value of transparency to promote other goals of democratic governance, reducing corruption, increasing participation, increasing efficiency, etc., etc. And of course, it can be also regarded as more an administrative task or an administrative practice than focusing on the managerial challenges regarding the implementation of transparency within the public sector. I'm not going again through this difference between intrinsic and instrumental value, but what's important on this slide to see that when we talk about transparency as a tool, as having an instrumental value, of course, trust is very important here. So one of the instrumental values of transparency is to increase trust, meaning that the more transparency you have, the more trust you will create, or at least that's a presupposition, an expectation that we have and that many organizations have when they say we want to be more transparent. We want to be more transparent to increase trust. But at the same time, it can also be addressed as an obstacle because there are many different trade-offs between transparency and other things. For instance, privacy. It's very important to reach some sort of balance between transparency that you want to increase in your organization, in your communication with other stakeholders, and other things that can be in jeopardy when you increase transparency. I'll just skip that slide for the sake of time. So now turning to trust, why is it linked to transparency? Once again, because the more transparency you have, the more trust you want to generate, you want to create. But once again, it's a very multi-dimensional concept. Before we had statistics about personal trust, I think. But if you think about trust in general, it can happen at many different levels. You can have trust in institutions, you can have trust in organizations, you can have social trust, so trust in the society in which you live, and then of course you can have personal trust. And when you want to measure that, it's very difficult because, for instance, if you want to measure trust in government, are you trusting the government? Are you trusting the Prime Minister as someone acting as the Prime Minister, or are you trusting the Prime Minister as a person? Do you have trust in that particular person? It's very difficult, and then of course can also change the results and the interpretation of the responses that you get from the people you survey, for instance. But here I will focus on institutional trust, which is a conviction or faith that the institutions in which you place your trust will be fair, will be reliable, will act in a competent way, and will be non-threatening to you. So in the research, what most people have done is that they've tried to operationalize trust with the concept of perceived trustworthiness. So how trustworthy an organization is. And here you have three main criteria. So the organization must be competent. So this organization is using the available resources in an efficient way. The organization is honest, and it also benevolent and shows goodwill. So the trustees' dispositions are favorable to your interests, and they're not the organization is not trying to take advantage of you. These are the three main components of this perceived trustworthiness, and that's how it is mainly addressed in the literature in public management. But in reality, it's very difficult to grasp these different dimensions. That's why organizations, for instance, the OECD, come up with a very simple question, which is, do you have confidence in your national government? Or if you take here the Pew Research Center in the US, they will ask people about the trust they have that the government in Washington is doing the right thing. And here you see that there are very different results from the graph that we saw before regarding personal trust. So it really depends on how you measure these concepts. So now how do we link the two? That's a big challenge. So it's first of all not unidirectional. So most studies tend to address these two concepts as having a linear relationship, so more transparency, more trust. But actually many people and many studies have shown that it's sometimes the other way around, because you need a certain level of trust to then act in a transparent manner. So it can go both ways, and it's not that easy, you know, to link the two. At the same time, some studies have also shown that in certain cases, transparency may be detrimental to trust, especially when sharing sensitive information. And something that is very important here, I think, you always have to keep in mind that when you're trying to establish the link between the two, it's very difficult to actually find the different factors that have an impact on trust. Because transparency is just one of them, right? You have lots of different factors that have an impact on the trust that you may place in a certain organization or in other people. But at the same time, you still have many studies that tend to explain the relationship between transparency and trust in a linear way, using these other factors as, for instance, mediating variables. So if you take another variable, it may increase or decrease this relationship between transparency and trust. And for instance, here I know a study where a policy area can have a mediating effect. So depending on the policy area that you take into account, you can have different results in this relationship between transparency and trust. And in the literature, actually, if you look at all the studies that exist, or at least the best scientific studies that were picked by Cuciniello et al. In the literature review, you see that you have less than 40% of all studies that have actually highlighted a positive effect of transparency on trust. So in the case of COVID-19, data were mainly used, or information that was communicated was mainly used to increase legitimacy of the measures that were taken, and of course increase trust, because the more trust you have, the more, let's say, compliance you will have from citizens. And that was, of course, key for governments during the crisis. And here they preferred proactive transparency, so lots of press conferences, online dashboards, of course, information in the streets. Websites also were very used. And here what we see, and I was talking about different factors that have an impact, and one of them is actually the pre-existing level of trust that you had in institutions. In these countries, the level of trust was then increased with transparency. And also in countries where you have well-functioning policies, especially welfare policies, the impact of transparency on trust was also greater. And in certain countries, I think it was especially the case in South Korea, they relied on the past crisis where they saw that actually the communication was not that great, and they made efforts to improve their transparency in terms of how they communicated with the public. And actually, they relied more on evidence-based policy, so communication about evidence-based policy, and that had the effect of increasing trust in the state actions. But I think, and this will be the last slide, what is also very important is how the trade-off between transparency and privacy is perceived in the country. And this will also have an effect on the relationship between transparency and trust. For instance, in South Korea, they had a survey in the whole population, and people said 85% of the people said that they preferred to have transparent information about the movements of the infected patients over privacy protection. So there, if you're transparent, of course, you will increase trust because people are ready to have this kind of transparency and this kind of communication. But what if the number there is 25 or 20%? Can have completely different results. In Canada, there was a recent study that showed that people are less reluctant to share their health data if they have more information about how their data will be treated. So here, once again, it's important to have some basis of trust, so you know what organizations are going to do with your data, to have this transparency, to be efficient in the relationship that you have with the citizens. And then the final point relating to tracing apps. Here we see that in a context where transparency is quite high, but also trust in government is quite high. If you have a frequent disclosure of accurate information, once again, evidence-based policy information, then you can generate more or create more trust in the measures that are taken, the tools that are used in the crisis, for instance, tracing apps. Okay, I hope I wasn't too long, and Chloe, you still have some time for the presentation.
Thank you very much.
Well done.
You were very brief. That was 10 or 11 minutes, so congratulations. So, our final speaker, so we do have 15 minutes for you.
You don't use it? Okay.
Yeah. So, Chloe Bier of ULB, so the floor is yours. Yeah, please.
Can you hear me? For the sake of time, I decided not to use the PowerPoint so I can condense my ideas in a more dynamic way. So what I would propose to address today is something a bit different. It's still collection of data, still a question of how public authorities will collect data, but this time not for health regulation purposes, but for security purposes. And I want to dwell on one aspect of it, that is called data retention. That is an obligation imposed on private operators to collect traffic and location data on users of telecommunication services. And what I will try to do is a plea in favor of lawyers and the law to try to set some limits in the way this type of exercise is carried out. And as I am a specialist of EU law, I will try to see whether EU law itself may play a role in ensuring that while there is a legitimate aim in collecting and retaining data for security purposes, there are sufficient safeguards and limits that are provided in the law to ensure, well, a certain transparency in why this data is collected and how the people those data is collected and privacy is potentially violated can seek remedies or obtain clear explanation as to why the data is being collected. So what I will do is discuss briefly 3 points on what are the law adopted at EU level and the limits they might have. I'll try to show as well how the judicial review by the Court of Justice of the EU may help in favoring trust by guaranteeing that there is a fair and proportionate balancing exercise between security and privacy that are two of the competing interests here. And I'll conclude showing the limits of this balancing exercise. So I won't make you a whole expose about what the EU has done in this field, but maybe just to start to explain briefly what is data retention about. So it's whenever we use our phone or we go online, the service providers are obliged to retain certain information as to the place or the time when this data has been, when we have gone online. They have an obligation to retain that data for a certain period of time, providing that then later public authorities, notably those involved in safeguarding security, may be allowed to access it for various reasons. The reasons invoked by national legislations are often linked to security. It goes from the defense of national security, preventing a terrorist attack, for instance, to more precise security purposes, such as the investigation or the prosecution of a specific criminal case, of a specific criminal offenses. But still, no matter whether you are concerned or not by such investigation, the retention of your data constitutes an interference in your right to privacy. And scandals, such as the one revealed by Edward Snowden with the huge data retention exercise carried out in the US, have eroded a bit the trust of the public in this type of exercise. And there has been discussions within national and EU legislative circles, but also within courts, to try to find the right balance between, on the one hand, the objective of protecting security, and on the other hand, the objective of ensuring the privacy of those who use such services. Starting with my first point, at the EU level, the EU has been thoroughly active in adopting legislation that may be relevant to ensure the privacy and the balance between data protection, the pursuit of security objectives. And I won't discuss all the instruments that have been adopted. I will mention just one that was specifically devoted to data retention, the Data Retention Directive adopted in 2006. That has been annulled in 2014 due to an incorrect balance that I'll come back to. And another one, the e-privacy directive, that seeks to preserve the right of privacy of users that use certain services. These two instruments have one particularity, is that they are adopted on the basis of the competences of the EU in the field of the internal market, and they impose obligation on economic operators, making them collaborators of these security objectives. These instruments, they tried to carry out a balance between the different objectives that are pursued, ensuring that the right of privacy and the protection of personal data is balanced with the need advocated by member states, by national security authorities, to have access to this data in the course of their activities to prevent crime or to prevent threats to national security. And the EU law instruments tried, to a limited way, to provide common standards throughout the EU territory and beyond, ensuring that the operators offering their services in the EU know what is the law applicable and what are exactly their obligations whenever they offer services to EU citizens or persons living in the EU. However, what we see, and it's a first limit here of the law and the standards provided in the EU, is that very often what is provided are minimum standards, leaving a margin of discretion to the national authorities and the national legislators to transpose these instruments in their national legal orders. Which means that, for instance, this Data Retention Directive that was adopted in 2006 was annulled in 2014, but its annulment at EU level did not mean the end of data retention as carried out in national, as provided for in national laws. And that's where, for instance, the Court of Justice of the EU came as a potential arbitrator, as it was seized by numerous challenges of national legislations by organizations particularly involved in the defense of privacy. And at this occasion, the Court of Justice has been seized. I think there is now more than five judgments, most of them in grand chambers. The Court of Justice tried to offer to the national legislators, but also to the EU institutions, a guideline about how this balancing exercise could be carried out. The message that is put forward is quite clear, that general and indiscriminate data retention of everyone is prohibited under EU law. However, what we see in the case law of the Court of Justice is that there is a possibility under certain circumstances and pending certain conditions to continue targeted data retention measures. I won't have the time to enter into the details of its judgments, but just to give you a brief idea of what the Court of Justice is proposing, the Court is establishing a series of legitimate public interest objectives that it ranks by an order of importance, from national security to the combating of serious crime to the prevention and investigations of criminal offenses. And this typology of security objectives is important because the Court establishes in its case law a link between the objective pursuit and the seriousness of the interference that is allowed in the rights of privacy of the individuals. To give you an example, once, if the national authorities claim to pursue an objective of national security, such as preventing a terrorist attacks, the interference into the privacy of persons by asking economic operators to retain more data on a more general basis may be allowed, pending that, again, specific conditions are provided. The legislators and the authorities have to establish, for instance, clearly the purposes for which such surveillance is undertaken, the conditions under which this data retention is allowed, and what are the safeguards provided in terms of time period and whether the persons concerned have a right of remedy. But there, and I will conclude there on the limits of the law, is that even though you have these very clear messages provided in the EU law instruments and in the case law of the Court of Justice, there are still margins of appreciation and political consideration that continue to play at national level. To give you an example, one of the cases of the Court of Justice, known as La Quadrature du Net, concerned the legislation applicable in Belgium and in France. In both, the court joined the two cases and considered that, provided the answer I just gave you, inviting the national judges to carry out this balancing exercise and test whether the national legislations that did allow in part for general and indiscriminate data retention would be compatible with EU law and with the guidelines that the court had given. And even though the two national judges received the same instructions or the same guidelines from the Court of Justice, they came up with different solutions. In Belgium, the Constitutional Court followed the judgment of the Court of Justice to the letter and annulled the national legislation, whereas in France, the Conseil d'État, via an, I would say, innovative interpretation of the case law of the Court of Justice, considered that, in fact, the national legislation was justified by a threat to national security as required by the Court of Justice. And this shows the limits of the law, especially in situation or issues concerning, I would say, sensitive public interests, such as the defense of national security. As we see, even though there are clear legal guidelines, the implementation and the interpretation of how they should be implemented is not always the same. And just to conclude with two lines, and I saw the questions and I will reply to them, just to mention that regardless of the instructions or the guidelines given by the Court of Justice, the national legislators and the European legislators are still exposed to pressure from, I would say, security actors to have access to this type of data. In Belgium, for instance, the legislator proposed a new law following the annulment of the previous one that still allows for a certain type of data retention and angers privacy activists in Belgium. And at EU level, we saw, for instance, the recent revision of the Europol regulation that was finalized just a couple of weeks ago, in which the EU legislator legalized a posteriori a practice of the agency of dealing with huge data set that it was not supposed to have in its hands, showing that even though there are attempts to set up legal limits, the would say the concerns on security matters and real politics do influence still the balancing exercise that is carried out in national legislation and practices. And I'll stop there.
So thank you very much, Professor Brière. Thank you. So we still have 5 or 6 minutes for Q&A. So is that okay? Yeah. So, but thank you. So please make your questions brief and clear and indicate clearly who your question is for. So I can see one question at the back.
Yes, do you think then that there would be arbitrage by the adversaries and their attackers, particularly disinformation attacks, for example, to go through the jurisdiction that interprets the European courts of state in the weakest way possible, and through that have a basic door into the rest of the Union?
I'm sorry, I'm not sure. You mean whether this can be used?
So the Conseil d'État France and the Belgian data interpretation will probably provide a door for an attacker to enter the Union through the weakest possible interpretation. I'm just wondering whether the actual interpretation of the European Court isn't opening the door for arbitrage possibilities.
Yeah, no, it might. I mean, like the thing is, like the difficulty here is that since the court does not, like, even though you have an attempt to have like common standards, the harmonization effect of the EU instruments is limited. The data retention directive has been annulled for some years now, and as far as I checked, there is no proposal yet to address again this situation. So the Court of Justice becomes the quasi-legislator in that field. And I agree that because of the let's say, differences in level of protection that are granted and the differences in the rules that are applicable, you might have a bit of forum shopping by security actors. It's something that has been already expressed as a source of concern. Especially because these legislations are not developed in isolation from other initiatives or instruments that foster cooperation between national authorities and security services. And so there is clearly like a risk that, like it's what happened with Europol, for instance, that the member states that have more lenient policy will collect the data for the others and share it with European actors. That will undermine the protection of privacy and this balancing exercise that the court has been trying to realize. Yeah, that's one of the difficulty here.
Thank you. I can also see a question from Simona.
Just really quickly for Professor Briere as well. I'm just wondering, in terms of data retention, whether the instruments that the European Union has right now are at all connected with instruments regarding the reuse of that data. We know that once security actors or even private sector actors get their hands on the data, they tend to treat it as their data institutionally or corporately, and make use of it in other circumstances. And with the advent of AI and machine learning in particular, that opens way many doors in terms of violating privacy. I was just wondering what your thoughts were on that.
I would have to double check the legal instruments, but I think one instrument that might help and one element that might help is the current discussions on the e-privacy regulation. It was a directive that applied for economic operators and to protect the privacy of users using telecommunication and other online services. The EU legislator is now engaged in a revision of that directive, and to transform it into a regulation, which should have a stronger effect. And I don't have the text of the proposal in it, but I would bet that there's probably here something about consent and subsequent use of the data. I would imagine so, but I have to double check.
Does that include also the stacking of data sets from multiple security actors?
I will have to check that.
Which has been very problematic in the US. We've seen
that. The privacy regulation does not apply to what security actors do, and that's one of the complexity here, is that depending on who is collecting the data and storing it, it's different legal instruments that apply. So, for instance, if you talk about the actions of Europol, the European Police Agency, their data protection regime is set in their own instrument and in a specific data protection regulation applying to EU institutions, agencies, etc. So it's one of the drawbacks, that the transparency and the accessibility of the information on who might have access to the data and how, as an individual, I can check how my data is used. Suppose it as a high entry cost just to understand which instruments might be the relevant one.
Okay, so we've come around to 20 minutes past, so I think we should end it on time there and respect the schedule. So thanks very much to our four presenters. for their thought-provoking sort of contributions to this conference. If you did have a question for them, you can sort of pester them politely over a coffee downstairs. So I think let's wrap it up and let's move to the coffee break. So thanks again to our presenters.
As any good conference organizer knows, you put your best panel in the end, the graveyard shift, so that you can keep everybody's attention. And so we kept the best for last. Our panel on emerging technology, cybersecurity and disinformation, social science and legal perspectives crossed. I'd like to highlight the fact that this panel is not only a product of the Waseda Brussels annual conference, but is also part of another project, the Jean Monnet on cyber diplomacy. And so we have here a cross-cutting of various research projects on an area of concern for both the EU and Japan. And obviously in today's world that is feeling increasingly at least maybe unsafe or threatening, questions of cybersecurity are certainly at the forefront of all of our minds. One of the speakers who is appearing on the screen, Professor Burton from ULB, Associate Researcher at St. Andrews University, will be joining us online, and for practical technical reasons, I'd like to start with him. So we will invite Professor Burton to give his presentation. He has PowerPoint slides which he will present himself, and then we will move to the panelist members. I'm very sorry we will not do a question and answer with Professor Burton for technical reasons again, but you can collect the questions and other people can put them to him later. And that just gives more time to ask tricky questions to those who came in person to the panel. So without any further ado, the floor is Professor Burton's, and normally you're ready to go. So thank you very much, Joe.
Thank you, Frederick. Can you all hear and see me okay?
Yes.
Good. So firstly, apologies. I had intended to come to ULB in person today. I'm very sorry not to be there with you to discuss these matters in person. I have a new job in Scotland and a rather heavy administrative load, which they've loaded up on me, which meant I had appointments today and yesterday here in Scotland, so I couldn't travel. But I do wish you all the best. I hope to catch up with you, some of you soon, and of course, follow up on the research aspects of the presentations today. So it's great to be with you virtually at least. I'm going to jump straight into the presentation and I'll just share my screen. Hopefully you can see that okay. And I just really wanted to start by saying that this work is really a product of the last 3 years. I'm very fortunate to have been a Marie Curie Fellow at University Libre de Bruxelles over the last few years, working on a European Commission funded project called CyberCult, Strategic Cultures of Cyber Warfare. And the research that I want to present today, I think is the product of that 3 years and some of the key findings and outputs from that project. And what I've been doing really is looking at the emergence of this cyber war phenomenon. It's estimated now that there are over 60 nation states that have developed what we would call offensive cyber warfare capabilities, OCC, defined here as virtual or physical tools to disrupt, delay, destroy, or exfiltrate information from computer networks. These capabilities are spreading in the international system. There are more and more states acquiring these capabilities, almost on a weekly, if not monthly basis. And I really wanted to explore this phenomenon in my project. I found when early on looking at this phenomenon that most of the existing explanations for the spread of these capabilities to states and indeed non-state actors are founded on materialist or rationalist assumptions. These include the oft-cited realist idea of a security dilemma that exists between nations, i.e. one state develops offensive cyber capabilities, this causes fear and mistrust in another state, which then does the same. and or the relatively low cost of these capabilities as compared with more conventional military assets. So the argument here is, look, we can achieve cyber effects for relatively little cost through, training some people to run malware on computer systems, and that will save us money in terms of buying high-end military assets. You hear this argument quite a lot. And or the spread of these capabilities predicated on the idea that they can achieve military and intelligence effects, including through espionage or by perhaps displacing or providing an alternative for the use of force on the battlefield. So these were the sorts of sets of explanations that I saw in the literature coming into the project, and really I wanted to take the explanation of this phenomenon a little bit further. So basically the arguments in the paper today and the ones that I build in the project is really we need to move beyond these set of explanations. In my view, accurately explaining the use and development of OCC requires us to think about particularly the strategic cultural drivers of cyber security, including those that exist in transnational hacker, military, industrial and epistemic, including academic communities. By this logic, offensive cyber is really a socio-cultural phenomenon that emerges from ideas, behavior, practices. These are the elements of strategic culture, at least, that exist and are embedded actually at a variety of different levels within our society and our politics. There are subnational strategic cultures, which I've examined in the project, including hacker culture, military culture, and corporate culture, industrial culture. There are various cultures at the state level, which I think have been formative in the spread of these sorts of capabilities, including among the great powers. And there are also supranational cultures, which have, I think, in many ways fueled the development and deployment of offensive capabilities, through international organizations, including those such as the EU and NATO. So really, this is the project graphic on the right, which looks at all the different types of cultures that exist, that I would argue are fueling and contributing to the spread of these capabilities within the international system. Let me take you through some of my core research findings across those three different levels of analysis: subcultures, national cultures, and supracultures. When it comes to subcultures, we're talking here about cultures that exist within and beneath the state level, and transnational cultures. And I looked at three of these. Again, hacker culture, hawks, which is the moniker for military culture, and hawkers, which is a moniker for essentially a weak, permissive security culture that exists in the corporate sector, which contributes to cyber insecurity. And in mapping out the ideas and the practices and the behavior that exists within these cultures, I observed various things. Within the hacker culture, for example, there is a focus on secrecy and covert action, an aversion to authority, the tendency to share malware or exploits within the hacking community, this idea of freedom of information as an animating discourse and idea. Of course, if you're attached to freedom of information, you might take measures to hack into those information systems and release it. It is a culture in which I think often the consequences of attacks are ignored or marginalized. The discourse presents the internet as gated and is based on weapons metaphors. There is a certain depiction of hacker communities which contributes to the emergence of the cyber warfare phenomenon and the spread of capabilities. The internet is something to be feared, cyber noir, as James Shiers has described it. A pursuit of technical expertise and a decentralization or declassification focus, wanting again to liberate information. When you look at the or hawkish culture that exists in military establishments, these same sort of ideas, discourses and behaviors have contributed directly to the spread of these sorts of capabilities. This includes the framing of cyber as an existential threat, leaning on Cold War concepts to talk about cybersecurity threats, including the centrality of deterrence, again, an attachment to secrecy, interinstitutional competition between organizations, the desire to develop OCC see for power projection or as an alternative or equivalent to military force. You know, the equation of cyberspace with physical territory, and again, that affects discourse that I mentioned earlier in the piece. Within the corporate sector as well, there is a subculture, I think, that has contributed in negative ways to the development and profusion of offensive cyber capabilities. Low risk estimation, a groupthink that exists within corporate sector, a weak organizational culture which has led to cyber risks proliferating, a desire to rapidly release cybersecurity products to the market without particularly good security testing, the existence of long-term unmitigated security flaws in software and hardware that's provided by corporate cybersecurity firms, a lack of security knowledge generally in the sector, an attachment to profits over security, and an aggressive pursuit across lots of different internet platforms of personal data, the acquisition of personal data for purposes of commercialization, which of course has led into lots of high-profile security breaches. There's also, I think, been a wider fear in the corporate sector around reputational costs associated with cyber attacks, a failure to disclose information. There was a famous case in Japan around Mitsubishi Heavy Industries, their failure to disclose a major cyber breach, which led to the exfiltration of weapons technology, and relatively weak information sharing between the corporate sector and governments in this area. So if we look at hacker culture, military culture and corporate culture, the ideas, discourses, behaviors that exist in these cultures, these have all combined, in my view, to again encourage the proliferation of offensive cyber capabilities within the international system. I'll just briefly take you through some of my findings at the national level and the supranational level. I looked at a range of cases at the national level, including the United States, Israel, Japan, Germany, and New Zealand, as case studies of how individual nations pursue offensive cyber capabilities. And there's a broad division here between what I would call the warrior states, such as the US and Israel, who are much more offensive in their cybersecurity doctrine, discourse, behavior, and ideas, and a group of states that I would call reluctant cyber powers, leaning on previous literature in this area, including Japan, Germany, and New Zealand, who have been, for obviously historical reasons and cultural reasons, much more reluctant to weaponize cyber capabilities and develop cyber warfare capabilities. When we look at discourse in the United States, it's all about persistent engagement, defending forward in cyberspace, the denial of safe havens for hackers, the Monroe Doctrine, preventing cyber attacks against the Western Hemisphere, and an exceptionalist discourse and practice that really presents the United States as the world's global policeman of the internet. And this again feeds into their doctrine and ideas like layered cyber deterrence, as pictured here. Again, if you look at the softer cyber powers, much more of a focus on resilience, the softer signaling of the capabilities that they are perhaps developing, a focus on cyber crime as opposed to cyber war, and much more focus on the governance of IT, including the development of norms in this area. Finally, and not least, my project looked at supracultures, so looked at how international organizations affect the proliferation and development of offensive cyber capabilities. I'll keep this pretty brief, but the two organizations that I looked at were the EU and NATO, and I found really that in some ways the EU does have a strategic culture, but it's not that strategic. Obviously, it's a more peace-oriented culture that's committed to peaceful resolution of disputes, a broad resistance to militarizing and securitizing the EU's role in the world, and their cybersecurity strategy is therefore much more defensive, regulatory and legalistic, more oriented towards economic markets and resilience rather than those harder concepts of deterrence and disruption. And I think there are perhaps some change in this. I'm sure this has come up today, I think in some ways due to particularly the digital sovereignty agenda that's emerging within the EU. The EU is looking to become a more assertive actor in cyberspace, not that it will develop its own cyber capabilities, and that there are strategic cultural breaks to that process eventuating. NATO, again, has a strategic culture which I think is distinct and has been quite well studied. It's based on, a much more defensive territory, which has not been a great match for cyber threats historically. Evidence of a tension between offense and defense as well within NATO. NATO casts itself as a defensive alliance and has had to find ways to overcome that strategic culture and think about how it might use those offensive cyber capabilities. And there are various internal clashes actually within the strategic culture of NATO between perhaps the US's more assertive position on the one hand and the more defensive positions of some NATO member states, including countries like Germany. Also tensions we see over 5G, threat perceptions, and the variants of that within the NATO membership mean, I think, in some ways that NATO's collective strategic cultural security culture has been a diluted influence, in this case, on OCC spread and development, and very much within NATO a system of collective defence, cyber seen as a domain of operations, the creation of sovereign effects. All problematic concepts in some ways from a strategic cultural perspective based on NATO's historic role in continental defence. So that again is a summary of what I've been doing over the last 3 years, looking to ascertain the influence of strategic and security cultures at a number of different levels of analysis. One final thing that I'd say is, well, what does this have to do with regulation? If you're going to regulate cyber, if you're interested in preventing the spread of OCC, then my research, I think, very much shows that you need to focus on ideas, behaviour, discourse, security practices. Taking this more socio-cultural approach, I think, will allow us to regulate this area perhaps more effectively than has been done so far. I'll stop there. Thank you, Frederick. And again, sorry I can't join you in person.
Thank you very much, Joe. I think we can thank him. So we will have the opportunity to interact next time you're in Brussels or when we see each other elsewhere. But building on the framing elements and the security culture elements set out by Joe, we can now maybe delve into 3 more specific cases. Maybe I can ask Simona to start. We'll go, well, no, maybe, sorry, Tatiana. We'll just go in counter order. I thought we would go.
Yeah, fine. I actually thought that I would be the last presenter. I'm happy that I'm not, because I think that my presentation is more of a, setting the overarching scene from legal and regulatory perspective. So one moment, I'm going to start the slides. And as a bit of disclaimer, I'm going to talk about regulation, but I'm going to talk about regulation in a traditional understanding. Command and control, laws, regulatory instruments, and regulators. This disclaimer is important here because I do believe that when we say regulation, we can understand it in a much broader sense. Markets regulate, right? Emerging technologies are indeed regulated by markets. Social norms of behavior regulate as well. You cannot hear me well, right? I'm sorry about that. Technical architecture regulates. So I'm talking here about written command and control regulation. So in terms of emerging technologies, and by the way, I do not like this term a lot. I actually quite dislike it because it's an umbrella term which lumps in a lot of technologies, and some of them have been with us for a while. Think about 3D printing, which is labeled as emerging technology by many, or the IoT. For how long do we know both of these? For quite a long time, if we look at the technological development. So, however, still, even then, being here for quite some time, the fast development pace of these technologies poses a lot of challenges for regulators. Well, first of all, if we think about traditional regulation, right, there are always like sectors and regulatory mandates. But when we think about security and cybersecurity risks which is posed by these technologies, we have to think about convergence of this traditional regulatory domain, like let's say medical devices safety or children toys safety, with highly complex and overloaded cybersecurity domain. And this complexity of technology requires a very particular expertise. And the lack of this expertise and also the availability of information about risks, availability of information about technology itself can pose the challenges to these already traditional and slow, like elephants, traditional regulatory domains. So this kind of fast development and quite a slow uptake, and this is not, trivia to say that the uptake is slow. It is slow. Again, I'm coming back to my example with the IoT, how long it has been with us. It creates these policy and regulatory gaps. And not only because there is nobody to intervene, but also because at some point there was a decision taken not to intervene, or several regulators were looking at this domain and saying, well, perhaps this is not my mandate, perhaps I'm just not stepping in. And also, if we think about innovation, on the national level, on the regional level, innovation always offers what? Competitive advantage, right? I want my nation to be competitive in technological development, but in this regard, sometimes cybersecurity risks are getting overlooked. So cybersecurity versus innovation has been perceived as some kind of dichotomy for quite a long time. I would call it a false dilemma. However, so what are the particular challenges posed by regulators? And is regulation still the answer in this regard, right? Okay, technology is developing, we cannot provide this uptake. Do we still have to regulate? Maybe there is something else, maybe we will leave it to the industry, let them do it voluntary. I would say, looking at the cybersecurity landscape, yes, regulation is the answer. The question is, how? So there is a lot of conventional wisdom in this regulatory idea about emerging technologies, like, let's say, soft law. We're not going to provide any hard guidance, any command and control instruments. Let's agree on some principles and let it go. Again, my example of the Internet of Things and cybersecurity risks. There were certain guidelines created by standardization bodies like ETSI, promoted voluntary. Still, cybersecurity risks for the IoT is very trivial. In some countries, devices are still being available where the default password is not changed by users and can be found. Then, of course, this idea of collaborative approaches, of the flexibility of regulation, of anticipatory regulation. With all these great ideas, the question still remains how. And if we look at how this conventional wisdom manifests itself in reality the picture is a bit different. And the first point, and I am again, if I may, go to the IoT or another example of AI, for example. How quickly can we assess and reassess the need for regulatory intervention? In 2016, there was an attack of Mirai botnet, which used the vulnerability of the IoT devices like light bulbs, like baby monitors, like Wi-Fi routers, which were not protected enough, which had default passwords. 2016, think about this, 6 years of technological development, and we still have the same problem. Somewhere in 2016, there was an idea, okay, let's issue the guidance, let's issue something else. But I'm going to make an example of the United Kingdom. They came with the idea of the IoT law and IoT regulation based on this idea of consumer protection, no default passwords, labels, warnings. They started the discussion 3 or 4 years ago. The law was proposed in its nearly final version at the end of the last year. So it takes some time. And when we think about the policy cycle, the question becomes how to measure the speed how to measure the efficiency, and how to marry this concept of speed and efficiency with the need to give it a proper consideration, how to ensure that all the stakeholders are consulted, how to ensure that regulation is drafted in a proper way. Another problem with command and control traditional regulation is regulate and forget mindset. What do I mean by this? There is a problem. We have two options normally from the point of view of regulation. Either we intervene or we leave it to the markets. So when we decide to leave it to the markets, sometimes it drags for too long before the regulators are actually able to assess the risk and say, oh my God, no, it shouldn't be with the market, we have to regulate. This is the first point. Another point is, let's say, there is a law on the consumer IoT protection. Does it mean that we have to forget about it for a few years? No, no, no. The idea of the policy cycle means that we have to reassess this as technology develops. We have to reassess it with each new risk posed. But this is still not in the mindset of traditional regulators. Even the idea of policy cycle is heavily criticized, by the way, as some of the linear thing. Another problem, which is contrary to conventional wisdom of anticipatory and flexible regulation, is actually a misalignment of regulation in various areas. Like, for example, I quite like the EU cybersecurity certification scheme. That was brilliant. The idea, the proposal on AI regulation by the European Union is actually quite good. And both of them have certification schemes. And there is already some critique that at the first glance, they are sort of aligned on paper. But if you look at the nitty-gritty details, they are actually not aligned. I'm not going to the details here, but there is enough critique and literature on this. So even with the best attempts, there is still some misalignment. Another problem is a big choice between sector-specific regulation and general frameworks. For example, if I want to regulate medical IoT devices, some wearables, am I going to do this through medical regulation? Am I going to do it like the European Union did for some of the devices, of course, only for some of the devices, with the wireless via regulatory instruments that regulate wireless equipment? So how am I going to go about this as a regulator? Or am I going to mix these approaches? And most of the time we see these mixed approaches, but then again, the point comes to alignment. How do we align here? And another big point is rather the last one, for me at least. It's still the mindset, maybe the concept of physical safety and regulation on physical safety somehow being separated still conceptually from regulatory responses on to the risks of emerging technologies such as cybersecurity risks, privacy risks, ethical risks. But they are coming together a lot. In the examples of self-driving cars or children's toys, the physical safety includes cybersecurity risks, but sometimes this concept is still hard to grasp. Do I still have some time? I don't know how, 2 minutes, right? And then it goes on the international level. How are you going to implement your regulation if there are differences in regulatory approaches across the border? How do I stop devices which are not safe being supplied in my country? And also, what are the incentives for various countries to actually harmonize their approaches? You have a competitive advantage on the one hand, but on the other hand, the threats and risks are sometimes too high. And we can see how this develops, for example, with lethal autonomous weapons and, on the UN level. There are no hard instruments yet, but there are some principles that are still being developed. And the question remains here, is this international regulatory harmonization is even possible in this increasingly fragmented world? And the big deal here is that many horses are already out of the barn. Sometimes when I talk to AI people or AI developers, they tell me, but I don't know what's in my box. Actually, explainability is good, but sometimes I just simply cannot explain because we cannot go back and redesign. Well, maybe this is a lame excuse, but still, how do we ensure that we stop new horses being out of the barn, how to fix these current problems while creating these forward-looking solutions which everybody is talking about. So to conclude, I'm not that pessimistic. So not so pessimistic outlook here. Many technologies are indeed still emerging, and so regulatory solutions are developing. So the way forward would be the risk assessment and prioritization of regulatory interventions based on this risk. And if you're interested, I would really like to advise you to look at the EU AI regulatory approach, which is based on the risk, like unacceptable risk, high risk, so, and the regulatory response and regulation would be based on how much risk particular application of this technology or development of this technology creates. The second point for way forward is to understand the convergence of technologies while understanding the sectoral impact, understanding that, for example, facial recognition in one field would be different from facial recognition in another field. We still need to understand the convergence here. Another way forward would be the outcome-focused framework. And there is a lot of talk about this, but I still have not seen how it goes in reality. But what do I mean by outcome-focused framework? You want to create the outcome. For example, this should not be as risky as it is. I want you to do this and that, but leave to the industry to decide how they are going to go about this as long as they can produce this outcome. And last but not least, the idea of regulatory sandboxes. They have been already quite successfully tested in Japan and Singapore, and I know that Spain proposed a regulatory sandbox in Europe, which might become a pan-European pilot project. I think it should start in about a couple of weeks, so I don't know how it will play out. So what is the regulatory sandbox? The innovators, the companies, they can come to the country and play with technology, play with development, but also provide the data to regulators so regulators can assess the risk. Regulatory sandbox framework in Japan from 2018 to 2021 attracted more than 100 companies, fed some data to regulators to decide on regulatory outcome. There is fintech regulatory sandbox in Singapore as well, and I know that I don't have any time left, so thank you. Would be happy to answer any questions.
We'll be very traditional with this panel, so we will have all the speakers give their presentation and we'll group the questions at the end. So after having heard about emerging technologies, cybersecurity, and physical threats, we are now going to hear about emerging discourses and cybersecurity and ideational informational threats. So I think you will be speaking.
How do I just click? Okay. Hello, everyone. Good afternoon. My name is Alyssa. Today, I'll be presenting on cyber defense and domestic security, the Brussels effect and regulation of hate speech and disinformation in the digital sphere, which is a paper I wrote with Professor Bacon. And for the sake of time, I'll just dive right into it. I'd like to begin with these two excerpts from the EU Code on Countering Illegal Hate Speech Online from 2016, and Twitter's announcement that they have permanently suspended Donald Trump from their platform. The arrow I added there is not arbitrary. There is a connection, which will be explained in this presentation. It's important to note the bolded parts of each excerpt. Basically, in the code, it says the IT companies will have in place rules or community guidelines clarifying that they prohibit the promotion of incitement to violence and hateful conduct. And when Twitter announced they were permanently suspending Donald Trump, they determined that these tweets are in violation of the glorification of violence policy, and the user @real Donald Trump should be immediately permanently suspended from the service. So basically, the banning of Donald Trump from social media was a major event in international relations. Never before had we seen a global political actor get kicked off social media by several social media platforms. And it was also an unprecedented event in the fact that Donald Trump had basically incited an insurrection using Twitter. And basically, nothing is more threatening to domestic security than trying to overthrow a free and fair election through the cyberspace. And what I found really interesting as an American, in case you couldn't tell from my accent, that the banning of Donald Trump can be traced directly back to the regulatory power of the EU. And the philosophy and subsequent infrastructure that justified this decision can be directly traced back to EU institutions. So basically the EU protected American domestic security better than America did, in a way, I argue. And so the main question we're trying to answer is, to what extent is the banning of Donald Trump an expression of the Brussels effect? And that's the theory put forth by Anu Bradford in the book by the same title. Basically, the EU has a culture of defensive democracy, which I will elaborate upon later in terms of hate speech. This culture was uploaded to EU institutions and expresses itself in a desire to regulate hate speech online. And through EU institutions, this culture has reached American tech companies. So now I'm going to try to give a super brief summary of Anu Bradford's Brussels effect. It is an entire book, and this is not super thorough, but just for some background. Bradford argues there's two reasons why the EU has been able to become a global regulator. The EU has built the institutional architecture to be able to leverage their market power towards outside actors, and the EU has intertwined the politics and economics of a stringent regulation agenda, allowing for the belief that high regulation leads to a better society overall. This is very different from America, which she explains in her book, and I don't have time to get into later. But she ascribes the Brussels effect to 5 factors. The first one is market size. The single market of the EU is what gives Europe the power of market size as global regulators. Basically, the EU can threaten to cut off access to its market to force economic actors to comply with their standards. Regulatory capacity. There has to also be the political will to be a regulatory force. This is why, with America's relative market size, there isn't the political will to be a regulatory force. So you don't see a Washington effect. This political will translates into the development of institutions, legislation, and bureaucratic capability to handle regulation. And alongside that, regulatory capacity alone is not enough. There must also be the political will to deploy stringent standards, to make them, and be capable of creating and enforcing them. And then the last 2 aspects of the Brussels effects are that the EU will regulate inelastic targets. Bradford gives the example of capital markets and consumer markets to highlight the difference. Capital is elastic and can be moved around to kind of avoid regulation, but consumers tend to stay in the same place, like in the EU. And non-divisibility, and so this is kind of the final punch that gives the EU its regulatory power. All 4 of these previous aspects combined means that the EU can create standards for outside actors, but they don't ensure the globalization of EU regulation. EU rules become the global standard when there is non-divisibility, legal, technical, and economic, which basically means it's legally really hard to avoid EU standards. It's technically really hard to avoid EU standards. It's also really expensive to try to avoid them too. So that's a very brief summary. Please read the book, it's really cool, I really like it. And so just to give some background on the events of January 2021, the Capitol riots. So on January 6, 2021, we saw thousands of Trump-supporting protesters storm the US Capitol building in an attempt to overthrow the election of President Joe Biden. In response, Twitter banned the account of Trump permanently to prevent risk of further incitement of violence, and this would cause several other American media platforms to follow suit. The reaction was pretty much negative from policymakers, but Americans and Europeans had very different reactions. So Americans were just like, this is censorship, boo, in general, but European lawmakers had a very specific response. So for example, Angela Merkel said the fundamental right of freedom of expression can be interfered with, but along the lines of the law and within the framework defined by the lawmakers. And Josep Borrell said it is not possible for this regulation to be carried out mainly according to rules and procedures set by private actors. This is something Americans completely disagree with. Americans have a super libertarian approach to free speech. I pulled this quote from the US Supreme Court to highlight this. In one of their rulings, they said that amendment rests on the assumption that the widest possible dissemination of information from diverse and antagonistic sources is essential to the welfare of the public, that a free press is a condition of a free society. And Bradford points out in her book that this is different from Europe because, unlike the United States, the EU does not view the right to hate speech as a valuable part of public discourse. And this is where we get to defensive democracy. There's a quote from the European Court of Human Rights where they emphasize that there has to be some compromise between the requirements of defending democratic society and individual rights. The US does not have a political history of dealing with fascism, Europe does. And because of these divergent political histories, the EU takes a completely different approach. While the EU is committed to freedom of expression, the EU also understands the threat that certain kinds of speech can threaten a free and democratic society. So violent speech is restricted in order to defend democracy. So the Brussels effect on online hate speech, there's a section in her book on it. Bradford makes the distinction between de facto and de jure. So this would be an example of de facto Brussels effect where private companies are complying or adopting EU standards as general policy versus EU standards being codified into formal law. She does make the note at the end of her section on this that there isn't technically a de facto or de jure Brussels effect on hate speech, because at this point, even though the Digital Services Act has been passed, it hasn't been fully implemented yet. So there's only the voluntary code on countering illegal hate speech online. And I've listed the current signatories here. What's interesting though is that changes are occurring in companies beyond the scope of the EU. So I put this list here of all American tech platforms that took action against Trump or Trump-related accounts following January 2021. Sorry, I always mix up the years when it gets to January. Amazon, Apple, Discord, Facebook, Google, Instagram, Pinterest, Reddit, Shopify, Snapchat, TikTok, Twitch, Twitter, and YouTube. The bolded companies are outside the scope of the EU, meaning that the Brussels effect cannot fully explain all the changes in hate speech policy going on within tech platforms, although it can explain some of it. So this is a timeline. It's a little messy now that it's up there. But basically in 2015 is the start of it all, where Heiko Maas publicly shamed Facebook for having really relaxed hate speech rules. We have the passing of the code in 2016. In 2018, this is an important part of American, I guess, fascism. We had the Unite the Right rally in Charlottesville where we had thousands of white supremacist protesters donning tiki torches, shouting, "Jews will not replace us," gather in Charlottesville. And in 2018, you see Instagram, Snapchat, and Dailymotion join the code. You see hate speech removal rates rise to 70% for signatories. 2020, we had the civil rights movement, Black Lives Matter, and the EU introduces the Digital Service Act, and TikTok joins the code. And by 2021, we see the permanent suspension of Donald Trump. So this is kind of for you to visualize how the EU has gently been ushering American companies through this journey to protecting people. And this is the introduction to the code. The most important part of this is showing that the IT companies that are involved in the code were actually willing to do this with the European Commission. So what's italicized is the IT companies also share the European Commission's and EU member states' commitment to tackle illegal hate speech online. And this is just a quick rundown of what the code set as standard practice. These rules exist across every American tech platform today, but they did not exist to the extent they did before the code was passed. So basically, the first aspect is rules. The EU told tech companies, create community guidelines clarifying that you prohibit the promotion of incitement to violence and hateful conduct. Make sure people are able to flag offending remarks. Remove it if it's actually offensive. And this code has been really, really successful. Flagging rates have gone up, and even more impressively, removal rates in signatories have risen from 28% to 70% in 3 years. And kind of the argument for why these changes are happening in non-signatory companies are because of this one part of the code, which is today the removals of hate speech content are clearly presented on a regular basis. Basically, the code asked IT companies, be transparent that hate speech is not okay and we will remove it from the platform. And because this wasn't clear before the code, it wasn't in public discourse, but with transparency, it entered public discourse. So it wasn't just a question anymore about how tech companies will regulate hate speech internally. It becomes a question of the value of hate speech in the online world and society overall. And there's also the development of American tech companies suspending accounts, which wasn't in the code. And so you can argue that they're not just following EU standards, they are adopting the philosophy behind it and making their own rules based off of it. Next slide. So now I'd like to kind of highlight some changes from non-signatory companies and their hate speech policy. This is like my most favorite part. I'm going to take off my presenter hat and be kind of American here. So in 2015, Reddit's hate speech policy was really wonderful. They said, it's okay to say I don't like this group of people. It's not okay to say I'm going to kill this group of people. Nice. The reason we're careful to restrict speech is because people have more open and authentic discussions when they aren't worried about the speech police knocking down their door. So you can see this is super American libertarian. Just, yeah, hate speech, really good for some reason. Anyways, by 2018, they updated their violent speech policy and they said, ensure you provide context to the viewer so the reason for posting is clear. Basically, if you're going to post hate speech online, make sure it has context, because that makes it better. And finally, by 2020, we see ultimately it's our responsibility to support our communities by taking stronger action against those who try to weaponize parts of Reddit against other people. Communities and people that incite violence or that promote hate based on identity or vulnerability will be banned. That is a big shift from 2015 to 2020. From American libertarianism to something that resembles more of European defensive democracy. And now I'd like to draw your attention to Tumblr. In 2010, I went through some GitHub repositories. They had policies on hate speech and defamation. Basically, even more American than Reddit, they said, we prohibit hate speech and defamation, and then only talked about defamation. And then in 2014, they would update it to say, while we firmly believe that the best response to hateful speech is not censorship but more speech, we will take down malicious bigotry as defined here. We encourage you to dismantle negative speech through argument rather than censorship. So again, demonstrating a commitment to American, let's talk to people doing hate speech. Let's try to talk it out. By 2020, we draw lines around a few narrowly defined but deeply important categories of content and behavior that jeopardize our users, threaten our infrastructure, and damage our community. We will suspend counts or remove content without notice for any reason, but particularly to protect our services, infrastructure, users, and community. And again, you see a shift from very American philosophy to something resembling European defensive democracy. Am I good on time? 2 minutes. Again, these are just examples from newer tech companies where you don't even see a progression. You see them come into the digital economy with community guidelines, with provisions against hate speech, reflecting the same philosophy of we will ban you, we will remove this speech to protect our community, defend our little online democracy, in other words. And so this leads us to normative explanations beyond just the Brussels effect. We pulled from the theory of Europeanization from Borzel and Riese. Basically, we can argue that there has been normative diffusion around hate speech facilitated by the Brussels effect in the digital economy. We have a direct influence mechanisms through the Code on Countering Illegal Hate Speech Online, and emulation, where companies who aren't directly interacting with the EU looking for best practices to control hate speech on their platforms, and they find that EU standards are working. We also have a perspective from human rights normative diffusion. You have the process of argumentation, where Heiko Maas was like, hey, we will regulate you on a parliamentary level if you don't manage hate speech on your platform. Instrumental adaptation would then begin for American tech platforms in the dialogue that began between the EU and US social media sites after Moss was like, boo. And that eventually birthed the 2016 Code on Countering Illegal Hate Speech Online. And institutionalization, habitualization, hate speech removal is not just seen as standard practice, but hate speech is seen as a threat to the health of the online community and not a part of valuable discourse, which is a huge shift from the original philosophy of these American tech companies. And finally, this is the last slide. Human rights socialization. Norm breakers are rejected from the digital economy. So this is from Risa and Sikink. Basically, adhering to human rights norms in their theory is how actors enter the international society. But if we look at tech companies as an international society, if you don't follow this norm of removing hate speech, you will be rejected from the society. So the American free speech app Parler only survived almost 3 years before Google and Apple removed the app from their stores and Amazon dropped the app from their hosting service in 2021. And another American free speech app, Gab, would ultimately be dropped from multiple web service providers and hosting services due to promoting hate speech. Apple would reject its application to the Apple Store, Amazon would drop it, and revenue for the company is now reliant on donations. And these are just two examples of hate speech apps being rejected. And that's all I really have to say. This is the bibliography, but thank you guys for listening.
We'll stay in the transatlantic sphere with Simona while the PowerPoint is being set up. I already tell you, you'll be very popular in Brussels. Now more to the security space and the NATO dialogue.
Yes. Yes, thank you. Hi, everyone. I'm Simona. I'm a research fellow with IISS, that is the International Institute for Strategic Studies. Our institute focuses on strategic studies. If you ever want to go online and think, how can I measure the balance of power between countries? We have a solution for you. It's called the military balance. Go check it out. What I will, and just to not be in doubt, I put it up on the slide for you. What I do at IISS is essentially, why don't I do this, because I like to move around a little bit. What I do at IISS is I'm leading the newest initiative of the Institute, which is focused on defense innovation and emerging and disruptive technologies. That's a really fancy way of saying, how do militaries think about the uptake of emerging and disruptive technologies like artificial intelligence and machine learning, like biotech and human enhancement, and so on and so forth, quantum and so on. So how do they do that? What kind of processes do they use? What are their references? And how do they perhaps contemplate regulation when it comes to the use of these technologies and assessing risk? And the things that I'm going to talk to you about today are roughly the results of a year-long project that we've been implementing and that my team has been involved in, looking at over 100 interviews with civilian military decision makers across all the transatlantic countries, that is 34 transatlantic countries. And what we looked at is, one, well, how are these countries thinking about the adoption of these new technologies that are essentially dual use? Their progress is driven by the private sector. How are these countries thinking about the adoption of these technologies? And second, what is the status quo? What is the state of play on these adoption efforts? What conclusions or what lessons can we draw from what they are doing so far? And what we came up with is this very, very colorful map. You'll excuse my very big talent in displaying information, and visualization is a critical part of the presentation. But what the map is meant to suggest to you is that we couldn't be more fragmented even if we tried. And it's interesting because we're actually trying not to be fragmented at all. We're trying to fight that traditional fragmentation when it comes to European defense and European military capabilities. So to the question of whether today, right, 5 years after we've started officially our efforts to adopt artificial intelligence and machine learning in defense, where is Europe? Well, Europe looks like this. The countries in red are countries who have already adopted, are well advanced in their strategic development, their strategic thinking and planning in terms of how to adopt artificial intelligence and machine learning in defense. And you'll see there are only 2 of them. And the UK just recently joined that very select group, right? These countries have implemented a wide variety of processes, new institutions, new tools, new instruments, including funding instruments to support the adoption of artificial intelligence and in defense. However, if you look at the rest of Europe, you'll notice that we are at very, very different stages. Most of us have so far completed some sort of strategy, plan, roadmap, governance outline. The reason I'm using all these terms is because that's what you'll find out there related to the use of artificial intelligence, period. Most of these plans are actually for civilian use and either specifically refute the use of AI in military applications or just leave a complete blank there. So that is the situation as it was measured in May 2022. You won't find many differences in the meantime. And then we started looking in a little bit more detail. Okay, so you've got a strategy. What does that mean? What are you exactly implementing? What are you adopting? What we found is that the vast majority, in the 90% scale, the majority of these projects were purely in R&D. Furthermore, the vast majority of this majority were in S&T, so the beginning scale of R&D projects. Some of them were completely paper-based, so they were studies about how we can use artificial intelligence in defense, not actual projects that piloted an algorithm into something that can be considered a military application. Furthermore, again, the vast majority of these projects, and unlike other countries we're looking at in the world, like the US or China, or even to some degree Russia, the majority of the projects that we're seeing displayed across the European spectrum are linked to some sort of long-term program of record. It's the future air combat system, it's the main battleground combat system, it's the whatever future military capability that has a delivery time sometime in the mid-2030s to early 2040s. That's a very long time, very long-term projection for the adoption of technologies which everyone across the board will tell you are moving so incredibly fast. To be very specific, the refresh rate in the digital realm right now, so digital software, renews within 3 to 6 months. Companies, the companies that were mentioned here earlier by Tatiana and Elisa, they have the ability to push out new software and new patches in real time to their entire enterprise system. Those are huge platforms, and they still manage to do it. In the military, that doesn't exist. not in Europe. It does not exist, period. Doesn't exist. Third, the thing that we've noticed is that one of the really interesting aspects of how Europeans are planning for the adoption of AI and machine learning in defense is that it's completely shaped their organizational, the structure of their organizational ecosystem when it comes to innovation. What does that mean? It means that we're very much interested in investing once technologies have been de-risked. If you look at the investment across Europe, be it state or non-state, in AI applications that could potentially be extended to the military realm or to the security realm, it's very late stage. So we take a very different approach to what venture capitalists would do. Is if it's going to give me money, is going to get me a surplus, then I'll invest in it because it's going to boom. Second, the second really interesting side effect of this is that it's creating this way of organizing our adoption of AI and ML in defense is creating some really interesting expectation gaps. Most of the strategies that we have read across all of these countries have a language that is built on urgency. It's urgent that we act now to adopt, to regulate AI, to do something about it, to counter the threat of AI, right? But when it comes to actual implementation tools, what we notice is they have a very slow path to development, and they are very incremental in their application. Take, for instance, the UK, the latest comer in the defense AI strategy realm. It says it says, we need to be ambitious. And then the second line is, but in the midterm, we will deploy AI for intelligence, surveillance, reconnaissance, which is literally the lowest of the lowest hanging fruit for artificial intelligence algorithms today. And even that might be might cause some headaches, mind you, for some of our European countries. So then we asked, this is what the situation looks like at the national level. What role does the supranational level, like the EU and NATO, play in helping with soft or hard regulation of artificial intelligence? The lethal autonomous weapons conversation has been mentioned here before. And that was something that truly monopolized the European discourse when it came to AI. We're not talking about how to figure out whether our military personnel are ready for deployment apps. We're talking about how the future Terminator is coming after us in Skynet. We're not interested in anything here. We're interested directly into here. And that was really problematic because the entire regulatory discourse was focused on trying to cut off or preventively ban as much as possible that risk from even happening. For instance, we're in Belgium now. The Belgian parliament has a law which says they prohibit lethal autonomous weapons. It's prohibited to invest in R&D for that purpose. The European Parliament tried to pass a similar resolution in 2018 to flat out and blanket ban investment in any kind of technology that would enhance autonomy beyond a certain point. So these are all effects of that discourse which focused very much on the higher end of the spectrum of the use of AI and autonomy together, rather than thinking through the steps of, not everything is AI. We have a lot of software in our military capabilities, and not 99% of it is not artificial intelligence. So how do we cope with the challenges of this software without necessarily thinking Skynet and Terminator is after us? Good. So to the effect of meeting that public demand and policy demand, and I highlight policy demand, what we've actually seen coming out of the European Union and NATO, the European Union has been pretty much covered here, and the European Union is the only one who has the authority and the legal standing to implement hard regulation. But what we have noticed, in fact, is a very rapid proliferation of efforts, both within the EU and NATO, to softly regulate artificial intelligence. The principles of responsible AI for defense have been mentioned here, right? But they're not the only ones. If you look more closely, you have the NATO Science and Technology Organization, who's investing a lot of their projects, actually. Over half of their projects are actually right now studies that look into potential risks generated by a host of emerging technologies, or efforts to think about architectures and designs that could mitigate those risks in the future. And you have that from AI in the realm of cyber all the way to full autonomous capabilities and how those can be employed. In the European context, the European Defence Agency has attempted a similar track, right, where we can go both, in the EU and NATO, go from, the attempts to technically standardize the algorithms themselves, the testing and evaluation process. So standardization, not just of the technology itself, but the organizational processes around it, such as let's all do agile development of artificial intelligence for defense. Let's all learn the lessons and best practices of industry, of private industry, and how they are so agile at developing these algorithms and scaling them so fast. But of course, what the question then becomes is, what is the scalability of these efforts? Because right now we see them, they are attached to specific agencies, right? The EDA or NCIA at NATO, or NATO Allied Command Transformation, or others, right? So they are vertically trying to integrate soft regulation of AI. But there's no scalability horizontally, which is anyone who will tell you what data does and AI does is moving that data on the horizontal. This is not just, I gave you the policy look earlier. This is the look of what Europeans are currently thinking about the use of AI in defense applications. I deliberately didn't choose ISR because it's fairly neutral, and quite frankly, it doesn't elicit a lot of interest, although it's here and we can use it now. No, I've chosen to focus on meaningful human control, which is a very controversial principle of soft regulation of lethal or autonomous weapon systems. And if you look at the map, it will show you what the current position of the member states are. What I would draw your attention to is not just how many colors there are there, and I'll challenge you to find more than 3 countries with the same color, but the problem is that we do have a lot of these countries, roughly half of these countries are engaged in projects, R&D projects of AI and ML without actually having voiced a position on any of these issues. So we're falling way behind when it comes to that. Not only that, we're also falling behind on some of the building blocks of anything we want to do when it comes to AI and digital transformation. That is a comparative picture of how different countries, both friendly, allied, and potential adversarial ones, are approaching digital transformation or defense data management systems. And you'll see that they're far more advanced at the first glance in defense than they are in their general approach to national data strategies. But there are very, very big differences between the level of institutionalization and the safeguards around defense data strategies in these countries. And in Europe, it's very much fragmented along national lines with little efforts to scale the exploitation of that data across borders. And I'll finish on a gloomier note. But, yeah, Frederick knows me, so he's not surprised, right? My conclusion from the study and from the data that I've seen is that we have a very, very misaligned approach to how we deal with the adoption of AI and machine learning in defense, including its regulation. It's not just misaligned with what it needs to be to lead us to the outcomes that we want out of these technologies, but also it's misaligned with practices that have been generalized within private industry for the last 20 years. Amazon, Apple, Google, anyone in the big tech community started to generalize the use of data and platforms roughly around 2000. Our militaries have not even seriously started to do that today, 2022. That's the big gap that I'm talking about, not just the money. That's a even bigger gap, right? So this misalignment is essentially acting as a big obstacle to our efforts, however genuine they are, to adopt AI and ML in defense. Moreover, even if NATO and the EU have legally the authority or the instruments to soft regulate the adoption of these and the introduction of these new technologies into defense, they are fundamentally underused by the nation states. And outside that use by member states, their authority will ring hollow, right? So that reduces the remit of their effective regulatory power, soft regulatory power over defense applications of AI in the midterm. And what that means at the broader level, right, at the strategic, let's see, the forest level, is that both of these institutions, as well as the member states, are essentially very ill-placed to rapidly, we've increased defense budgets, right? But with this approach to how we adopt AI and how we approach defense innovation more broadly, we're just so ill-placed to exploit that influx of cash that we're seeing in defense across Europe. Thank you so much for your attention. Very much look forward to your comments. Thank you.
Thank you very much. And not to lose any time, we have 7 minutes for questions, so I'll do one round of questions. So if you have a question, please go for it now. Yes. Either elevate your voice or come pick up the microphone.
Thank you. So Julien Cabay, I'm a professor at ULB. I got a question for Elisa. It goes actually, it's a twofold question. I was really interested, and I think it's quite convincing to see the difference between like the policy regarding hate speech a few years ago and nowadays on the different platforms. So the question I have is, the first part, how did you, in your analysis, included maybe the evolution of the secondary liability of these platforms? Because from a legal perspective, the liability and safe harbor provisions were actually adopted in the early stage and early days of the internet. Google didn't exist, all these platforms with interactivity didn't exist, so it evolved over the time, both in the US and in the EU, and in particular through case law. So the provisions from the law did not change. So if we were thinking from an EU perspective, that would be more a Luxembourg effect than a Brussels effect if we were taking this into consideration. So I'd like to know a bit, how did you see that, or did you include this in your analysis? And the second aspect of the question is, how would you maybe, I'd like to have your thinking on if there is this kind of Brussels effect, or whatever we can call it, but it's obvious that there is this change in the policy. Is there any kind of technical explanation we could imagine stating that, for example, if you're a company operating on the internet in, let's say, all over the world, you should probably, it's probably easier to adapt your technology for monitoring the content in line with one type of legal provisions rather than having like different type of systems, because actually it's more complicated to monitor according to different possibilities you would have under the different jurisdictions, whereas you are actually having one technology operating all over the world. So these are two questions, but they are related, and I'd like to hear about. Thank you.
It's on. Hello. Yeah. Can you hear me? Oh, sorry. Basically, when I started my analysis, it started with looking at the Brussels effect, the book, and looking at the section on online hate speech. And she made the beginning arguments that there could be a Brussels effect on online hate speech. And I started just kind of digging around on the internet, as I do in my free time. And it's hard to say whether it's an expression of EU regulatory power or EU normative power. That's something I'm still trying to kind of contend with, because there is the argument that, okay, these tech companies don't want to get cut out of the EU market for profit reasons, but these tech companies also really do like the standards of the EU when it comes to hate speech. So I can understand kind of your question. It is kind of hard to determine whether you could attribute this solely to regulatory power or solely to normative power. Did you want to? No. I think, yeah, that's about it. I don't want to take up too much time from but yeah.
I see that our keynote address or concluding words address has arrived, so I will maybe wrap up the final panel. Thank all the speakers for your contributions. I guess all the speakers will be at the closing reception, so the same rule applies. If you have follow-up questions, catch them at the reception. And again, a round of applause for all. And might I invite His Excellency Ambassador Yetsushi to join the stage.
Thank you very much. Professor Masahiko Gemma, Vice President of Waseda University, and Professor Anne Weyembergh, Vice Rector of University Libre de Bruxelles, distinguished speakers and guests, ladies and gentlemen. I'm extremely delighted today to have been invited and give this opportunity to make my concluding remarks here. This conference is the first to be held in an in-person format after a 3-year break due to the COVID-19 pandemic over the past 2 years. I would like to express my appreciation to all those who have been involved in the organizations of this conference. Before starting my closing remarks, I'd like to say a few words about what's ongoing in Ukraine. As you all know, 6 months have passed since the Russian aggressions against Ukraine began. Since then, we have been deeply shocked by the large number of casualties, including innocent civilians. We have to stress that Russia should end its own starting war immediately, and on this point, Japan is united with Ukraine and all the partners, including the European Union. Today, I would like to take this opportunity to express my views on 3 points. First, appreciations for Waseda University's activities, including this conference. Second, the main digital policy trends in Japan and the EU regarding today's conference theme. Thirdly, expectations for future activities relating to new technologies and regulations. Firstly, Waseda University, with the cooperations of universities Libre de Bruxelles, ULB, established the Waseda Brussels office, WBO, in Belgium in 2016. Since then, it has served as a bridge between Japan and Europe and organized 3 international conferences on timely topics. I would like to express my sincere appreciations to Waseda University and the WBO for their activities, and especially for their active promotions of academic exchanges between Japan and the EU. In particular, today's conference on the theme of new technologies and regulation in Japan and Europe has brought together science and technology perspectives with public policy with the aim of interdisciplinary discussions. I am convinced that it has successfully provided many insights for you all as experts, practitioners, and officials in many fields. The EU has been expanding its role in leading global standards in various areas, and we hope that Waseda University and the ULB will continue to actively contribute to academic exchanges between Japan and the EU in the future. As a second point, discussions throughout today's conference focused on the ever-evolving relationship between digital technology and society. We are well aware that the increasing digitalization of our society and the economy, also known as the digital transformations, has become an important policy priority for both Japan and the EU. The Kishida administrations in Japan has been promoting the development of digital infrastructure and other related measures to boost digitalizations under the visions for a digital garden city nations. In parallel, the von der Leyen commissions and EU member states have been promoting various initiatives under the policy priority of a Europe fit for the digital age. On the basis of our current shared policy priorities, at the Japan-EU summit in May this year, we launched the Japan-EU Digital Partnership to work together on the digital transformations by identifying areas of common interest. This aims to promote Japan-EU cooperations in areas such as data flow, digital trade, next-generation telecommunication standards, semiconductor supply chains, AI, and cybersecurity and others, in order to realize economic growth and a sustainable digital society based on high-quality digital infrastructure. In this context, it is very timely that today's conference has focused on the relationship between digital technology and society. I'd like to thank everyone involved in these discussions. Ladies and gentlemen, finally, as a third point, I'd like to mention future expectations regarding technology and the public. As we all know, new technologies that were once emerging, including digital technology, have dramatically improved convenience in our societies and enriched people's lives. Today, emerging technologies such as Internet of Things and AI are used in a variety of areas and have become deeply embedded in our societies. On the other hand, the digital transformation will also pose various challenges. As discussed today, challenges such as AI and copyright, data privacy, and cybersecurity are some of the cases that exemplify how digital technology has not only made our lives more convenient, but has also brought forth new social challenges to be solved. We need to establish appropriate rules to ensure that digital technology is useful to humanity. Taking a holistic point of view on science and technology, in addition to digital technology, has had a significant impact on human society. We believe that emerging technologies need to be designed and managed so that they are created and utilized in accordance with our universal values of freedom, democracy, respect for human rights, and the rule of law. Currently, in practice, digital technologies and other emerging technologies can be used easily across disciplines and borders and for various purposes. For this reason, it is very difficult to define their governance and set regulations in specialized disciplines, specific countries or regions. As interdisciplinary and international approach is crucial when it comes to addressing the public challenges arising from digital technologies, such as data free flow with trust, data privacy, intellectual property rights, digital currencies, and disinformation. I hope that today's conference has provided one such opportunity for Japanese and European professionals from many fields. All of you who participated today are well versed in the technical and regulatory aspects, and therefore I look forward to your valuable input and insights. Ladies and gentlemen, I would like to conclude by expressing my hope that today's discussions on the relationship between digital technologies and emerging technologies and regulations at the fourth Waseda Brussels conference will lead to further development and enrichment of academic and scientific discussions between Japan and Europe. At the same time, I'm also optimistic that they will lead to greater digital business cooperation and policy collaborations between Japan and the EU. Thank you very much for your attention.
And so, ladies and gentlemen, this concludes our conference today. Thank you very much for attending. Thank you very much to all the speakers for all the wonderful presentation we had today. And I think we had now a lot of things to think about in the coming days, months, and years. And I hope that it will also bring up new collaboration, research projects, and things like that. Waseda Brussels office is at your service to do so. Thank you very much. And now enjoy the cocktail. And we can discuss a little more around a glass of water or maybe a coffee or something else. I don't know. Thank you.